Alright guys, so I'm so excited to bring you this full JavaScript course where we're going to look at all of the basics of JavaScript. I wanted to compile all my information together for this course, and you know what? I think you guys are going to absolutely love it. It's all free. There's no caveats right here. It's all in this video. You're going to get tons of content. You're going to get the history behind the language. You're going to get just so much more about this language that's incredible, right? So we're going to go from strength to strength at this point, and hopefully this will launch either your programming career, and I've got plenty more on programming itself, like in your mind, and not just the code itself. And that's where I'm going to bring real value into your life. I wish I had a course like this when I was starting out. I wish that the concepts behind the language are also introduced, not just the language itself, because the concepts and the way in which a language works is the way that other languages also work in a very similar fashion. And without that understanding or that quick version of history, you'll have to sit through hours and hours of things, constantly with reading materials. And do you know how many people buy books this big? They're massive, they're huge. They take hours of your life up, right? Okay, so yeah, all right, this is a 6 or 7 hour long total freebie for you. But what I want you to get excited about is the fact that I will also be launching from this a brand new course that will be a more advanced version as well. And I'm going to give you more details on it later, but right now you guys need to get those basics in your brain, and there's also going to be more and more content that's going to come out. It's amazing. And what I've got planned for you and your future career, you can't afford not to take these types of risks, these types of things. Take the time to invest in yourself. I mean, literally, it's free, it's self-development, it's also learning and growing in one of the fastest paced industries in the world. Once you know the concepts, once you know the patterns and the basic things, guess what? You will grow in this industry phenomenally fast. Any product you want to make, look how you can scale it. Make a product in JavaScript. You can make apps now in JavaScript with a fully native user interface. Now, these things will come. Right now you're on the basics, but once you learn this language, it's scalable. It's one of the most scalable languages you can write. It's the #1 programming language in the world right now. And pretty much all the employers are asking for JavaScript. Where are most employers? Online. Where are their storefronts? Online. Running on the client side, which you'll learn about that. And of course, they want the JavaScript. Now JavaScript's on the server as well. You can run JavaScript like PHP. You can run it actually on the server. How amazing is it that you can learn one language and it scales over so many platforms? You can build real-time applications in about 30 minutes. Now, I have got so much exciting things for you. I've got such a great future for you, and it's going to be unbelievable. You're not going to have to invest tens of thousands into an education, and I'm going to give you all this content. But what I first want you to do is, if you really believe in this, and you want to support this Avelx family, and you want to support this message right now, what you need to do is hit the subscribe button, hit the ding dong bell so you get notifications, and please join us on Avelx and Avelx Academy. Both of these things are going to be platforms that are going to build your knowledge and share your knowledge. We're going to create courses together in real time. You're going to talk with all the community members. We're going to talk about these things. We're going to have a great community there so that when you do face a problem, you will get an answer. We've all had those things. Well, just post it on Stack Overflow. How long does that take to get a response? Well, we can get a quicker response. So the whole point about this is we're building a future platform for all developers. I want you to start with your journey here because you're right as a beginner, but this isn't the only course you should take. There's also Programming 101 as well. We'll get to it, but right now, I want you to enjoy this course. So let's get on with the course. So we're going to take a look at the history behind JavaScript. And the reason why we want to do this is because we want an insight into how there is a lot of names for this one language. There's many names such as JavaScript, LiveScript, Mocha, and also you've got JScript and ECMAScript as well. Why do these names exist, and what happened with the history of this language? Well, first of all, this language was created by a guy called Brendan Eich in 1995, and it was created in 10 days. Its development code name was Mocha, under the supervision of Netscape and Sun Microsystems. Netscape was partnered with Sun Microsystems that designed the Java language. Now, he ignored the boss's instructions to design the language based on Java. Instead, he chose Scheme and Self. These languages are not known to us today, but Brendan liked these languages because they were simple and easy to use. And that's why JavaScript is so easy to use today. When it was released, the language was called LiveScript. So Mocha was the development name. Now, when it's finally polished up and it's presented in the Netscape browser, it was called LiveScript. Then it was renamed to JavaScript as a joke to Sun Microsystems because the only part of the Java language they used was the name. Sadly, even though it's a joke, many people have been confused by Java and JavaScript being two very different languages. Or perhaps maybe Sun Microsystems wanted their mark on that language. Then Microsoft saw this and reversed engineered JavaScript. However, the name JavaScript and LiveScript was trademarked. So they called it JScript and integrated it into the IE3 browser in 1996. The problem is we have all these different browser vendors giving the same language different names. Also, the whole point to the web is that we create once and distribute everywhere. So we needed a standards body to make sure the standards are kept between the browser vendors, making it easy for us web developers. Once we write a script that will work in Netscape, it would also work in Internet Explorer 3, and so forth. So what they did was they went to the European Computer Manufacturer Association, hence the name ECMAScript. Since ES1 or ECMAScript version 1, there has been many revisions. The most notable is ES5 in 2009, and now in 2017 we have ES6, which adds additional features to this language. You can visit the ECMA website to find white papers on the standards of this language to understand how this language is supposed to work under the hood and what browser vendors should be adhering to. So hopefully now you can see how this language was designed by Self and Schema, and how it didn't actually incorporate anything from the Java language. However, they called it JavaScript, and then you have all these different names here for one language. But I want to stress that Mocha, LiveScript, JavaScript, and JScript are all the same language, as well as ECMAScript. They're all referring to the same language, but because these companies own trademarks on those names, we have all of these different names for one language. And also, the biggest and confusing one is the fact that people mistake JavaScript for Java. They are two completely different languages, and they have a completely different syntax. And what do I mean by syntax? Well, it's the way in which a language is written. For example, you could say French has a syntax. They have certain symbols they put in their language. And English has a certain syntax. Well, programming languages have their own syntaxes, the way in which you write the language. And if you take a look at the way in which you write Java and the way you write JavaScript, they are very, very different in the way that they are written. Understanding what the browser does with our JavaScript code is very important. It gives us a tremendous understanding as web developers to really get under the hood and discover what happens with our JavaScript. So very briefly, all languages, no matter what programming language it is in a human readable format. This is the syntax of the language. This is for us, the programmers. However, your computer doesn't understand this. It understands machine code, or what we know as ones and zeros. So now let's understand the browser a little more. With each application that you have, most of the time it's made up of lots of little different applications that control certain aspects of the program. It looks like one program, but it's actually made up of many different programs. So, for example, the browser has 3 main programs that we're interested in. The first program is the DOM parser, and this takes our HTML code and it converts it into a structured page that we visually see. The next program is the CSS parser that will take our CSS code and then it will make sure that our document layout is rendered correctly. But truth be told, even though we have the HTML and CSS syntax being parsed here, we actually combine these two together. We have something called the layout engine or rendering engine inside of a browser, which is actually just classed as one program. And it takes both your HTML, CSS, and it does other things inside the browser as well. And ultimately, it renders the page, as seen here. And then finally, we have another little mini program called the JavaScript engine. Now, this JavaScript engine program can go by different names in different browsers, but they're just code names. They're just names for the JavaScript engine of that browser. For example, Firefox has SpiderMonkey, Google Chrome has the V8 engine, Safari has Nitro, and IE has Chikara. So it doesn't matter what name we give our JavaScript engine, its sole job is to take the JavaScript syntax that's in human readable form and convert it ultimately into machine code or ones and noughts so that our computer can understand our instructions. So this is why we call it client-side, because the files are being downloaded onto the client's computer and processed on the client's computer. Now, if we take a look at the JavaScript engine specifically, this is actually either going to be an interpreter or it's going to have compilation involved in there, such as a JIT compiler. For example, Google's V8 engine, and in fact, a lot of JavaScript engines are JIT compilers. And what JIT means is just in time. And what that means is it takes your human readable instructions, whatever instructions you want to execute at that specific time, and it basically converts those instructions. And they're actually very, very quick. They also do some optimizations as well. Now, I've made a course on interpreters, compilers, JIT compilers, and so forth in my free Programming 101 course, which I definitely recommend you check out that video. Please do note though, however, that when the user downloads your HTML, CSS, and JavaScript files, they are in human readable format, so anybody can look at the source code. However, this is the whole point of the web, that it's open, it's flexible, and it's expandable. So there's no way of actually stopping somebody from looking at the source code. And to be honest with you, I've learned a lot by looking at other people's source code. So by the web being so open, it's very transparent and it works very well. So help out other developers too. Console windows and interfaces are very important. Now, I'm not on about Xboxes, PlayStations, or any of the above or below. I am on about a simple text interface that allows you to input commands and view outputs. That's all a console is. It's a simple text interface. I like thinking of the console interface like the cool 80s kid that's a hacker and can go ahead on his really old computer and all he can see is giant text being typed out on the screen. That's a console interface. It's got no buttons, it's got no cursor, it's a standard text interface. And yes, your computers, even though they do have graphical interfaces, do allow you to open up a console window or console environment, which will allow you to take a look at basic input text and basic output text from the command written. Or if you type the command in wrong, you'll be able to see error messages and so forth. If you run on Windows, you can open up the command prompt. This is a console window. If you're on Mac, you can open up your terminal. This is a console window. And if you're on GNU, you can open up your terminal again, which is a console window. It's a basic interface, but however, don't let its simplicity fool you. Computers are very simplistic. However, the console interface, even though it is very simplistic, it is very, very powerful. Your graphical user interface just hides all of those commands that are run, so technically you don't have to be extremely geeky to use your computer. However, as programmers, we like geeky and we like consoles, and we like inputting text and viewing output because that's what being a programmer is all about. So, does JavaScript have its own console? The answer is yes. So, what is this console? Well, this console will allow you to type in JavaScript commands, and those commands will be taken live to the JavaScript engine, the just-in-time compiler, compiled, run, and the returned output will be delivered back to you in a human-readable format, which is again just text. This is very, very powerful, and the whole idea of programming is we understand exactly what we are getting back. And throughout this course, I'm not really going to be writing JavaScript files. I may do here and there, but overall, we're going to be doing all the console work. We just want basic input, basic output. And that way, you can see everything live. You can see what's happening in your just-in-time compiler. But please do bear in mind that sometimes I will be writing JavaScript files. And what you can do in your JavaScript files is log things out to the console window. So you can run the script and you can take a look at the output. Again, we'll look at all this later. But however, mainly we're just going to start out with just typing commands directly into the console window. And also, the console is extremely beneficial for debugging, not just to view output, but to view errors and warnings. Any errors compiling your JavaScript files or running commands directly in the console will appear in the console window. So, if there is any problem and your JavaScript isn't working the way you expected it, you need to open up your console and take a look at those errors. So how do we gain access to the console window? Well, we open up the developer tools. Now, every single browser that's on the market today comes with developer tools. I'm just going to cover the most popular browsers. So the first one is Google Chrome, the #1 browser in the world. All you have to do is go to a web page. I recommend going to a web page that doesn't have any JavaScript errors. So I recommend going to avelx.co.uk and make sure you open a new tab up, go to avelx.co.uk, and then anywhere on the page, right click and say inspect element. When you do this, the developer tools window will open. This developer tools will actually let you modify the DOM and even let you modify the CSS live on the page without having to refresh it. But also you have the console tab, and from there you can take a look at the console window, and from there you can input commands and view the output of those commands. You can also view errors and warnings. Now please do note the data that is displayed in my console window, which is the Google Chrome console window, may look different in your console window if you're using a different browser. Now if you are running Firefox, you need to right-click Inspect Element, and from there you have all the same set of standard developer tools, DOM, CSS, and also you will have the console as well. If you are running Safari, you need to go to the Safari Preferences, and then you need to enable developer tools. Once you've enabled developer tools, right-click anywhere on the page and hit Inspect Element. And if you are running Internet Explorer, simply press F12. When you press F12, the developer tools will open up in either IE 8, 9, 10, 11, and so forth. And again, all the standard set of tools, but mainly we want to take a look at that all-important console window. Hi guys, I hope you are finding this content really useful and adding value into your life, and I'm serving you the way that I should be with that great service of knowledge and information, and hopefully getting you excited about your career. And I hope you can get the value that you need out of this. And if you are and you'd like to contribute something, maybe buying me a cup of coffee, hit that Ko-Fi link in the description down below and you can donate like $3. That will be enough to get me a nice cup of coffee, and I can still keep making great content for you guys. Objects are extremely important when it comes to programming, especially when you start to realize that there are some seriously complex applications out there that you may want to build someday, but their complexity is based on simplicity, which is objects. Objects have stumbled a lot of people, but they are very, very simple. So let's start out with the real basics. Your program can only contain nouns, adjectives, and verbs. That's it. Programming is very simple. Nouns are descriptive. So take a look around you. You live in an object-oriented world, and each object has its own properties or nouns. These describe the object. So I'll take an apple, for example. So we have the nouns such as the width, height, color, and weight. These are nouns, but they're not good enough to describe the entire object. You also need the adjectives as well, such as the string red. So when we combine the adjective red with the noun color, we know that now we have a red apple. These key and value pairs, or nouns and adjectives, are called properties. Next, you have verbs. Verbs are performing an action, which is a function. That's exactly what a function is. So you have nouns, which is descriptive, and verbs, which are functions. And functions, like verbs, for example, could be eating the apple. That's a verb. Also, I could throw the apple. That's a physical action. So again, it's a verb. So verbs are functions. Now, when a function is within an object, it's still a function, but we give it a different name. We call it a method. That's it. So when we say method, it simply means a function that is contained within an object. That's it. That's how easy an object really is. So to give this some perspective, what I want you to do is think of, let's say, creating a graphics editor, a lot like Photoshop. I have a canvas, and on that canvas, I can have several images. Let's say I have 3 images in total on the canvas. Now, what we have is 3 objects on the canvas, 3 images. And for each image, I have the X and Y coordinate, where the image is placed. Then I have the width and the height of the image, and I also have the image data itself. So now that we have all of this data and it's collated together, all of these properties are encapsulated, put together, I have each object which resembles each image. Now let's imagine that objects didn't exist in programming, which is just impossible. But let's say they didn't. How could I then group this data together? The simple answer is I couldn't. So for each object, all of those properties will be let loose. How do I know which property, which noun describes which image? The simple answer is I don't. That's why objects are so important, because they allow you to group information together that relate to certain aspects of your program. That's why it's important. Now, to really get this object orientation in your mind, what you need to do is think about this in everyday life. Look around you. Look at all the objects you have. Just look at your computer. Take a look at the width, the height, the color, the size of the keyboard, the trackpad type, so on and so forth. Again, this is all very, very important. And then look at what you can do with the computer. I can type, I can smash the computer, which normally that's under angry. And then on top of that, you also have a whole host of other verbs that you could do to your computer. So that's the whole idea, is the fact that when you group data together, it becomes so paramount how important objects really are. And if you don't understand objects, you will not understand any programming language. It doesn't matter what it is. Now, to really ingrain this into your mind, apply it to your everyday life. Just visually think of those braces and adding in the properties and methods of each object you come in contact with. For example, you wake up in the morning, you go ahead and get the milk out of the fridge. So I'm going to picture the fridge. I'm going to open my curly brackets. And then within there, I'm going to take a look at a few nouns that describe this fridge. So it could be the make of the fridge, the size of the fridge, and so on and so forth. Then on top of that, I'm opening the fridge door. That's a verb. That's something that I'm doing to that object. Therefore, I'm running a method on that object. I'm opening that fridge door. If you keep thinking like this in your everyday life, I guarantee you object orientation becomes a breeze. Now, the next level is embedded objects. So we've already established that objects are very, very simple, but objects can contain objects. Just like in everyday life, objects do contain objects. Again, think of your computer that's sat right in front of you. Well, it's not just made up of one object. It's not just classed as one object. You may have a camera in your computer. You have a screen. You have a keyboard. You have the trackpad. Each of which have their own nouns and verbs associated with each component in your computer. And you can break it down and down and down and down and go as complex as you would like. But then what I need to do is encapsulate all of those objects and components together into one object. So here you can see it's all encapsulated into one object. So this right here is a hierarchy of objects. We're establishing an order of objects. We have the sub-objects and the main parent object. And when you think of something like a car engine and all the components of a car engine, again, you can go into some serious depth with your objects. So we've understood one. Encapsulation. Encapsulation is grouping data together, whether it be nouns and verbs or both. And if you really want to remember encapsulation, just think of a capsule that contains many chemicals and so forth that you stick in your gob and swallow. Then we have nouns and adjectives which describe the object and verbs which are actions performed on that object. And finally, objects can contain other objects. Now, if you understand all of this, you will understand objects. And if you apply this knowledge in your everyday life, then objects will become more clearer to you as a programmer. So what is the JavaScript syntax? Syntax is simply the way a program is written. So we have all these different languages. For example, HTML, the hypertext markup language, has its own style that you write it in. That's the syntax. That's all it means. That's what syntax means. It means the way in which that language is written, and that's defined by the creators of the language. Now, there's going to be a very popular acronym. An acronym simply means each letter is a word. And that acronym is API, and it will constantly keep popping up. So we really have to understand what is an API. API stands for Application Programming Interface, and every language on the face of the planet has its own API. What is it? Well, an API is simply a collection of functions and also properties as well. So let's have a look at this. We have the window object in JavaScript. If we take a look at this in our console, we can see that a window object has many functions. These are methods. These methods were not set up by us. This was set up by the just-in-time JavaScript compiler. So this program automatically defined these functions and properties in the window object. In and of itself, we didn't need to do anything for that window object to be defined. It was already defined for us. So in that case, that is the JavaScript API in a nutshell. It's just a collection of functions and properties. Likewise, we can also have APIs inside of APIs. For example, let's say I download the all-popular jQuery library, which probably most of you have come in contact with. Well, jQuery attaches onto the window object, and you can see here with the $, jQuery is an API. It has its own collection of functions and properties. This is what's known as an embedded or extension API. So that basically means that jQuery needs the JavaScript API to define its own API. So jQuery is just using those native APIs that come with JavaScript, those native predefined functions, and then it's using those in its own functions and creating its own style. But it's not in and of itself a completely different language. It's an API extension, therefore it's adding on to. Or you could call it an embedded API. That's what libraries are. And whenever I create, let's say, an object within the window object, because everything goes inside of that window object, and we'll learn more about this later. But whenever I create an object with my own methods or my own functions and my own properties, I'm essentially creating an API. You don't have to give it a name, but that's what you are doing. You are creating your own API. So remember, JavaScript comes with a JIT compiler that takes your human readable code into ones and noughts, and a JIT compiler have their own native APIs or predefined functions and properties right out of the box. Otherwise, if it didn't, you wouldn't be able to create your programs. And you can extend onto the native API by creating your own API. You could create your own library, or even just creating a grouped set of properties and methods. You are creating an API. So again, to pull up the window object, simply go to your web browser, go to any web page, right click, inspect element, and then go to the console tab. And from there, you just type in window, and that will bring up the window object. Now, every single window, doesn't matter whether the window is in a tab, so you have many tabs, or many different separate windows, it doesn't matter. Each one of those windows or web pages has its own window object, and each window object is isolated from the other. So in essence, one web page can manipulate the window object and add stuff to the window object that's different from the other one. So each window, each web page has its own window object. Then also what we have is the API, or Application Programming Interface. A lot like when I'm interfacing with other people. You can think of the people as the programs, and we're interfacing back and forth. And these programs encapsulate, meaning put together, their own APIs, such as their own properties and methods that you can invoke. Like, for example, with jQuery, you can actually start to set up a new jQuery object and then start to modify it and so forth. So jQuery's got its own API. It's all encapsulated together. And of course, you can have APIs embedded inside of other APIs. We have the native JavaScript API, and then we have the embedded jQuery API. Then finally, what you've discovered is about programming language execution. Programming languages can either be executed by an interpreter, compiler, JIT compiler, or AOT compiler. In the case of JavaScript, it's a JIT compiler. And the JIT compiler will take your instructions just in time when you need those instructions, and it will take them off and it will convert them into machine code or gobbledygook, ones and zeros that your computer's hardware can actually understand. And it also does some other optimization processes as well. So that is essentially how JavaScript and its syntax is used in the browser. Primitive just means basic. You can think of like a primitive human being, like a caveman. It just means basic data. And you will not be able to create an application without basic primitive data. So let's take a look at this primitive data. Well, first of all, you have a string. And you can define a string by the double quotes, or you can also define a string by the single quotes as well. Now also with strings, you may need to escape certain characters. What do I mean by escape? It means nullify certain characters. So for example, if I have the double quotes and I said, he said, and then what we typically have is the double quotes to define what somebody is saying. So he said, hello. Now you'll notice here we can see that this part is in red and this part is in red, but this part is black. And what that means is this is actually going to run in JavaScript. And it's actually going to go out there and try to find a variable called hello. And we'll talk more about variables later. But what you have here is you have two strings, one there, and this bit is JavaScript. When you run this, you'll get a syntax error. I'm very sorry, we can't find hello. And also, this is incorrect anyway. You're not concatenating, which means joining together. So this is incorrect completely. It's invalid. So what we need to do is we need to say, right, I don't want to end the string there. So I want to nullify this character. And you do that by placing in a backslash. You need to place that backslash right next to the character you want to escape. So we're escaping this quotation mark character. You also want to do the same here for this quotation mark. And that's it. And there you go. So we have hello, and there it is. We have the hello right there in the string. So you nullify the characters. Also, what you could do is mix and match the quotation marks. As I said, you can define a string by single quote. So you could say hello world, and then you could use the double quotes. Yep. Like that. And you'll notice that if we start with a single quotation mark, only an ending single quotation mark can actually end the string. So the double quotation marks here don't affect the single quotation mark. So this is actually good to mix and match the quotation marks. That's why we can define a string with both single and double quotation marks. It just makes it easier for us as programmers. And likewise, it's the same thing in the other way around. Hello world, and then you can have single quotation marks. And single quotation marks cannot escape or break out of the string of a double quotation mark. Nice and easy. The other type of primitive is a number type. Now, please do note with JavaScript, the number type is the number type. However, there are two types of numbers. You have whole integers, such as 100 or 200 or 1. So these are whole integers. They're whole numbers. They're not fractional, nor are they divided into a smaller section. So also what you can have here is floating point numbers. So these are integers, and then you have floating point numbers, which is fractional numbers, like 1.1. It has the decimal place in there, or 100.256. This is, again, floating point numbers. Again, these are all classed as the number type in JavaScript, but you do have the two different types, whole integers and floats. Now let's go ahead and take a look at Boolean. What does Boolean mean? Well, when you think about Boolean, think of a pool, think of an ocean. When something is Boolean, it floats. And if something is not Boolean, it sinks. And you only have one of the two. It's either going to float or it's going to sink. It's either negative or positive. It's either true or false. So when you define true, you're not defining a string here because you've not got the quotation marks in. If you put the quotation marks in, you've now defined a string. You can see it's highlighted red. But when you actually have just the word true without the quotation marks, you are defining a Boolean, and false, which is also a Boolean. Is it going to float, true, or is it not? False. And that's the only state. It's a light switch. It's either on or off, yes or no, 0, 1, true, false. And that's it. It's either on or off. And that's all the Boolean means. Now you also have other primitive types as well. You have null and undefined. Again, these are not strings because there's no quotation marks there. Now, what do these mean? And these have caused a little bit of confusion. Well, null actually could mean that there is no value assigned. It means that it's empty, it's void, it doesn't have anything. Now, why would you actually want to do that? Well, when we create variables, it will make more sense. But please do note, these are primitive types. Null and undefined mean the same thing. It's undefined, or it doesn't have anything assigned. It's completely empty. It's void of anything, of any value. Totally. So again, we'll come back to this later on of why you would want to do this, but you may want to know if, let's say, you have a variable, and we'll get onto this later, and if it's void, if it actually contains anything. If it doesn't contain anything, it will be null. It's still a value, but it's a value that lets you know there's nothing in there. It's completely empty. Finally, you have the primitive type, which is nan, and you must spell it exactly like this, capital N, lowercase a, capital N. And what this actually means is not a number. So if you wanted to check to see if, let's say, a variable or a part of your program has a number stored within it, and let's say if it's not a number, then you will get this primitive type returned. It will tell you, sorry, it's nan, it's not a number. So you know not to use this variable or this value in your mathematical expression, for example. So nan just means not a number. So there are your primitive types. What you have first of all is a string either by single or double quotes. You have integers, which are whole numbers. And you have floating point numbers, which have the decimal place in them. They're fractional numbers. Then also you have Boolean, such as true and false. Next you have null and undefined. And then finally you have nan, which means not a number. There are your basic primitive types. And by using these basic pieces of data, you have primitive data. Our programs need to store values and they need to pull up those values later on in our program. Just like you have short-term memory inside of your mind, well, your computer also has short-term memory. And it needs to be able to store values, but we as programmers also need to pull those values out of memory when we need them. Memory is just storage. So let's go ahead and take a look at creating a variable, then a constant, and then have a look at what this means for us as programmers. So what we need to first of all do is to create a variable, we use the var keyword. Now when you do this, you're creating a box. Think of it like you're creating a box and the box needs a name because your program can contain thousands of boxes that contain all different values. And you need to be able to identify what is inside of that box. So let's go ahead and create a variable called name. So this box now has a name. Now please don't make this a string because this is not actually defined as a string. It's actually defined as a symbol. It's a memory address. Think of it like this. Your house has an address. The address isn't the house, but it is a way to target your house so the postman can find you and post a letter through. Well, likewise, we want to find stuff in memory. So this time what we want to do is we want to create a box and we want to give it an alias name so that then we can target this in memory. We can find it, we can point to it in memory. So we're going to create a variable called name, and then we're going to use the equal sign. Now the equal sign is the assignment operator. It's a command to the JIT compiler, and we'll talk more about operators later. But this command is going to say take whatever is to the right of this operator and assign it to the box. So I'm going to say go ahead and define the string Lawrence, and then also we end with a semicolon. And think of the semicolons as the full stop to your sentences, just like in the English language. When you write a sentence and you're finished, you write a full stop. That's what your semicolons are there for, to say this statement, this command that I'm giving to the JIT compiler is finished. So that is a command to the JIT compiler to create a variable, to create a new box, label that box so that we can understand what that box contains. We have a general idea, so it's nice and easy for us to address that box, target it, and then we want to assign the value to the right of it. Now this could be a string, a number, a boolean. It could even be null or undefined. It could be anything that you would like it to be, an object or an array. But it needs to be one value that is then going to be assigned to the box. It's going to be placed inside of it. So we're going to take this string and place it inside of this box, and there we go. And then when I put in the name, you'll see I say name. So I've targeted, I've focused on this value stored in memory, and it's pulled out that value, Lawrence. And that's nice and easy. And as I said, your program can contain thousands and thousands of boxes, so we need to use our names wisely. Now, when naming your variables, please don't start with numbers or even a capital letter or, any sort of special character. But what you can do is, you can have divides in here and so forth. But try to keep it as simple as possible when creating your variable names, and never put in spaces, that's not allowed, and never define a name as a string. So that is how it works. It's simply an addressing system. Now, being a variable, well, you know what variableness is. It means it changes. It's variable. It changes in value. So with this box, I can actually assign a new value, such as Turton, and end with a semicolon because I've completed that statement now, that command. And what it will do is it will delete out the old value that was stored in that box, and it will assign a new value, Turton. And now, when I type it in, you'll see it gives me Turton until, let's say, my program later on changes it to something else, like so, and then I can type in name, and it will keep giving me that name until it's changed at a later date. That's a variable. Now, with variables, you can also create a blank variable as well. You don't need to assign a value straight away. You can actually create a box waiting for a value to be stored. Now, when I do this, you'll notice it returns undefined. It may return null. Don't forget, null and undefined are primitive types. They are values to say there is no value. It's void. It's hollow. It's waiting for a value to be assigned, in other words. It's just an empty box. It's just a way of telling you there's an empty box. So if I now type in blank, I'm just going to keep getting undefined until I actually change the value. So let's go with blank, and then let's say new value. And what that will do is it will take out the undefined or null value primitive, and it will put in a string, for example, or an object or an array, which we'll talk about later on. But basically, what you need to understand is variables and constants are just ways of fetching data out of memory so that we don't have to type in really complicated numbers to try and find data in memory. We can just type in a nice, easy name. Now, also, JavaScript is a loosely typed language. And what do I mean by that? Well, it's loose on its data types. So, for example, you could have a variable. Again, we have the variable blank. And blank contains a string data type, like so. So we can reassign a string. However, in some programming languages, it will only allow you to assign a certain data type. Once you've created that variable and you've assigned a data type such as string, you can only assign a string value to that variable. Whereas in JavaScript, that doesn't happen. It's loosely typed. It's loosely typed data. So you can change the data type, such as instead of being a string, it could be a number, or instead of a number, it could be a Boolean, and so forth. And instead of that, you could have an object, or instead of that, you could have an array, and we'll talk more about this later on. And so what that allows you to do is what we're doing here is we're assigning different data types from string, number, Boolean, object, and array to the same variable. It's a loosely data typed language. Now, the other type of box is a constant. So you've got variables that change in value. Well, you know something is constant, it doesn't change. It's the same today, yesterday, and forever. So a constant is constant throughout the lifetime or the execution of the program. Once you've defined a constant and your program is executing, the constant always stays the same. So it's a constant, and then you need to define a symbol name, an address name. So I'll just say last name. And with this last name constant, I'm going to say Turton. Now, you cannot, under any circumstances, create a constant without assigning a value. Before, we created a variable and we didn't assign a value. That's because we can add a value later on. But with a constant, you can't add a value later on. So when you create a constant and you create the name of the constant, the symbol, you can't then later on assign a value. So your constant needs to have that value assigned straight away. So you know what the value is. You're more consistent in your thinking. You know it's going to contain that value, and that's what the value is, and it's never going to change throughout the lifetime of your program. And that's good for security reasons, so nothing else can change that part of your application, that memory address. So we have a constant called last name, and we're going to assign the value Turton into that box. And then you'll see last name. And there you go, it has the value of Turton, and I can keep typing up. But if I try to assign a new value like a variable, well, don't forget, it's look but don't touch. It's constant. in nature. So if I try to assign a new name like Lawrence, it'll say, I'm sorry, what you're trying to do is you are trying to assign a value to a constant. And you cannot do that. Once you have a value stored within it, it doesn't change. It's still a memory address, it's still a box, it's still a pointer, but this box is sealed. It won't let you open it back up again and take out the value and put in a new value. If you want to do that, you need a variable. And if you don't want to do that, if you know that you're going to set the value and that's it, then you use a constant. That will help your application be a bit more robust. Now, what you have to think of is that last name is a symbol. And also you have the other one, which was name. These are symbols. And in fact, if I take a look at the window object and I expand the window object, you have a whole host of names right here. These are ways for us to access either a function or a value. So we need an ability, the programming language needs an ability to store all of this together. And what it's actually called is a symbols table. A symbols table is like a database, and it stores all of these symbols, these names that allow us to access values. You can also think of a symbols table as a giant warehouse that contains all of these boxes, and all of these boxes have got names on them, and then we can go into the warehouse and we can find the box with the right name. And think of the window object as this giant warehouse, this warehouse where we roll up the shutters. Let's roll up the shutters and let's enter into this giant warehouse with boxes full of different names. And you take a look at all these different symbol names that you can see here in purple. But then also if you keep scrolling down and you keep scrolling down, eventually you will find the symbol that you created named. There's my box. I can find my box in this gigantic warehouse full of boxes because it has a very specific name. It has a unique name right here, and there is my value. And that's what it's doing, is it's looking through this gigantic warehouse, it's finding that box, pulling that box out, opening the box up, and giving you the value back. And then you can do what you need to do from there. So this is actually what is the symbols table. It is, in fact, just a database, a warehouse. And we have boxes, which are variables and constants. Your variables vary in value, your constants stay the same in value once assigned, and of course variables can have different data types assigned to them. They're loosely typed, so you can have a string, a number, and so forth assigned to a variable, assigned to that box. It doesn't have to be of the same data type. First of all, what are operators? Well, without operators, you simply wouldn't have a programming language. It wouldn't exist because you need operators. And when you start writing programs, and when you look through your script at all the operators that you're using, you'll realize that without operators, a programming language becomes useless. It's futile. So what we're doing here is we are taking our human readable instructions. This is an instruction where we create a variable called name and we assign it a value. This is an instruction in a human readable format, but the computer can't read that and understand it. It needs to go through a JIT compiler or something of a kind. So you have AOT compilers, interpreters, and so forth. But that's not the point. With JavaScript, you have a JIT compiler, and that is a program that will read through like you would read a book. And it executes your commands. It puts your commands together and it executes them. And that JIT compiler will convert it into machine code or bytecode that can be executed in the hardware. Now, we also have something called operators. You'll notice I said this is an assignment operator, but what is an operator? Well, an operator is a predefined function for the language. It's a function defined in the JIT compiler. It will read through your code, and when it reaches an operator, it will actually run a function. Now, what is a function? Well, you can call a function a subroutine or a subroutine a function, and we'll cover functions in detail later. But what in essence are they? Well, if a function is a subroutine, just think of it like a subroutine for you, making coffee in the morning. When you go downstairs and you want to make a coffee, you have a subroutine. You put the water in the kettle, you boil the kettle, you pour the hot water in and so forth, and you go through all these things subliminally inside of your mind. Well, these things are pre-programmed inside of your mind. You can just do it naturally without thinking about it. Well, with the JIT compiler, it's actually got these operators predefined, ready to be executed in memory, and it can be run right in memory. So it's predefined functionality. It's a predefined subroutine, just like you going downstairs performing an action like making a cup of coffee. Functions are verbs, they're actions, they're tasks that you can perform. Well, of course, an operator is a task, something you're asking the compiler to do. You're asking it to run a particular set of tasks to, let's say, create a box, give it a name, make sure that that box can have its value changed. And then also what we want to do is open that box up and we want to assign a new value. So this is what it is. This is actually a function. Operators are functions. And this is just one operator. We've just got the assignment operator here. But there are many other operators. And you can have many operators in one statement. So what we need to do is understand there is an order of precedence to which your operators are executed, to which these functions are executed, which are the more important operators. So there's one type of operator, but if you actually search in Google MDN JavaScript operator precedence, this page will be the first link, and you can scroll down and you can see a table of all of the operators that you can use inside of JavaScript. You also have the number, which gives you the precedence. If it's a higher number, it means that that operator is going to be executed first before the other ones. And if it has a lower number, it carries a lesser precedence. So for example, you've got at the highest order, the parentheses, or what's called the grouping operator. And then you can keep scrolling down and you'll notice that we have our assignment operator, which actually is very low right here. And you can see what it does is it's right to left, meaning it takes the value on the right and it assigns it to the value on the left. So that is actually what is happening right here. And by this table, we can identify what is going to run before others. And this is very important because you need to understand the order in which these operators will be executed. So if you go ahead and take a look at this, you have a mathematical expression, for example. So we have 5 plus 2 times 3. Now, if you just read it like a book from left to right, you would get the wrong answer. So let's take a look at this. If I was to just read it like this, 5 plus 2 is going to be 7, and then times 3 is 21. Let's go ahead and do this, and you'll notice we actually get the answer 11, and that's because you don't read it left to right. You understand that there is a precedence with these operators. We have two operators here. We have the multiplication and we also have the addition operators, and it's not just in the way that this is written, it's what operators take higher precedence get executed first, just like a calculator. And if you type this into a calculator, you'll still get 11. And so mathematicians know about this. There are a few different sayings for this, but we go with BODMAS. And so this is how I remember the operators in a mathematical statement and the order in which they are executed. So first of all, you have brackets. So brackets could be the round brackets known as parentheses. They take the highest precedence. And if you take a look at the Mozilla Developer Network, look at it, look at this, the grouping, the parentheses right here have the highest precedence. Then you have what are known as powers. Now, powers are actually a function call in JavaScript. If you want to power a number, times itself by itself so many times. So we'll look at this one. Powers is a function call, and if you take a look at the Developer Center's table right here, you can see that 18, there's the next one, a function call. There's the name of the function, then you have the parentheses, and then you pass in values. Now we'll talk more about functions later on, but that is the next order of precedence. Then after you have the powers, you also have division and multiplication. Division and multiplication share the same precedence right here. So if we scroll down, there it is, 14, multiplication and division. Whichever one comes first at that point, they both hold the same precedence. And then finally you have A and S for BODMAS. A and S is addition and subtraction, and there it is. Addition and subtraction carry the same precedence as one another, so it doesn't prefer executing one over the other. So let's go ahead and look at this. BODMAS. So we don't have any brackets, we don't have any powers in this expression, we don't have any division, but we do have multiplication. Well, we know that multiplication has a higher precedence than addition, which is right here. So multiplication gets executed first. So 2 times 3 is 6, and then you say plus 5, which gives you 11, because the addition comes afterwards because it doesn't have a higher precedence. So that's why you get the answer 11 instead of reading it left to right. There is a precedence right here. And so that is understanding that these functions in one statement, you can have multiple operators, and these functions or these operators are executed based on their precedence. So let's try a bit more of a complex expression and return that, and that expression returns the number 28. And I want to write out BODMAS again in that order so I can see the order of the precedence. So what you have here is, first of all, you have the power. Now, you can't actually write an exponent, which is a base number, and then you have the exponent in the JavaScript syntax directly. You have to invoke a function. So this is actually the powers right here. And I don't want you to get too hung up on function calls at the moment. We will talk about functions later. But all we're doing is we're passing in the base number, and then we're passing in the exponent. So the base number is 2, and then we tell the computer how many times we want to times the number by itself. So it's 2 times 2 times 2 times 2. So it's 2 times itself 4 times. So 2 to the power of 4. We have the division, we have multiplication, we have subtraction. We also have the grouping operator. And then also we have the multiplication operator as well. So there is BODMAS. Now we need to go through it. So first of all, are there any brackets? Well, yes, there are. There are these round brackets or parentheses. And you can see there's only one operator inside of them, which is the multiplication. So this gets done. 2 times 12 is 24. Then we need to go to the next stage. Well, we've got powers. So with powers, you've got math.power right here. 2 to the power of 4, 2 times itself 4 times is 16. Then we need to go and look at any divisions. Well, the next one is division. So 16 divided by 2 is 8. Then we have multiplication. Well, there's no more multiplication left, so there's only these operators left. So what we need to do now is we have the addition and subtraction. Now, addition and subtraction are on the same level. There's no precedence over the other. So we just read this left to right. So we have 8 plus 1 is 9, minus 5 is 4, and then finally we say plus 24. So 4 plus 24 is 28. So when you follow this order, this BODMAS precedence, if you will, and understanding how these operators are triggered, you understand how they work. So what you have is, again, brackets, so they're parentheses. Then you also have powers, division and multiplication. Again, division and multiplication are both on the same level. It doesn't prefer one over the other. It's just which one comes first. And then addition and subtraction are on the same level. So in this case, we just carried on from there, left to right. There was no precedence over the other. So that is actually what BODMAS is. And there are the mathematical operators, and it fits in with BODMAS. And I believe there's also others as well called PEDMAS in America as well. They also have their own names, but it's the same type of thing. Parentheses, exponents, division, multiplication, and then addition and subtraction. Now, very quickly, I just want to talk about divide, because you have two types of division. They both carry the same precedence, but what you have here is a regular division, which is just the /. But you also have another type of division, which is actually a remainder divide, or the remainder operator. It's also called modulus division as well. And this will actually just give you the remainder of the division. So, for example, we have 9 and we want to divide it by 5. Well, we know that 5 can't divide into 9. So we're left with a remainder of 4. It just provides us the remainder. So it just leaves us what's left over. And this is actually quite good for finding out odd and even numbers. For example, if it's an odd number and we try to modulus divide by 2, well, we know that if any number can be divided by 2, that it is an even number. 2 is an even number and it goes into all the even numbers. So if I go ahead and return, we know we get a remainder of 1. So this is an odd number. But if I was to say 10 modulus divide 2, I know that 10 is an even number because 2 was able to divide that number up and there was nothing left over. There was nothing. And so that's it. So it's actually quite good for finding odd and even numbers. So we have the standard type of division, which will tell you how many times a number will fit into another number. And then also you have the modulus divide, which will just give you the remainder. It will tell you I've tried to divide this number into this one, and if I couldn't fit if I couldn't fully divide that number, then it will just give you whatever is left. So that is how it works. Now you know about operators are predefined functions in the JIT compiler. You know that operators have a certain precedence when they are executed, and that's it. So there are many assignment operators that we can use. If we take a look at the Mozilla Developer Network, you can see that we have the assignment operators and they're all on the same precedence. Now I've already taken a look at the standard assignment operator that takes the value on the right and assigns it to the variable or whatever is to the left. But you also have all of these other assignment operators as well. Now we're going to leave these assignment operators because these are bitewise operators and they're a little bit more complicated. But you already know about, let's say, addition, subtraction, powers, multiplication, divide, and the modulus divide as well. So let's take a look at some of these. First of all, I can create a variable called number, and I'm going to set that number equal to 20. So now we have a symbol name called number, which is a memory address, and it points to a certain address in memory, a certain value in memory, which is currently an integer 20. Now we can take a look at the different assignment operators. So again, you just have the standard assignment operator that would just delete out the old value and assign the new value. That's dead easy. But what happens when we use, let's say, plus equals? Well, what you're actually doing here is you are adding to the existing value. So the existing value is 20, and we are adding this new value, 30. So we're combining the values together, and that's going to equal 50. So once it's done that, it will then assign that value back to our variable. So now number won't be equal to 30, it will be equal to 50. And likewise, you can also have the subtraction. So what we want to do is subtract 30 from 50 and assign it back, which will leave 20. And then also you can have multiplication as well. So we can say 20 times 2, which will equal 40. Then also we can have divide as well. So number divide by 4. So we're going to divide 40 by 4, and that's going to be 10. You can also have the modulus divide as well, or the remainder. So this will leave a remainder. So if we try to, let's say, divide by 4, well, how many 4s can we fit into 10? Well, you can only fit 2 4s into 10, leaving 8, and 2 remainder. So there we go. We now have 2, and you also have to the power of. So we have the double asterisk for that. So 2 to the power of 4. So that's 2 times itself 4 times. So 2 times 2 times 2 times 2 is 16. So there you go. There's the different assignment operators. You've got the standard assignment operator that will take the value out and assign a new value. And then you have all of these other assignment operators that will actually take the existing value on each one and it will either do addition, subtraction, multiplication, divide, modulus divide, and you also have to the power of as well. And you can go ahead and modify these values. Now you'll notice that most of these are arithmetic type operators. These operators could be used for mathematical expressions and so forth. But what I want you to understand is that even though we have the plus equals, the plus operator doesn't just deal with numbers. It actually deals with strings. And let me demonstrate this to you. If I have the string Lawrence, and then I would like to concatenate, meaning join strings together, I use the plus symbol in JavaScript. So I can say now, Turton, and end with a semicolon. So I've got two separate strings, as you can see, defined by two separate quotation marks, and I have the plus operator in between them. And what that will do is it will join the strings together. So that's quite interesting. Now what happens when you try to, let's say, concatenate a number? You may be thinking, well, this should surely error because you've got a string on one side and you've got a number on the other side. Well, let's hit return, and you'll notice what it did was polymorphism. Now that is a big word. What does polymorphism mean? Well, you know that this operator is a function. It's a function defined in the JIT compiler. Now, when you go downstairs and make a cup of tea or a cup of coffee, you can polymorph. Your subroutine, your routine for making a coffee or a tea can change. It can adapt. Its process can be different, if you will. For example, you can make a tea and you can add more sugar to it or more milk. If you're making tea for different people, your subroutine is still make a cup of tea or make some coffee, but it adapts, it changes, so you can add more sugar for somebody or change the amount of milk. It's the same subroutine, but it changes, it polymorphs, it adapts. Well, likewise, we have polymorphism here, which means it can do and adapt to different situations. It's ready to change and mutate. So instead of being an addition operator that adds two numbers together, this polymorphs and it can actually concatenate two strings together. Or if you have a string anywhere, either to the left of it or to the right of it. So if I had, let's say, a number to the right of it and a string to the left of it, you will notice that what it does is it polymorphs. It takes the number, the integer, and it actually converts it into the string data type. It adapts. Think of polymorphism as a blob that morphs around. It changes and adapts. You can think of it like Play-Doh. It changes and adapts itself into different shapes that you push it into. And that's exactly what I would describe as polymorphism. It just changes and adapts to the environment that you throw at it. So strings always take precedent. Once you have a string there on either side of the plus operator, it will automatically change whatever is there, whether that be a float, it could be a Boolean, for example, as well, such as true. Again, it will convert the Boolean type into a string data type and combine them both together. So that's what we call polymorphism. Now, coming back to the assignment operator, what you have here is I could have var name equals Lawrence, for example. And now name is equal to Lawrence. And then I can say name plus equals, and then we're going to say Turton. So what it's going to do now is it's going to look at the existing string, and it's going to say, right, I need to concatenate, meaning add on to, join this string right here, and assign it back to the variable. And there you go, it says Lawrence Turton. So that is the plus equals assignment operator, and the plus operator adapts itself, it changes. Once it finds a string either to the left of it or to the right of it, whatever other type there is, whether it be a Boolean, whether it be an integer, whether it be a float, or whatever else it may be, it will actually convert it into a string. You'll even find that if you were to say null plus and then Lawrence, let's take a look at this. It will actually convert the null data type into the string null. It always converts it into a string. So that is the plus operator, and you now know about the assignment operators, and you also know about polymorphism. Just think of it like Play-Doh. You push the Play-Doh into different molds, it fits, it adapts, it changes to suit its environment. So far, we've been working with the console window in the browser. And when we work with this console window in the browser, we can run very simple statements and commands. But the thing is, when we refresh the page, we unfortunately lose all that data. And even in the next lecture, what I'm going to be doing is actually I'm going to be writing out functions and so forth. So there's going to be lots of code here that we need to write out. And I'd also like to keep this code. So even if the page refreshed, I have my code stored in a more persistent, meaning a more dedicated space, such as a JavaScript file or a .js file. This way, my code can be stored and then it can be loaded in to different web pages and it will stay in the web page even if I refresh the browser. Now, what we have here is called a code editor or IDE, which stands for Integrated Development Environment. It's simply a code editor that allows us and facilitates us in creating our scripts. There are many code editors that are completely free. This one that I'm currently using is called Brackets. And if you go to brackets.io, you can download this IDE for free. Also, please note this lecture does come with the source files. So you can go ahead and download the source files for the current project, which is the index.html file. This is the HTML file that is displayed inside of the browser that you're currently viewing. And then you also have the myapp.js file. Now the .js symbolizes a JavaScript file. This is where all of our JavaScript code will go. And HTML is for our HTML markup. And so currently this is what myapp.js file looks like. Now ignore all of this code because we're going to get back to it later. But let's take a look at the index file. You have the basic markup that you need to create a simple HTML page. And what we have right here is the script tags. Now, when you use the script tags, what you're doing is you are linking to the JavaScript. So we are linking to the myapp.js file. So we're targeting this file and we're saying include all of the code, and we want to execute the code that's in this file within our index.html page. We're just creating a nice link there between the files. Now, please do note you can write JavaScript in line. So for example, I can write script and you can write JavaScript directly in HTML. So anything in between these script tags will be classed as JavaScript. Now, let's say that when I load my page, I want to display the string hello world in the console, and I want to do that via this script here. How do I do it? Well, first of all, we need to target the console window. So you say console, and then what you need to do is tell it to log something out. So we do console.log, and this is great for debugging. If you ever want to check a variable or you want to check something in your scripts, it's always recommended to log something out to the console. When you log something, it's like a ledger. For example, you have maybe a book with all of your accounts in it, a ledger, and you log each transaction out. So that's exactly what we're doing. We're logging some information, some data out to our console window. Now, don't forget the console window is text-based only, so you can't, let's say, display an image or something like that in the console, but what you can do is display the text and so forth. So I can say console.log, and then we are invoking this function with the parentheses. Now, I'll talk more about invoking functions later on, but we say console.log, and then we pass in the data. So I'm going to pass in hello world, and that's it. So we save this now. And when I hit refresh, you'll notice it says hello world in the console window. So we can actually communicate from the JavaScript to the console window, and you can write JavaScript directly in a HTML page. You don't need to actually have a separate JavaScript file. But the reason why I want a separate JavaScript file is because I want to keep the logic, this side of things, all the application logic, you know, the calculations and the computations away from the markup. I just want the markup to be the display, and I want my application logic separate. So now I can write some really advanced scripts and I can keep it away from my markup code. This makes it easier for me to focus on my application logic, the computation, the mathematics, all the rest of it, and focus on my markup. And this separates the concerns. This is always what you want to do in programming, is separate the concerns. You want to keep things away from something else. So if something's for presentation, for visuals, keep that in one file. And if something's for computation and logic, you keep it in a separate file, and that actually will help you out. Now also, why have I included the script right at the bottom of the body, and why do I recommend it? Because let's say my JavaScript file here is, let's say, 200 or 300 kilobytes, which is fairly large. And so that's quite a large JavaScript file, and your JavaScript files can get very large. So the reason why we don't include it in the top is because HTML is block loading. So in other words, it starts loading line upon line, precept upon precept. So it goes to the head, then it goes to meta, title, script. And what it will have to do is, if your script is really large, it's going to actually hold up the rendering, because the body of the page is the bit that you can see in the browser. Now let's say my file is 200 or 300 kilobytes. Well, it's block loading, so it's waiting there, it's sitting there, and it's trying to download all of the JavaScript, and then it carries on when it's finished, and then we get on to the bit that's rendering. Whereas if I had my large JavaScript file at the bottom, we start block loading line upon line, precept upon precept. And of course, when we start rendering things out, for example, our header elements and all of our styling and all of our page, all of the rendering, all the visuals come through first, which makes our page look a lot faster. And then we load in our large JavaScript file or files into our HTML page. It just actually makes it better for rendering as well. So that's a quick tip. And so I'm going to go ahead and save these out. So now I've moved my console.log into the myapp.js file. This file is now being linked inside of the index.html file. And then finally, when I hit refresh, we get the exact same result. So let's take a quick look at the console.log and see what we can log out, where you can log out a string, you could log out a number, you could also log out true and false, which is a Boolean. You can even log out primitive types like null and undefined, like so. So I can go ahead and save that and hit refresh. And what's really nice about this is the fact that I can get the output, and it can tell me what's going off inside of my script. Sometimes when you're writing your scripts, don't forget, it's not executing. So you're only looking at what you've written and it makes sense to you. But when you run it in the browser, bad things can happen, things that you weren't expecting. And so what's really nice is to log the data out as you go along to figure out what's happening to the data. Is this function returning the right data? Is this variable containing the right information? You can log out variable data as well. So var num equals 10, and then I can log this out to the console. So I can say console.log, and then I can log out the num variable, and we can go and save that and hit refresh, and there is the num variable. So it looked at that symbol, that reference in memory, and it pulled out the value. Then on top of that, with the console.log, you can do all of these things in one go. So you can log out a string, you can also have a standard integer or a floating point number, you can also have a Boolean such as true or false, and then also you can have null and undefined, and also I can log out, let's say, variables and outputs from functions as well, which we'll talk about later on. So there we go. You just separate each value out with a comma, and then go ahead and save it and hit refresh, and you'll notice that one line has logged out all of those different values. So you can log out multiple values, you can log out multiple variable values, and so forth. So go ahead and have an experiment with console.log, and that will help you later on in understanding the output that is provided. Functions, or subroutines are tasks that our program can complete. So you can call a function a subroutine or a subroutine a function, but what I like to do is use the word routine or subroutine. And the reason why I like using that is because we have routines in our daily lives. For example, when you want to make a cup of coffee or make breakfast, you have routines for these things. Or when you want to leave your house, you have a routine for locking all the windows and doors and making sure everything is secure. You have all sorts of subroutines that you use in your daily lives. And you have these subroutines waiting in your mind, in memory, when you need them. And you just don't need to think about things. But with programming, we need to teach the computer, we need to show the computer how to perform these actions. We need to break down this subroutine, whatever it may be, into a set of instructions. So that is where functions or subroutines come into play. For example, if I want to make a cup of coffee, I have a subroutine for making coffee. And when I think about that, I think about this subroutine that I have where I pour the water into the kettle, I boil the kettle, I tip the water into the mug, then I add my milk and my sugar and so forth. Now also, when I think about this subroutine of coffee, I think of it as adaptable, changeable. So please do understand that even though I have the abstract, making coffee, well, yes, that's on the abstract layer, meaning it's basic. It's a very basic way of looking at something. But the instructions need to adapt. So for example, I have a friend that comes over and says, "Can you make me some coffee?" And I say, absolutely. Now, making coffee is the same when I'm running that set of instructions when I want a cup of coffee, but my friend also wants a cup of coffee, but it needs to be adaptable. Those instructions need to change. He may have more milk, he may have more sugar, he may have a different combination. And you may have many different friends that all want a coffee, but they want it slightly different from one another. So what you have in programming is the keyword function. This tells the compiler that you want to define a subroutine. You want to create that routine like routines inside of your mind. Then you need a symbol name. Now, don't forget, if we have something that symbolizes something, it means it's referencing something, it's pointing to something. And we know that symbols are just memory pointers, they're addresses, they're addressing something in memory. So we need to actually give our set of instructions, our list of instructions, a name so we can find it in memory. So once we've done that, then you have the parentheses, and the parentheses define parameters. Now, parameters are just variables. They're variables that can have values assigned to them when we execute our instructions. And I'll come back to this in just a second. But you can have as many parameters as you like. Then you have your curly brackets or braces. And in between those braces, you have your set of instructions. These instructions are going to complete that routine. So what I'm going to do is I'm going to have a set of instructions, and then you can return something. So when my subroutine is finished, I can return the coffee. Just like when my friend says, "Could you make me a cup of coffee?" I go off in the kitchen, I do the subroutine, I complete it, and then I give something back. I return with the cup of coffee. Now, finally, our programs need to be able to invoke these instructions. Now, don't forget, just like in your memory, when we've defined this subroutine, it's just in memory. We haven't actually executed or performed the task yet. All we're doing here is we're defining the execution context. We're defining the instructions to run. However, we are not invoking these instructions until we want to make a cup of coffee. Just like this routine is inside of your mind to make coffee, but it's not actually being executed until you want to make a cup of coffee. So for example, we call up the symbol name. Now, you know when something symbolizes something, like an address symbolizes the location to your house. Well, likewise, we have these symbol names, and they allow us to address, point to in memory, our instructions that we have defined. So we can call these instructions up and we can invoke them. And we use the parentheses to do this. Also, you need to pass in the values. So how much sugar, how much milk, and so forth. These are called arguments. Arguments are values, and parameters are the empty boxes or variables waiting to store the data. And then we can use this data in the execution of our instructions. It makes it adaptable. so that I don't have to write every subroutine out there for different combinations. For example, you've got maybe different amounts of sugar and maybe no milk, or maybe milk and sugar. What happens then? Do I have to write a subroutine for every one? No, because I can pass in arguments, values, for each instruction that I want to run, for each cup of coffee I want to make. Therefore, my instructions are adaptable, and that means that I can just write one subroutine that adapts depending on the coffee that I am making. So that's what we have here. We have a subroutine, and we have it adaptable by the parameters and the arguments that are placed inside of the parameters. They're just variables. And then once we have finished executing our instructions, we can return. You can, if you want to, you don't have to, return an output after all the computation is finished. And also what happens to the parameters is those empty boxes are deleted out of memory. Think of it like we're putting it in the warehouse, but the warehouse needs to be cleaned every now and again. And what we want to do is we want to take these parameters, these variables, and we just want to throw them away. We want to get rid of them in memory. We want to clean the warehouse because we don't want these anymore. We only want the parameters when we're executing the context. Otherwise, what happens is we will fill up memory and we'll be wasting memory because we need to run this subroutine over and over and over again for each friend. But we don't need to keep on storing these values. Once I've made the coffee, it's done. I don't need to say, right, I remember how much sugar's in there now that I give it. No. I don't need it anymore. I can get rid of that data. We always want to make sure that our applications are using as little data as possible or cleaning up ourselves as much as possible. So what happens is once it's finished, these parameters, these variables get deleted out of memory. Now, we know that parameters are variables. They're empty boxes waiting for values. And of course, those values can vary when we execute. So we know parameters are variables. We also know that arguments are values. But why do I say arguments instead of values? And why do I say parameters instead of variables? Well, first of all, you've got parameters. If I say, please add this parameter, I didn't need to say to you in that sentence, function. You automatically knew because I said parameter, that is a variable defined for an execution context. You know I'm talking in context of a function. You know I'm talking about a function. And also I can say, please pass in this argument. You know I'm talking about a value that needs to be passed in when we're invoking a function. I didn't need to say in that sentence, invoke a function, but you knew immediately because I said argument instead of value and parameter instead of variable that I am talking in context of a function. I'm referring to, pointing to a function. And that is why we don't say variables and values, we say parameters and arguments. So here I have my existing application, which I have the index, and then I have the myapp.js file. And the myapp.js file contains our make coffee function. And in here you can see we have our parameters, which are just variables that store values. And then we also create a variable inside of the execution context, inside of these curly braces. Now it's important to note that if you create variables or constants and so forth inside of these curly braces, they are also temporary as well. Once we've finished, once we've got down to here, we've executed all these instructions, we delete all of the variables. This variable right here, these parameters, all of this gets deleted out of memory, and that's it. We just keep the instruction set. That's it. So once we have created this, we create a variable. It just contains a simple string, boil water. That's the very first thing we do. And then we're using the plus equals assignment operator that will concatenate our strings together. So the next string we put together is pour into a cup. Then we add coffee granules. And then I'm doing something interesting here. We say plus equals and then we say add. And then you'll notice I'm using the plus operator again. This is concatenation, but this time I'm not concatenating a string. I'm actually adding in the value. So let's say sugar contains the value of 0. Well, actually what this is going to do is it's going to concatenate in the value of 0. So it will convert this into a string and it will turn into one large string. So no spoonfuls of sugar, for example. And there you go. That's all it's doing. So we just need the concatenation. You'll notice the plus is on both sides as well. So that's what we're doing in. We're concatenating in the value, the argument that's stored within our sugar parameter into the string, and that's all it's doing right there. So add X amount of spoons of sugar. You can see now it's adaptable. And then also we're going to do the same thing for the milk. And I want a percentage sign. So I'm going to put a percentage sign in there because milk is just going to contain an integer again. So it will say something like add 20% milk. And that's it. That's all it's going to do. So once we've done this, we return the entire string. All of these little pieces that make up our string, our instruction set, will return this entire string by returning this variable, the instructions variable. Now don't forget, this variable will be deleted after we have finished executing, but the output, the actual string, will be returned, and we can do whatever we want with this string once we have returned it. So that's what we ultimately want back from our make coffee function or subroutine. Now, if I go ahead and open up the index page into the browser, and then I also take a look at inspecting it and going to the console, I want to take a look at, first of all, the window object. The window object, again, think of it like the giant warehouse full of all of the little memory pointers that we have. And you'll actually notice that if I was to scroll right down and we keep going, we do have a memory pointer in here for make coffee. There it is. Make coffee is a symbol. It's symbolizing, meaning it's like an address. It's pointing to our instructions in memory, and it is in fact a function. So we've got make coffee. There is our instruction set, and now we can invoke this. Now, if I was to just invoke it within my script, so if I was to say make coffee, and then I was to say, right, pass in 2 sugars, and we want 20% milk for my good friend here, and I was to go ahead and save this, what I would do now is try to take a look at this in the browser. So let's hit refresh, and if I open up the browser, nothing happens. So what we need to do is, again, export this out to the console. So we're targeting this console interface, this text interface, and then we're logging out. You want to log something, you put it in a ledger and so forth. We want to log out the output, the return from this function, which is the string. So if I go ahead and now hit refresh, and then when I look at this, there you go. It gives me the return. Boil water, pour into cup, add coffee granules, add 2 spoons of sugar, and 20% milk. It just returns the string, and it logs it out to the console window. And likewise, we can actually call it from the console interface, because don't forget, it's in memory. It's in that window object. We've got a symbol called make coffee that points to those instructions, and then I can go ahead and say 5, and maybe I want 50% milk this time. And you can go ahead and keep changing the values so that this is adaptable. And that is what we're talking about with subroutines. We define that routine, it's in our minds, and our minds can adapt this routine depending on what we're doing, and then you can invoke that routine. You can actually perform that subroutine, that action, and then you can keep changing it as you go along. So that is subroutines. Objects and arrays are used throughout our entire lives, and they'll also be used in our programs. Our programs typically represent objects in the real world, so we need to make sure we understand objects and arrays. You can see your television, car, and all of the other objects that you use throughout your daily life, and they are obvious for what they are. Objects are obvious, but you also use arrays, and this may not have been so obvious in your daily lives, but what do you use in your daily lives that are arrays? Well, you could have, for example, a list of to-dos, a shopping list, a teacher that has a register full of names for the registered students in that class, and all sorts of registers for your cars, for your number plates, and all the rest of it. These are arrays. To understand programming, we need to understand when do we use a standard object and when do we use a special type of object called an array. An array is an object, but it's a type of object. So first of all, let's take a look at objects and couple it with obvious. Objects are obvious. When you look at your computer, your smartphone, your television, your car, your house, you can identify what it is. It's obvious as an object. And objects in programming, what we first of all do is we put in the curly brackets or braces, and within those braces, everything is grouped together. For example, if you have a car, you need the nouns and adjectives to describe the car. So the nouns would be the key name, such as color, and the adjective will be the value, such as red. So it describes the noun. And by these nouns and adjectives, we can describe the look of this object. And you can do that for all objects. And these are called properties. Properties have a symbol name, which point to a value in memory. And we call these key names whenever those names are in an object. And the values are the values stored in memory. And that together, the key and value pair, is called a property. But what happens when you need to perform an action on the object? You know that staring at your computer will do nothing. You need to type and you need to click. And likewise with a car, you need to get in it, drive it, lock it, unlock it, open the sunroof, turn on the radio, do whatever it is that you want to do inside of that car. So what you have is the subroutines or the functions that you can perform, those actions that you can perform on the actual object itself. Now, when you take a subroutine or a function and you place it inside of an object, it's called a method. And the reason why we do this is because if I say to you, add this method, you know immediately I am talking about a function or a subroutine that is within an object. It's for an object. So that is why we have these precise terminologies. This is called a method, where you have a key name. Don't forget, it's a symbol. It's pointing to something in memory, and it's pointing to an instruction set, a set of instructions you can perform on that object. And so that's what we have, that subroutine or that function. And the reason why we're grouping these together by the braces is because if these values just floated randomly around our program and they were not grouped together by these braces, then it will be pretty useless. Now also you have arrays. Now arrays are objects, but they're just a special type of object. Just like a shopping list in your hand. Well, the shopping list is an object, but it's a list. So whenever you think about a list of car names, a list of products in the warehouse, a list of names registered for a classroom, a list of registration plates for the driving authorities. It's a list. It's iterable. In other words, it has elements that make up the complete object. So for example, a shopping list has lots of elements inside of it. And these elements have numbers assigned to them. Now we define an array with the square brackets and we group our tasks, our list together in the brackets. And each element is assigned a number because we know typically what a shopping list will have. A shopping list array will contain items found in store, and also a to-do list would typically contain tasks. Each element will now be a task in our to-do list. We understand the type of thing we're pointing to. But you'll notice that each thing in the shopping list is unique, it's identifiable, and each is on their own. An apple is not an orange, and an orange is not an apple, but yet we're grouping it in this shopping list. This list that's pointing to different objects around the store. That each element is assigned a number. We need to be able to pick out and identify our elements in the array. We need to iterate over, so go one by one by one. And it's zero indexed, meaning the first element in the array has the value of 0. And then we go up from there, 0, 1, 2, 3. Now it's important to note that in JavaScript, whenever you modify an array, the key names are automatically updated. These numbers are reassigned potentially if they have changed. So the program actually organizes your elements for you. And that's the beautiful thing about an array. It will keep your list together. It will keep those key names. And the elements inside of the array will be your elements. And you can take elements out and you can add new elements in. And everything will be managed by the programming language. Recap. Objects are obvious. We have objects defined by the braces or curly brackets, and we have the nouns and adjectives that describe the object, the nouns being the key names and the adjectives being the values. And these are called properties. Properties describe the object. Then also you have the subroutines, or the actions you can perform on that object. And when you place a subroutine inside of an object, it is in fact a method. And again, it has a key name, a symbol name to point to this action, this list of instructions to complete the action. Then we also have arrays. Arrays are lists. They contain similar types of things, such as names or car registration plates or items in a shop. They contain similar types of things, and they list out these similar types of things, and each one of them is called an element. So let's start programming this out, and we are going to start with the myapp.js file. Now, we can create an object in the console window. That again, to create an object, we just open and close the braces. This is called an object literal. It literally means we're creating an object. And there you go, we've just made an object. But there's no way to reference this later on in our program. So it would have created this object and then it would have destroyed it out of memory, because there's no way my program can later on point to it. So if my program can't refer to this object later on, it's a waste of time. Get rid of it, get it out of memory. Again, it's all about speed and decreasing the amount of memory your program needs to execute its tasks. So I'm not going to create the object in the console window. It's a bit too limited. So let's go back over here and let's create a variable. And a variable allows us to define a symbol name, such as car. And I can use this symbol name to target this object in memory, and then I can end with a semicolon. Now I have an object right here and I can save it, hit refresh, and I can type in car, and there it is. There is my object, but it's empty. It doesn't have any properties. I can't see it and know what it is. I can tell that it's referring to a car type of object, but we've got no properties to describe the object. So let's go ahead and add those now. The first thing we'll have is the key name color, and then we have the value, which is going to be red. There is the noun and there is the adjective that describes the noun, and the key and the value pair is called a property. It describes the object. And also we assign values this time to key names via the colon. And we can keep adding in more and more key names. And if you want to add in another key name and value or another property, then you need to put in a comma, and then you can have another property, such as speed, for example, is going to be 200. Now I want another key and value pair, but this time I don't want the value to be a primitive value or an object or an array. I actually want it to refer to a subroutine or function. So I have drive, for example, and drive is going to have a subroutine in it that will return drive. And there we go. We now have two properties and we have one method. This key and value pair, the value being a subroutine or function, if that's the case, that is a method. So we've got properties and then we've got methods. And so what we have now is the ability to save this, refresh the browser and type in car. And when we do this, you'll notice we have the properties, color, and speed, and we also have drive, which is a function. And this function is contained within this object called car. So that is how you create objects. Then very quickly, let's create a shopping list. So I'm going to create another object called an array. Again, we need to refer to this object later on in our program, so we need to give it a symbol name so we can reference it in memory. And then we can define an array by literally, this is called an array literal, by opening and closing the brackets. That's called an array literal. We're literally creating an array. And this time, you don't define the key names like this, 0, and then you say Lawrence, for example. The key names are already assigned for you. They're automatically done. You just want the values. So right here, this would be apple. And then we have another item in our shopping list. So we want to add in the comma again, apple, orange, and so forth. And let's have pear as well. So you have all of these different items or elements within the array. And then let's go ahead and save this and preview in the browser. and we'll say shopping list. And there it is, shopping list, apple, orange, and pear. There is our list, and you'll notice that when I open this up, it is an object. You can see the similar type of syntax with the colons and so forth with a regular object, but this time it's actually assigned the numbers for us, and the program will manage these elements. If I was to delete orange out there, for example, pear would become 1, and so forth, and it will manage those key names, so it's easily iterable. So that is how you define an object, and that is how you define an array. Hi guys, I hope you are finding this content really useful and adding value into your life, and I'm serving you the way that I should be with that great service of knowledge and information, and hopefully getting you excited about your career. And I hope you can get the value that you need out of this. And if you are and you'd like to contribute something, maybe buying me a cup of coffee, hit that Kofu link in the description down below and you can donate like $3. That will be enough to get me a nice cup of coffee, and I can still keep making great content for you guys. Objects can contain other objects. Also, arrays are objects. You can think of it like a car engine, or pretty much any object. Even your computer is made up of many objects. When we look at these objects, we see one entire object. We see the overall hierarchy, but you can dig down deeper and deeper. Just like a mechanic takes a car engine to pieces, you have the car object, you have the engine, and the engine has many objects inside of it, including the head gasket, pistons, and all the rest of the rods, nooks, and crannies that go in there. And then the steering wheel, the interior, the seats, the headrests, all the rest of it is all based on objects. And when we group these objects together in a giant hierarchy, we have one object, but we understand that objects contain objects, and that's how it works in programming as well. So here we're going to start out with the myapp.js file, and I'm first of all going to create a symbol, a memory pointer, and we're going to create a car memory pointer, and we're going to assign the object. So whenever we reference car, this will pull up this object in memory. And then we want the make of the car, for example, we'll say Volvo, and then we have the speed, 160 miles an hour, so that's very quick. But then also what I'd like to do is I'd like to put an engine into my car. So let's go ahead and create an engine object. Now again, I'm using the colon for assignment, and then all I do is I put in another object. And this object is still going to help describe this object. If I know an object contains an engine, for example, I know that it's going to drive the car. It's going to have some kind of movement. So this is actually still called a property. This key and value pair, as we have key and value pairs right here, this is still called a property. So even if you have an object, which is a standard object, or an array object, it doesn't matter. It is still classed as a property. So we are creating a property here, the engine property, and inside of here we can have, let's say, the size of the engine, which is going to be a 2 liter. There's a floating point number for you. And then also we can say make, and the make can actually be from another manufacturer such as BMW and so forth. And also we can have the fuel type as well. The fuel type could, let's say, be petrol. So there we go, and we can keep going with this. For example, I could have pistons as well, and again they can be an array, for example, and we can have an array of piston 1 like so, and piston 2. Now don't forget, arrays are objects. We must remember this. So I could make this another standard object, or I am instead making this an array because we have an array of pistons. We have many pistons, and typically every piston is the same. So what I could do is, as an array is a type of object, don't forget it is an object type, I can actually embed objects into the array. So for example, we can have an object for each piston. Now, a car doesn't typically come with 2 pistons, but this one does. So we have the pistons, we have an array of pistons, and each piston is an object, like so. So objects can contain objects, arrays contain objects, and objects can contain arrays. They're just classed as objects, really, to the programming language. So now we have a list of all the pistons because they all carry the same similar type of thing. And so each piston can, let's say, just have the maker. We can have the maker and we can set that to BMW. And you can go into even more detail by embedding more objects into this object and arrays and so forth. You can just keep on going, embedding objects inside of objects. And you can see there is a hierarchy. A hierarchy means a structure, just like the food chain is a hierarchy, or your place of work has a hierarchy with the boss sitting at the top and then it goes down to directors and other things like that. So that is a hierarchy. We have a structure in which our object is created. So we have the main car object with these properties. Then we have the engine that's embedded inside of it. This is another property, but it's an object embedded inside of this. So there we go. We've embedded that. And then we have the size of the engine, the make, the fuel, and so forth. And then finally, we have another object, which is the array. And the array has multiple piston objects inside of it. So that really is the whole hierarchy for our car object. Now, if I go ahead and save this and I open it up inside of the browser, let's go ahead and type in car. There is my car object. So we referenced it in memory and you can see the make and the speed, but then you can also see engine is an object and I can expand that. And you'll be able to see we have the fuel and make. And then also we have pistons. Now pistons is an array and it tells us how many elements are contained within the array. This is really nice. You can see here we have 2 elements, 2 objects. There's the first and then there's the second. And don't forget to separate out each value with the comma. And there it is. I have an array. And I have 2 objects. So we have the first object with the index of 0. Don't forget it's 0 index. So this is the 0 indexed object. And again, this could be a string or it could be a number. It could be anything you really wanted it to be. And there we go. So we have an object, maker BMW. And then we also have the second piston object, which is exactly the same. Let's change that to BMW2, in fact, so we can see a bit of a difference here. So car. Open this up, go to the engine, go to the pistons, and the second object with the index of 1 is maker BMW2, and now the first one is maker BMW. So now we have an entire hierarchy, a structure and a stack. And also I can create an array. And again, I'm going to create a memory pointer to my array. And an array can contain a variety of things, such as a string or a number, or in fact, it could contain another array. So I can have another array and I can say embed and I can say 200. I can also come out of that. So there's the string, there's the number, there is the embedded array, an array inside of an array. We have embed 200. And if I stack this down a little bit, like so, you'll be able to see each value on a new line. And I can also embed an object inside of here as well. So I can say car is going to be Ford. There is an object, and again I can embed objects inside of objects. Arrays can embed objects, and objects can embed arrays. These are all properties, by the way. If it's not a function as the value, it's classed as a property. And here's something really cool, is the fact that we have methods in objects. So I can create a function or a method called drive, and it returns the string drive. So that is a method within our car object directly. You could put this inside of the engine object, and even what you could do is take this function right here and you can place it inside of an array. So you can place functions inside of an array. Now what's important to note here is you don't have a name. These are called methods because methods have a key name that we can define in a standard object, and then we have the subroutine that will perform that particular action. In an array, we don't have that anymore. We cannot define a name for our function in the same way. It's given a number. So let's take a look at this now. Let's take a look at the array. So if I go ahead and refresh, in car you can now see that we have drive, and by the parentheses we can see that it is in fact a method, a subroutine waiting to be executed. And then also you have array. Now with array we have 0, the first element is the string, 100 is the second element with the index of 1, 2 is an array with 2 elements, which is embed and 200, and you can see that there. It has 2 elements, 0 embed, 1 200. Then also you have the object as well. The object that I've embedded has one property called car and the value Ford, and there it is. Then finally we also have the fourth element. Now you'll notice the fourth one is in fact a function, and there is my function. This is the drive function, but I can't give it a distinct name. The memory pointer is actually the number 4 this time, not as in the standard object, which the memory pointer was drive. So that's it. We've established that objects can contain other objects can contain the array type object, and the array type object can contain objects and other array objects as well. You can just keep embedding objects and arrays inside one another, vice versa. Doesn't matter what order you do it in. You can keep on embedding and embedding. So go ahead and take a look at playing and experimenting and try to do this yourself. Try to make this hierarchy yourself. Write it from scratch and really learn how the syntax flows and how things can be embedded inside of other things. Try to do it for your computer or for, let's say, other components or other objects that you work with in your house. Try to make an object hierarchy, whether it be a cabinet with drawers and so forth. Let's try to really learn this hierarchy and the syntax that goes behind it. So we have a variable called car. Now let's say we're the mechanic and the program would like to actually pull out specifics about the car. Sometimes he wants to go to the bookshelf and pick a book out for that car so he can understand the mechanics of the car and he's got details. So all he'd like to grab out is, let's say, the maker of the car, such as Volvo, or he may want to know the speed so he understands what piston heads he needs or what type of engine he's working with. So by this, our programs need to be able to access members inside of an object. Now, whether you have an array or whether you have a standard object, they're made up of members. Now, standard objects are made up of, let's say, properties or methods. These are all members of this object. You can look at this like a community of properties and methods. And these are all classed as members of this entire object. And also with the array, for example, you have these elements. Each element is, in fact, a member of the array. That's the terminology we can use. And if we take a look at what we have here in JavaScript, we have an operator called member access, and it's the dot symbol. So this could be the object itself, such as car, and then we can access one of its members, member access. So we can access one of the members, such as make or speed or even engine. So let's go ahead and take a look at this. What I can do is I can either write this out in the script, which I can do, or I can directly type it out in the console. So let's target the console first of all. So we're creating a reference in memory called car. We made it here, and now we're targeting it, and we know that it finds it in memory. But now let's go ahead and pull out make. Well, this is a member. Make is a member. So I'm going to say car.make, and what it will do is it will look at this symbol first, car, and then it will access this symbol's value, which this symbol points to a string in memory. And again, you can end it with a semicolon if you really wanted to. And there it is. It pulls out the string Volvo. Now, likewise, you can log this out to the console. So I can say console.log, And again, we have a memory pointer car dot and then make and end with the semicolon. And that's it. And if I hit refresh now, you'll automatically see the string Volvo appears, and it came from myapp.js file right here on line 24. There it is, line 24, and it shows me the actual string. So we've just accessed, first of all, this symbol by typing in car, then we've accessed one of its members with the dot syntax, and then we type in the symbol name, and so forth. So we can also have car.speed, for example, and you can even access, let's say, car.engine. An engine is an object. And in this object, you have fuel, and you have make, and you have pistons, and you have the size of the engine as well. So here is our object. Now, how do we access one of these members? Well, you do the same again. So car.engine refers to this object, and then you use the dot syntax again. And then after that, you can type in one of the members you want to access inside of this object, such as the size, or the make, which is BMW, or the fuel right here, which should be petrol. So what we're doing is we are targeting the main hierarchy, the very top of the tree, the entire car object, and then we're going inside of it. We're always going inside of it with the member access, and we're accessing each member. And each level that we go into, so each object, we're using the dot syntax to access each level's member. And you can keep going with this. Now also, what about methods? So for example, I want to run or invoke the drive method. How do I do this? Well, if we say car dot and then drive, they needed a name so we can target that subroutine, and then with the parentheses, we can actually invoke, meaning run this function, this subroutine. And if I end with a semicolon, car.drive, and all it will do is return the string drive. After all the computation, after this execution context, this list of instructions, it only has one instruction, and that's just simply to return the string drive. So let's see what we get returned. There we go. And I've written dive instead of drive. Just notice that one right there. So anyway, we are returning the string drive. Now, if you just say car.drive without the parentheses, notice what it does. It actually prints out the function or the method that is contained within this object. The same goes for regular functions as well. It will just print out the actual syntax. That's all it does. So if you want to run it, you need to make sure you put in the parentheses or round brackets. Then it will invoke this execution context. It will run it, and then it will deliver whatever is finally output from the computational function. And you might have noticed this syntax may look a little bit familiar. We've got car.drive, but we've also got console.log. And so what is this? Well, we're looking at a symbol name called console, and it's referencing an object. Because we have the dot syntax, it has members. If it has members, it's going to be an object. And then we have the member log, which is a method. It is a function that is being invoked by these parentheses, and we're passing in arguments or values into this method. Let's take a look at this. You go to the window object. We open up the warehouse full of boxes, and these boxes have memory pointers so that we can find these boxes. And if I go ahead and scroll right down, you'll be able to see there is a memory pointer called console that contains an object. And in there you have all of these different things that you can use to look at memory, and you can log information out, and you can get info of certain information. So this is the method that we're running. There's lots of other methods that you can actually do to log out certain pieces of information, like the timestamp and so forth, if you want to check how fast your script is running and so forth. So we're running this log method found in the console object, and that's what we're doing right there in our script, which will produce the string Volvo because we're targeting this property in our car object, and we're logging that value out to the console. Now let's get back to accessing multiple levels. So you've got car, then you've got the engine. So we're expanding this object. Now we're in this object. What we can do is we can target one of these properties. And you'll notice one of these properties contains another object called array, called pistons. So I can say dot pistons, like so, and end with a semicolon. And this will give me the array found here with two objects. As you can see, two objects, 1, 2. This one has the index of 0, and this one has the index of 1, which is BMW2. So here we have an array. Now, how do we actually access members of an array? Well, if we take a look at car.engine.pistons and then say .0, now 0 is the key name. You'll see there that is the key name for the first object. Let's see what happens. We get an error that said unexpected number. So what it's doing is it's treating this member access as though it were a number instead of a memory pointer. I want it to treat 0 as a memory pointer, as a symlink or symbol link. If something symbolizes something else, such as the name of a box, symbolizes that box. A memory pointer, well, this in this case is actually being treated as a number, not as a symbolic link, as a reference in memory, and or treated as a key name will. So we actually have a huge problem here where we need to be able to access objects or elements inside of our array. What about this array? How do we pull out each individual value? Well, this is where we have the computed member access. The computed member access calculates and works out whatever is in between the brackets, and whatever is returned is treated as a memory pointer, whether that be a number, it could be a mathematical expression, it could be a statement in JavaScript. So this is what we're going to look at in the next lecture. In the previous lecture, we tried to access one of the members inside of the pistons array. We tried to grab one of these objects. Unfortunately, it didn't work. It treated it as a number instead of a symbol link or memory pointer. Now, you have two choices. You can try to access a member by the dot syntax, or you could do it with the computed member access. Now, this operator uses the brackets, and inside of the brackets, it computes and then it delivers the result. So instead of using the dot syntax this time, I want to now change it to the brackets. So you either use the dot or you use the brackets, but you cannot use both. Don't forget, you use either this operator to access a symbol or a member, or you use the brackets to access a member, but you don't use both. So you don't say dot brackets. That's not allowed. You use one operator or the other operator to access a member. So now we're looking inside of the pistons array, and we're grabbing the element with the ID of 0, which is this particular object. So I can go ahead and take a look at this now, and you'll notice it returns that object, make a BMW. Now what happens when I want to actually target this property specifically and just return the string BMW? Which operator should we use? Now don't forget, this is a standard symbol link or memory pointer with the word maker. And what have we been doing prior? Well, we've been using the dot syntax to actually gain access to these members with a simple name. It's only when it turns into a number, this number is computed inside of the brackets, and what's returned is a symbol link instead of a number type. So what I can do now is use the dot syntax again. So we're inside of this object. Then we're saying, right, I want to access a member inside of this object. So we're going to the next member, and that is going to be maker. So now we're going to pull out the string BMW. So you can mix and match. You can either go with the dot syntax, or if you come to, let's say, a key name that is a number, such as an array, then in fact what you want to do is use the brackets. And likewise, we can do the same for the array. Now the array is an array, and each one of these members in our array has a number. So for example, you could pull out the string. This has the index of 0. So I can say array and in the brackets 0, this will return not a number 0, but a memory pointer 0. And so then we have string. You can even pull out a function, for example. How do we invoke this function right here with this spelling mistake? Is we access it by its number, by its ID. So we've got 0, 1, 2, 3, and 4. So this is actually the key name 4. And then what happens then? Well, if you just run it like so, it just prints out the function. How do we get it to run this execution context? Well, how we get it to run this execution context is you target it and then you put in the parentheses. And when you put in these parentheses, it tells it to run this execution context. Notice what happens. It runs, and then of course it returns the wrong thing. Let's do that again. Drive. And there we go. It returns the string drive. So this is quite nice. Now you know about mathematical expressions and statements. When we write something out, such as var a equals, and then you put in a value, for example, you can, in fact, create a statement. That is a statement. It's a command. It's a sentence you're giving to the JIT compiler and it's executing. And then also you can have mathematical equations, such as 1 plus 1 minus 1. And what is that going to equal? That is going to equal 1, or let's say minus 2. So we have all these operators here, the plus and the minus operators. You're going, well, I know that, but this is a statement, and this is also a statement. Now, when you have the computed member access, whatever is inside of the brackets is treated as a JavaScript statement. So for example, what I can do now is I can clear this out. Let's say that I target the array this time, and I'm going to do something a little bit different. Inside of my brackets, I'm actually going to write out a statement. 1 plus 1 minus 2. So whatever is in between these brackets will be executed, will be invoked, and it will return the value 0. So if I go ahead and hit return, you'll notice that it returned 0. This is like saying array returning 0, the number 0, and that will be used as the symbol link. And there it is. String. So you can see that we can write mathematical expressions inside of here and also regular statements as well. Because don't forget, you can actually use variables in your mathematical expressions. So you can create a variable called a and it's equal to 10. We've created this symbol link in memory and it references the number 10. And then you can say a plus 1 minus 5, which will leave us 6. So we add 1, that's 11, take away 5 is 6. Hit return, and there you go. You can use variables in your mathematical expressions, just like you use variables, algebra, in maths. So that we can change this and move things around. So now let's take A and let's use it again. So I'm going to say array, and then we're going to say A. So now we are pointing to this variable that I've created on the window object, and then I can say take away 5 and then take away 2. So if I take away 5, that leaves 5 left, and then we take away 2, that will leave 3. And what is the third member? 0, 1, 2, and 3 is in fact our car object. So let's go ahead and hit return. And that's exactly what we get. It's the same as typing array. It computes what's inside of the bracket. So a minus 5 minus 2 is equal to 3. And then it returns that as a symbolic link. It executes that statement. It's computing the statement, whatever is inside of those brackets. And there we go, it's returning this. So if we want to dynamically fetch something out of an object, like writing an expression, we can do this. Now what about, let's say I want to access car, and then I want to access the make symbol. But this time I don't want to do it the traditional way, so car.make. Instead, I want to use the brackets. Now here's the problem. It's actually going to look for the variable called make, which we haven't made this variable, just like we called the a variable in our mathematical expression. Don't forget, this is treated like JavaScript in between these brackets. It's a statement. So if I was to change this to, let's say, make, you'll get an error because it's looking through the window object, it's looking through the warehouse, the window, and it cannot find a variable called make. But we do have this property here called make. So if I was to say car, and then I was to turn it into a string, now what it will do is it will return this primitive value, it will do the computation, and there's only a string here, and it will turn this string into a memory pointer called make. So you have car make, and then you can see it pulls out Volvo. So please be very careful when you want to access certain properties with the computed property. Treat it like you writing a statement out like that, saying make right here, and you can see, sorry, it's not been defined, just like we got right here. It's like writing it outside of the brackets. So it's computing what's in between there. It's looking for variables and so forth. And you can keep going with this. So you have car, and then you can access the engine object, this object here. And there we go, we have that object. And then you can go ahead and access the pistons as well. So we can say pistons, which is the array, and we have an array of 2 objects. The first one has the index of 0, the other one has the index of 1. So let's go ahead and grab this out. So I'm going to say pistons and then 1, and it will grab this element right here. And then I can even use brackets again and say go grab the maker as well, which stores the string BMW2. So we go to car, then we go to engine, then we go to pistons, then we access the second object in the array with the index of 1, then finally we go inside of the object and we grab out the maker property there, which stores the value BMW2. And you can do lots and lots of powerful things when you use the brackets, and you can still invoke, let's say, subroutines as well. So again, I could say car, and then I can access drive, for example. So now I'm accessing this method, and then what I can do is I can invoke this with the parentheses after it, and there it is. It returns the string drive. Or if I don't put in the parentheses, I can actually see the function syntax itself. So that is the brackets. You use brackets for, let's say, writing statements out. This could be a mathematical expression. You could also target a variable. So I can say var pointer, and pointer could be, let's say, make, for example. And then I can end with a semicolon. And then I can say, right, target car. And then I want you to go grab the variable called pointer and grab its value, which has the string make. So this will return the string make, and that will return Volvo. It's the same as writing car. It executes whatever is inside of the brackets. So the bracket says, right, there's a variable called pointer, and we return that value, which is make. So it's the same as writing make, and then we return it. So there is the value Volvo again. And if I was to change pointer now, pointer is a variable, so I can change its value to, let's say, speed. So pointer is now equal to the string speed. Let's go ahead and say car brackets pointer and hit return. And there we go. Now pointer is returning the string speed. It's returning that in those brackets, that computation. It takes that string and it turns it into a memory pointer. And there it is, 160. So that is why we have the computational brackets. You can also do all kinds of things like concatenation inside of here. So for example, let's say I have car, and then we have en plus gin, like so. What will this do? Well, it will concatenate. The plus operator concatenates, meaning joins together these strings. So it will join together these strings, which will be engine, and it will return that and turn it into a memory pointer. So I can say, like so. So this will be computed, whatever is inside of the brackets, and it will return the string engine, which should return this object. It's the same as writing car and then engine in the brackets. And also what you can have is car.engine. So you have this ability to mix and match between the dot syntax. And if you need a bit of computation in there, such as the elements in an array that is a number, or if you'd like to fetch a key via, let's say, another memory pointer like a variable, then you can do that with these brackets. So now that we've created our hierarchy and we're able to access this hierarchy and pull data out of it, what I'd also like to do is be able to create new symbols dynamically within my objects, and I would also like to assign new values. So again, we're going to be using the console, and you can run along with me. And so what you have is the car, and you can target the car, and you know that this is a variable. So car itself is an object, but you could actually assign a whole new empty object, or you could assign a string or anything else. So it would actually delete out this object, and it will assign a string to the car variable. Now when I call up car, you'll notice it's a string. It deleted this object for a string. So that's entirely possible. Now on top of that, what if I just wanted to change one of the values, such as the string Volvo that's being logged out to the console? How can I actually change this? Well, what you need to do is you need to, again, target what you want to assign. So last time we targeted the entire car hierarchy object and we deleted that and we replaced it with a string. But now what I'd like to do is I'd like to target a member called make. And now we're targeting this member, we can assign a new string such as Ford and with a semicolon. So it's going to target this symbol in memory, and it's going to look at this value and it's going to change this value for the string Ford. And there we go. So we have car.make equals Ford. And now if you take a look at car, we still have the object here, but the make has now been changed to Ford. Now also, don't forget there are other assignment operators that we can use. So for example, we know that car.make contains a string, and we know that we can use the plus equals operator. So we're going to concatenate because we already have a string here, and whether there's a string on the left side or the right side over here, it will convert it into a string. I could even put in a number right here, such as 200. And when I do that, you'll notice it converts the number into a string, and there it is, Ford 200. And you take a look at the car object, there it is, make Ford 200. So that is also the assignment operators. Don't forget about the other assignment operators for mathematics and so forth. So for example, you have car.speed. And again, you can access it this way, or you could access it with the brackets like so. And we can say, for example, times equals 2. So 2 times 160. And that's going to leave us 320. Take a look at car. There's car. The speed is now 320 miles an hour, fastest car on the planet, Ford 200. There you go. And you can also reassign, let's say, objects as well. So we've got this engine object. Let's just very quickly say we're going to take the engine out. So I'm going to say engine equals, and then you can assign a new engine. We can set that to new. And when we do this, take a look at car. You'll now notice that we have engine, and it's replaced this object with this significantly less complicated object that just has a property new engine. So that is pretty cool. And you can even reassign, let's say, the methods. Don't forget, this is just a symbol name pointing to a method or subroutine or function. So for example, you could say car.drive equals, and then I could just say drive. Since this subroutine doesn't really do much, it just has the string drive. So now when I look at car, it is no longer a function, it's just a standard string that's nice and easy. But how do you create, let's say, a new key? Well, how do I do that? Well, we're starting out with car again, fresh, and we've got drive as a method. You've got the engine object, make and speed. But let's say that I would like the model. So how do I put the model in here? So I'm going to say car dot and then model. You can think of this like saying var model. you're creating a new symbol name because this symbol name currently does not exist within this object. And then what we can do is we can assign a new model, such as V60, for example. So car.model equals V60. Let's go ahead and do this. And now when I take a look at car, you'll notice that it actually created the model symbol and it has the value of V60. So that is how you create, just like you would create a new variable, that's how you create a new key name, a new symbol or memory pointer within this object. Very nice. Now also, what you could do is say car.color, for example. And let's say that I don't even put anything in here. I don't assign anything. Car.color. Well, you'll notice it just says undefined. Sorry, I didn't find that property. And if we take a look at car, you'll notice it didn't actually create that property. So you need to make sure that if you want to create it, you can't just create it like var color, for example. That will create a variable called color, and that variable, that symbol will exist, but it will be undefined. If, however, you want to create a symbol name, a key name, inside of an object, then you need to assign it right then and there. So I can say car.color is equal to red. And only at that point when you assign a value, will it actually create that symbol inside of the object, color red. That's how you create a new property or member But we can also create new methods as well if you would like. Just treat it the same way. So car.stop. This doesn't currently have a symbol link inside of our object. And then we set it equal to, so we want to create it, and then we want to create a function, for example, that will return the string stop. And when I do this, I can hit return, and then if I type in car, you will notice that inside of car, we now have the stop method. Also, you can add and change things inside of the engine object. So for example, we can say car.engine.stop equals pretty much the same function again. And we could say stop engine this time. And then when we take a look at car, open up engine, we targeted the engine, then we actually created a symbol called stop that didn't exist, and we set it equal to this subroutine. And this is now a method in our engine right here, this stop. So that is actually very easy to do, and you can change values in the engine and so forth. So I can clear that out. So that's how you create methods. Now finally, how do you delete certain members? So when I take a look at car, let's say I no longer want color. How do I get rid of this property? Well, if I set car.color equal to null, well, that won't get rid of it. It will nullify it in a way that it won't have a value. It'll say there is no value, but null is still a value, and this symbol link is still here, and it's a waste of time being here. So how do we completely remove it? Well, what you do is you use the delete operator, and then you define the symbol link that you want to delete, such as car.color. It will find that symbol link right there, and it will just simply delete it out. Now, this operator delete is a function, don't forget, in the JIT compiler, and if it manages to successfully run its operations, then it will return true. If it couldn't delete the particular property or method, it would say false. Sorry, I can't delete it. So it did manage to delete it. Now I can say car again, and now you'll notice there is no color property. It's been completely removed. This symbol link has been completely wiped out of the memory map. Now, finally, what we can do is you can also delete methods as well. So you could say car.stop. So we can delete that method that we created, hit return, and then you can say car again, and you'll notice that method has been removed. We only have the drive method from now on. So it's pretty much a death trap for a car. So that is how you assign, create, and delete members within a standard object. Arrays, however, are a little bit different. and we are going to take a look at modifying our array in the next lecture. Now let's take a look at modifying members of an array. So the first thing I'd like to do is I'd like to change this string here. So what I could do is we can type in array and then we have the brackets, and the number that's returned is now going to be a memory pointer. And if I hit return, it returns the string. If I'd like to assign a new string, I can use the assignment operator and say new string. And you'll notice now when I open up my array, it says new string. And also don't forget you have your other assignment operators as well. So now I've refreshed the page, so array 0 is going to be the string, and then I can say plus equals, and then you have concat, and you have all of these other assignment operators that you can use for strings and integers. And if I take a look at array, you'll notice it concatenated string and concat together, and it gave us string concat. So that is assignment in arrays. Now also what we'd like to do is be very, very careful when using the bracket syntax, because an array is treated as an object. So what you could do is say array, and then you could say, right, I want to create a new element. Well, that's fine if we know how many elements there are. This is 0, 1, 2, 3, and this is the one with the 4 as the memory pointer, this function. However, if I want to create a new one, then you could say 5, and then you could assign a new string value. If I hit return, I can now type in array, and now you'll notice that I do have 5, and it does say new string. But you need to be very, very careful when using the brackets. So if I was to say array, and let's say I didn't know how many there were, so I guessed, and I said 20. Well, don't forget, there is now 5 elements, because I created a new one saying new string. So now I'm saying array 20. So here it is. I hit return. Now let's take a look at my array. You'll notice right here it says after new string, what we did was we created 14 undefined or null elements. They're just nullified elements, meaning they're empty. They're pretty void and useless. For example, what we did was we created null 14 times like this. And then after the 14, we actually have the value 2020. And even though when I open this up, you'll see it's 0 all the way to 5 and then 20, it's just because these guys are null or undefined. They're still there, like I wrote it out like this. They are still there in memory, these values, but it just shows us 20 because it's not null or undefined. So we have 14 undefined or null elements in our array, and then we've got 2020. So you can see how using the bracket syntax is not very good for arrays. Also, you have to be very, very careful again with the bracket syntax, because what you could also do is not even use a number. You could actually assign a string like this, test, and that can be equal to test, like so. And you're probably going, well, that's not going to be very good, because it's no longer a list type object where we've got numbers for each one of our elements. And also you could do the same thing with the dot syntax, because again, arrays are objects. So you need to be very careful how you modify them. So let's do test2 and test2. So you can either use the dot syntax, now we're using this regular symbol name, or you could do it with the brackets with a string. Be very, very careful what you do, because now when I take a look at array, you'll notice that this object now has test and test2. Now, why is this really bad for arrays? Well, arrays are supposed to be enumerable. Enumerable means countable. So if I had, let's say, 5 £5 coins in front of me, I can count £1, £2, £3, £4, and so forth. I know what the next number is going to be. Countable. But you can't count test and test2. It's not obvious what they will be. So this array object, as a list, it's supposed to be enumerable, that we can iterate over, meaning go one by one by one and count over them. But now we've ruined it because we have test and test2. So be very careful how you modify your arrays. Now also there's something very interesting to note, and I'm just going to refresh and get rid of this. You will notice that when I create an array and I assign these elements, We also have this property here. Now, this property is a computed property. In other words, this value is dynamically assigned. Whenever we modify this array, it will change the length property. The length property tells us how many elements are in the array. So we can see we've got 1, 2, 3, 4, and 5 elements in the array. Now, the first element has the index of 0, but it's still classed as an element. We've got 5 elements in this array. So it lets us know how many values are stored within. And if I was to modify it, so array 5 equals, and then we can say new value. Now let's take a look at array again. We now have 5, and you'll see the length is 6. Because now we have the index of 5, but don't forget it started at 0. If you want to know the length, it's actually 6, because this now starts at 1, then 2, then 3, 4, 5, and 6. So there are 6 elements in this array now. And the way you actually pull out this property is you say array.length. And when you say array.length, it returns the length of the array, how many elements are stored within this object. So how are we actually supposed to modify an array? Well, if I pull up the array, and then I also see a __ proto, and this is the prototype object, and I will talk more about prototype later, but the actual JavaScript language created this for us automatically. When we create an array, it attaches another object onto it, and it's called a prototype object, which we'll talk about later. But it comes with all of these different methods, and these methods allow us to iterate over values. It allows us to filter data inside of it. It allows us to change and modify data in our array. So this is all defined by JavaScript, the language itself. So what I'm going to do now is I'm actually going to start using some of these pre-built methods that I can run on this array object to modify it and change it. So let's go ahead and just get rid of that. Let's say I want to get rid of the first element in the array. That's dead easy. Just type in array.shift. And what this will do is it will shift everything up 1. So let's go ahead and hit return. And what this method does, it doesn't take any values. You just run it with the parentheses, and it just returns what it deleted. It deleted this element out of the array. And now when we take a look at array, you'll notice it says 100. So it starts with 100 right here. Now also what we can do is pop things off the end of the array. So this is the last value now. Let's sync this up. So we have new value. And what we want to do is we want to pop that off the end of the array. So I'm going to say array.pop. Again, it doesn't take any arguments, which is values. You just run the pop method and it tells you what element, what member it deleted. Well, it deleted this member and it just told us what it deleted by returning it. And then I can say array. And there we go. We start with 100 and we end with the subroutine, with the function, just like we have here. So that is how you take off the first element with shift and take off the last element with pop. Now also we can add new elements to the beginning of the array using the unshift method. So we say array unshift, and unshift actually takes the values. These arguments that we're passing in will be elements inserted into the array. So we could have a string. You can actually pass in as many as you would like. You can just keep going with this as many as you would like, but you can have numbers, you can have floating point numbers, you can even have, let's say, functions, don't forget, and you could also have an object, and you can even have an array. So we're putting in all these different types. We have 1, 2, 3, 4, 5, and 6 elements that we are inserting into our array. So now you'll notice it returns the length of the array. If I take a look at my array now, my array is considerably longer, and you'll see that the length is now 10. And what it did was it started here at the 0 position, and then it inserted all of those values right at the beginning. And you'll notice that it kept everything in sync. So if I go ahead and return this now, you'll see that all of these numbers are correct. They're all in sync and they all work. And there is our first value set that we have here. We put in an array, we put in an object, we have a subroutine that we defined, then we have the floating point number and the integer as well, and also the string. So that is actually how you do it. And again, you don't have to have that many things. You could just say unshift. Just have one if you really wanted to. It depends on how many things you want to insert into the array. So if I say insert, now it's 11. Take a look at array. Now we have insert right at the beginning, and everything stays in sync. So unshift is to add elements at the beginning of the array. To add things to the end of the array, we use push. We can now say array.push, and we can start pushing in values. And again, you can have as many values as you like. Separate each argument, each value out with a comma, don't forget, because we're running a function. So I could say 200, 300, and again, you could have an array, you could have strings, you could have objects, you could have subroutines, and so forth. So say array.push, and what it will do is it will return the length. And now we have 14 elements in our array. What it did was it went right to the end here, and then it pasted this in. So now we have these elements as well in our array. And if I take a look at this, you'll be able to see that is exactly what it did. 200, 300, and string at the end. So that's what push is there for. You can just add in one value, or you could just keep going with as many values as you'd like to push in. Now also, this may not be enough, because let's say if I wanted to, let's say, add in values in between, instead of going right to the start or right to the end, I might want to go in the middle somewhere. How do I now do this in JavaScript? Well, you use the splice method, and with the splice method, you can do anything within the array. So first of all, I'm going to target my array, and then I'm going to call the splice method and invoke it. And the first thing we need to do is say, what position do we want to start with? Well, I want to start right here and delete out this array and also delete out this object. So we start here. So we go 0, 1, 2. This is where I want to begin. And don't forget it's 0 indexed. So I'm going to say 2, and then you define how many elements you want to delete. If I didn't want to delete any elements, you can leave it at 0, but I want to delete this element, 1, and this element, 2. So I want to delete 2 elements from my array, and that will do it. So hit return, and it tells you what you deleted. It returns an array of what was deleted. It deleted the array with 2 elements, embed and 200, so it deleted that one. And then also it deleted the object as well, this one. And now if I take a look at array, you'll see it has string 100 and the function, just like we have here. Now let's say that I wanted to add in elements in the array. Let's say I want to start here this time and I want to add in elements. How do I do that? Well, you use the splice method again, and again it's point and delete. But this time I don't want to delete anything. So I want to first of all take a look at my memory pointer. Go 0, 1. I want to start here. So that's where I want to start. Then, do I want to delete any elements? No. So I say 0. Then you can add in as many values as you'd like, just like unshift or push. You can add in as many values. So it's point, delete, and then values. So I can necessarily say hello, and then I can say world, and then I can add in a number, an object, an array, a function, whatever you want it to be. And there we go. And I can just keep going in this fashion. But I'll leave it with these 3, and I'll copy that out. And now you'll notice it returned an empty array. That's because we didn't delete any elements from our array. So it's just telling us, sorry, we didn't delete anything. And now when I take a look at my array, you'll notice it added it in. It went here. It started here, and we didn't delete it. We moved it down, and we added in these 3 values. Then you have 100, and then you have function, and that's exactly what it did. You point, then you say you want to delete, and then you can also add in new values. And you can also replace as well with the same technique. So for example, let's say I want to replace string and hello, or even world and 200. Let's make it a bit more complicated. So again, what we do with array.splice, the first thing we do is where do we need to go? Well, we need to go here. This is where I need to start. So 0, 1, and 2. I need to start at position 2. I want to delete because I want to replace these two. So I want to delete world and 200. And I can say delete those two elements. And then I can replace them with either one element. So I could say world 200, or I could keep adding in as many values as I'd like. So let's just replace these two with just this string. So let's go ahead and hit return. It told us what it deleted. It deleted world and 200. And then what it did was it placed in this value into our array. So now it says world 200. And if we take a look at array, there it is, world 200. So the splice method is very powerful, and it lets you modify the array in such a way that you can delete any particular amount of elements. It allows you to place in new elements as well at any point or position. Functions are first-class citizens or callable objects in JavaScript. You can think of these braces as containing a list of instructions. And don't forget, we define the objects via these braces, called an object literal. Well, you can think of this as defining an object, but this object is a callable object. It's invocable. Like if I called you by your name, you're invocable. I can catch your attention and I can run some instructions. And that's exactly what we're doing here. If I was to now save this and refresh the browser, I can print out this callable object by typing its symbol name, its memory pointer that I've given it here, or I could invoke it by saying name with the parentheses and end with a semicolon. This will invoke the callable object. It will tell it to run those instructions between the braces, the executable context or the callable object. Now also, what can you do with objects? For example, you can embed objects inside of other objects. So for example, let's create a variable called obj, and we're going to make an object again with the object literal, the braces. We're literally creating an object, and it can contain embedded objects. So I'm going to create the symbol name embedded, and you can embed objects inside of objects. Well, you can actually do this with functions or subroutines or callable objects. So let's go ahead and create a function, and then let's type in concat. And then what I'd like to do is I'd like to receive this particular string here. Now I don't actually have to do this, but I'm going to come back to why I'm doing it like this later on. So we have concat, and then it's going to be name. And then inside of here, we can simply return a string with, let's say, Mr. And then I'm going to concat in name. Now, at the moment, all we've done is we've defined a subroutine inside of a subroutine, or callable object inside of a callable object, just like we have here. And don't forget, arrays are objects as well. So you can embed arrays inside of arrays and objects inside of arrays. Doesn't matter. You're just embedding. You have this hierarchy of effectively objects. And that's exactly what we have here. We have callable objects nested inside of one another. And if I was to save this, all it would do is it would just run the name subroutine, and it would only return Lawrence Turton. The reason being is because I just defined this callable object. I didn't actually invoke it yet. This is still just defined. I've not invoked it like concat. So I can invoke this. And what I'd like to do is invoke it with the full name, like so. And then I'd like to return the output, the overall output from this subroutine. So what exactly is going off here? Well, let's go ahead and hit refresh. And then I want to run it to make sure it works. And you can see it says Mr. Dot, which came from our concat function, Lawrence Turton. So what happened? Well, we invoked it, we called it first of all, and it wants to run this list of instructions. This callable object is now executing, and it creates a variable called full name, and it stores the value in memory Lawrence Turton, which is the string. Then we create another subroutine, an object inside of an object, and this is going to be concat. So concat is now the symbol name in which I can reference this subroutine, and it receives an argument. So an argument is a value. It's going to receive this value, Lawrence Turton, this string, and it needs a place to store it. So we create, in essence, a variable, a parameter, that will store that string whilst we're executing, and then it will delete that out of memory. So I'm just going to go ahead and say, right, that name parameter contains that string, and then we return from this subroutine when it's invoked the string Mr., and then we say plus, well, we've got name right here, which we know that name contains the string, and then I concatenate it together. And then, of course, when we invoke it, that will return the string Mr. Lawrence Turton, and that's exactly what's happening. So when you've invoked it, it just returns that string back out again. And so there it is. That's the entire process that occurs, and you can have objects inside of objects. Arrays are objects, or arrays inside of arrays, and you can mix and match. And you can also have callable objects inside of callable objects. And you know that as well. Speaking of objects inside of objects, that you can have a standard object literal right here. And methods are in fact subroutines or callable objects nested inside of an object. And you have the same thing for arrays as well. It's just the arrays don't have a method name. They're just an element inside of the array. Now let's do something a little bit more tricky. Let's pull this back to its original state like so. And let's say that full name here, I actually want to turn it into a parameter, and this parameter will receive an object like so. So what I'm going to do is I'm going to invoke name, and then I'm going to pass it an object, and it's going to have the first name, and then we're going to have last name. So there is our object that will then be passed to this parameter, this argument, and then we can start to use it within our subroutine. So now I can say return full name dot first name, and then concatenate onto that full name dot last name. So there we have it. But if I was to refresh the browser, it looks like nothing's happened, and that's because even though we've invoked it, we've not logged out the output to the console. So you need to say console.log, and then you would need to run and execute this callable object, and then after it's run, it will return the string Lawrence Turton because it concatenates those properties together, and then it will log it out to the console. So now if I hit refresh, there it is. The output's logged to the console. And so what happened? Well, this object that was invoked, and let's just simplify the syntax right here, was invoked by the parentheses, so we're targeting this callable object via its symbol name, and then the argument was passed to the parameter and assigned, and then what we're doing here is we're saying, right, return, we're accessing that object, and we're pulling out the first name property, which produces the string Lawrence. So that produces the string Lawrence. We access the same object again, and the last name property contains the string Turton, and then we're concatenating that together, and then we're returning that to the console. And so that's exactly what has happened here. But now, let's now pass in a callable object to a parameter. Just like you could create a variable that can contain an object, a standard object, you can also create a variable or constant that contains a callable object like so. So you don't need to define the symbol name right there because this callable object is defined already by this symbol name. So we can call it up via obj. So you can actually put functions inside of constants and variables. So let's take a look at now passing in a callable object. Now this callable object, again, doesn't need the name placing in here because it's going to be given a symbol name when it is assigned to the parameter. So a function, a callable object that is an argument does not need a name. It will be given a name when it's passed in to my function up here. And so there we go. We now have name function, and there is my callable object. And let's say it returns the string embed. Wonderful. So this callable object just returns the string embed. And now let's go ahead and return whatever is inside of the full name. And what we need to do again is say console.log, and we need to log the output from this callable object to the console. So save it, hit refresh, and you'll notice what it did was it printed out the function, the callable object that we defined here as an argument. So what happened was we invoke this callable object. This callable object received the argument, this callable object, and assigned it to full name. And then what it did is we took full name and we returned it like so. So we're literally returning a callable object here, this function. And so now when this function is finished executing, this callable object, it just returns this function here. That is what's returned. And that's what we have here. Now that's quite interesting. It poses a new problem. How do we actually execute this? Well, you know that potentially what you could have done is executed it by putting in the parentheses. So now we're not just returning the callable object and printing it out here. We want to say, right, execute the execution context. We want to run these instructions because we know that this callable object is in this parameter, and this parameter can then be used to invoke that particular callable object by the parentheses. So let's go ahead and save this now and hit refresh. And you'll notice it says embed. And that's exactly what it did. So to recap, functions are callable objects. They are objects that contain a list of instructions that are to be executed when they are invoked. They're invocable objects, callable. Objects can be contained inside of objects, so callable objects can be contained inside of callable objects, and you can keep nesting your callable objects inside of one another. And wherever you can pass in, let's say, an object, so you can assign an object to a variable or a constant, or you could assign a object to a parameter, you could in fact change that object for in fact a function. So now you can understand the architecture of objects. You can also understand the architecture of callable objects. Memory hoisting is a feature of JavaScript. And I first of all want you to focus on the two words. First of all, we have memory, which we'll get to in a second. But then also you have hoisting. Now, hoisting is a feature of JavaScript. And what does hoist mean? It means lift up, like a crane. Or if you wanted to change the engine in your car, you need a hoist to hoist the engine out of the car so that you can put the new one in. So hoisting just means to lift up. And the second thing we have is memory. Now, what do we think of when we think of memory? Well, we think of potentially symbol names, names that refer to values that are stored in memory. And these symbol names reference and point to certain values that are in memory. And you can think of the JIT compiler as a chef. Now, when you think about your scripts, don't think that they immediately execute. They don't. JIT compilers are the chefs. They need to prepare their ingredients before they can start cooking. Cooking is executing, and preparation is the creation phase, whereby it lexically reads through your code. What do I mean by lexically? Well, you lexically read through a book. You start reading left to right in a lexical manner, reading through the code. And that's exactly what the JavaScript parser is doing. It is in fact reading each and every character, and it's taking a look particularly for syntax errors. So it wants to know if when it starts executing there's going to be errors, then it won't bother. And also it's not only looking for errors, it's looking for symbol names. Here's a symbol name, such as a variable or a constant name. And also it's looking for the other type of symbol name that refers to a callable object. It's still a symbol name. And what happens is it takes these symbol names and it hoists them, lifts them up. Now, I do want to stress the fact that what it is not doing is it's not taking code and placing it above. It is, first of all, going through the code line by line. And typically you would think that executing straight away would cause an error, and it would, had there not been the creation phase, the preparation by the chef, the JIT compiler, because you can see that even though I'm executing this first in my script, where I'm referring to the myName variable that hasn't been created yet as of line 1, and the print name hasn't been created yet as of line 1. But yet for some reason, when I run it in the browser, you'll notice it says undefined. And also we get the string returned John Doe from our callable object. So what happened in the creation phase was that it started to create memory pointers. Now, if it's a variable or a constant and it's just a symbol name, it's actually undefined. It's just like you saying var my name. So that is all it's doing, and it returns undefined. It's just creating a memory pointer, and currently it refers to a block of memory that's undefined or null. You may get null or undefined, it means the same thing. There's no value that's been assigned. It's just created the symbol name, the pointer. That's what it's done there. Now with functions, it's different. It did create this memory pointer, this print name, but as it is a function, a callable object, this execution context got hoisted. So you can think of functions actually getting hoisted above, like so. They are really getting hoisted. The whole body of the function, the execution context of the function, is lifted up. Now, once it's done this, it will actually create that function like so. So let's take a look at it from a process where it starts reading through. It found that, it created that in memory, it found that symbol name that's associated with a callable object, so it created that function. This is the first creation phrase, the chef that's preparing all of his ingredients, ready to execute, ready to cook. Then it goes through and it goes back up to the top again and it starts executing. So then what happens is it starts executing this. Now my name does exist, but it's not actually referencing anything, and print name has been created. This callable object has been hoisted, and therefore I can paste this in now, console.log my name and print name, and then it executes, and then it will produce undefined and John Doe, because don't forget on the first pass, my name is now undefined. However, when I run it here, of course, it's going to say Lawrence, because it has now been created as of executing this line of code. But prior to that, it would be undefined. And that's exactly what you have here. When you run it, undefined, and the function was hoisted, so we get John Doe. And also, in every execution context, you can think of this script as an execution context. We are executing what is in this script, this block of code that we've defined via our JavaScript file. This is executing. Well, we also have execution contexts as well. Callable objects have their execution context. These also have hoisting. So for example, I can say console.log a, and then I can say var a equals 100. Now, what are you expecting to log out in the console? Well, let's save this and hit refresh. You'll notice it logged out undefined on line 7. And here is line 7. And it's logging out undefined, because what it did was it created the variable a, and it created that symbol first. So it reads through execution contexts as well, and they also have hoisting. And it's in effect saying var a up the top here, and that is equal to undefined. But of course, we just say var a. So it's creating it, and then later on, it's referencing that symbol name and assigning it. But during that phase, a still is undefined. So console.log, if we try to log it out, is going to be undefined. And that's what's happening inside of it. And how can I tell this? How can I tell it's memory hoisting? Because if you try to call a symbol that doesn't exist, you get an error. So if we save it, there's no error. It's just undefined. But if I actually cut it out, like so, just cut it out completely, look what happens. Reference A is not defined because it can't just randomly create it. So it is hoisting, but it's not executing this, the assignment operator. It's just creating the memory pointer. It's hoisting the memory pointer. So for variables and constants, it hoists only the memory pointer, and it's just pointing to a blank piece of memory. And also when it comes to functions, well, if that symbol name points to a callable object, it hoists that to the top. And don't forget that each execution context has memory hoisting within it when you execute it. You can even do the same thing for an embedded function. I can say embed, and this will return the string hello. So now I'm going to invoke it. So I'm going to put in a comma, and then I'm going to log this out in the console. I'm going to say embed, and then I'm going to execute it. So let's save it and hit refresh. And you'll notice that this entire function, this symbol name referencing this callable object, was hoisted, lifted up above. And that is memory hoisting. Now, when you think about scope, think about access. For example, you can have a mechanic that's going to repair a car engine, and we know that objects contain objects. They have scopes. You can't just open up a car engine and then pull out a piston, for example. You need to take the engine to pieces. You need to take the engine blockhead off, and you need to dismantle the entire engine block. So we understand that there is scope. You can't just lift the bonnet up and pull out a piston. There is ways in which you can access objects nested inside of other objects. And that is exactly what scopes are. Whether it be a standard object or a callable object, these are scopes. They have their own access level. They have their own defined perimeter, if you will. And some have greater access and some have more limited access depending on where that callable object is and where that object resides. And that's all that scope means. And just like objects in our program, you know they have scopes. You know you can't just type in, for example, engine, and then we want to pull out the very first piston like so. You couldn't do that. You're just going to get undefined. And the reason why you're going to get undefined is because it's not defined. The pistons are not defined in this scope that you can see. This starting and ending braces in there, in that scope, pistons are not defined. And so we don't have that access to that array yet. But what we need to do is we need to take off that head gasket, or you need to take off the engine block and so forth. I'm not a mechanic, so do forgive me on this one. But what I need to do is I need to say, right, there's the engine, there's the overall engine. Now we need to take off the head gasket, for example, and then we need access to the pots. And in the pots, there is an array right here, and then we can access one of the pistons in our engine, just like a mechanic knows that he needs to go through multiple objects to get the object that he needs to fix and repair. And you, as the programmer, are that mechanic. You're the mechanic that needs to be able to know how to access your objects and how to access them individually, one by one, and then you can pull the data out. That is called scope. It has an access level. Now, don't forget that functions are also called callable objects. They have their own scope. They have their own execution context. If you have a look here, it is those braces again, and you can tell those braces, they have scope. That's why our IDE, our editor right here, can actually collapse the brackets, because that is a scope. Like so. So you go to engine, then you go to head gasket, then you go to pots, and then you can access one of these elements. So that is all to do with scope. And functions have scope. You'll notice we have function, run expression, and then what we have is we have a variable called a is equal to 10, and you also have an embedded callable object called add. And this returns an expression. It returns a, which is defined outside of this callable object scope, a plus 90. So I've created the variable in this function, run expression, but in this embedded function, I'm actually calling up that symbol called a. And we're going to say add 90, and we run that add callable object, and it will return 100. A is 10, 10 plus 90 is 100. That will then be returned when we execute this function. So let's go ahead, and what I want to do is actually run the function. So I'm going to say run expression, then we need the parentheses to invoke it, and when you do, you get the value 100. So this is what we have scopes for. Now, let's say I created variable b. So I created var b is equal to 90, and then I say a plus b. So that should return the same thing. If I save and refresh and we run it, that's fine. Instead of the old equation, I'm just storing the number 90 in the b symbol. So what actually happens now? if you try to do this on a regular object, you wouldn't be able to do this. For example, if you said engine, then you went into head gasket, then you went into pots, and then let's say you wanted to go back out and say, right, I want to target maker, like so. If you actually try to run this, you would find it would return undefined. In other words, this memory pointer doesn't actually exist within this scope, because that's the scope we're targeting, which is this array, and then it's trying to find the symbol name maker inside of this array, and it can't find it. We've only got 0 and 1. So you can't do this with regular objects, but callable objects are different. Callable objects go on to what is called an execution stack. And what do we mean by this? Well, if you think about it, you have a stack of papers, for example, and each paper could be a function, a list of instructions to run, and we stack these papers up ready to be run. And what's stacked on here is the execution context. So first of all, you have the run expression execution context, and then also you have another execution context, which is called add. And this execution context is placed on the stack also. Now, what's happening with these execution contexts? Well, the run expression is first of all being executed, and it creates the symbol A in the symbols table. After we finish the run expression execution context, we have the add execution context. But what it does is it doesn't just automatically delete something out of memory. It says, can potentially another callable object access the symbol A? And the answer is, yes, it can. So it leaves it in memory. This is called a closure. It encloses and it encapsulates and it keeps together all of the symbols that have a reference to them or could have a potential reference to them. And also, don't forget, the add execution context is going to create the symbol B as well. And then what happens is we say return A plus B, which is 100. So after all the execution is finished, we have 100 returned. Now, when we're finished, there is something called garbage collection. In other words, can any other part of our application access those symbols after we've finished executing? No, it can't. There is no other part of my application. If I try to access, for example, the symbol A down here, or I've already run the function here, can I access A? No, you can't. And you can't access B either. So what's the point in leaving or wasting memory by storing these values and keeping these memory pointers? Because no longer can our application access it. Only these callable objects, only what was in the scope of these callable objects could access potentially one of those symbols. So now that we're finished with our execution, it simply deletes those symbols out of memory. That is called garbage collection. It gets rid of waste symbols or symbols that we no longer need. Now also, let's say that we run the add function and then we try to access in the outer scope, in the run expression scope, the variable B. Will this work based on what we have just seen? The answer is no. So let's go ahead and delete that and just hit refresh. And then what I'd like to do is say run expression. Now when I say run expression, it'll say, sorry, B is not defined. So what happened? Well, again, we have this execution context and it runs this execution context first. It does not run the add execution context after. So what happens is it created a symbol called A, which is equal to 10. There's nothing wrong with that. But when it was invoked, we invoked the add callable execution context, but it just added it to the stack, one below. So all we have is a symbols table that has the A symbol. B has not been created. So when you invoke a function, it doesn't mean that it's going to invoke right there, dead center, and that's where it's going to invoke. No, it's just pushing it onto the stack of papers, and each paper is a list of instructions. And it's not run those list of instructions yet. It's not run the add list of instructions. So that function hasn't been run and the symbol B hasn't been created. And therefore we get this error. So it runs this execution context, then it runs the add execution context. That is very important to remember. Just because you have it invoked here does not mean that it immediately invokes the subroutine right then and there. It adds it to the stack and then it goes down the stack, and you can have functions inside of functions, just like objects inside of objects, callable objects inside of callable objects. And when you invoke each one, you are in fact adding to the stack. So for example, if I had add and add, then that would actually add the callable object twice onto the stack. And we can have the parameter now b, and then you can set one to 90 and the other one to 20, and you get different results out in the console. And we can just log this out in the console. So I can say console.log, log this out, and hit refresh, run expression. We get 130. So it created the outer execution context, and it said, right, we need to run these system instructions. Right, we want var a equals 10. It created that symbol. Then it noticed that we invoked the add subroutine twice. And as we invoked it twice, one with the value of 90 and the other one with the value of 20, it adds those into the stack with the argument values. And that's what's happening here. It's called the execution stack. And yes, you can have the same function repeated over and over and over again on that execution stack, or what it is known as is the main thread. And you can think about a thread of string with beads on it, and each bead is your function. And we just run each function, we throw each bead off the thread and we get what's returned. And we also have a temporary symbols table for the temporary execution context. And when we encapsulate this main thread with this temporary symbols table, this temporary database that stores symbols, it is called the outer execution environment. That is this environment. It's a temporary environment in which our functions and those symbols which those functions have created just for the process of those functions, and that is this environment in which we're executing these lists of instructions here, and then it's cleared out. It's only a temporary space for execution to happen in our JavaScript program. So, functions are callable objects. Callable objects have scope, just like regular objects, and you can have objects embedded in objects. But callable objects are special in the fact that we have this temporary symbols table, and the language feature is called a closure, where any sort of symbol that's created inside of our execution stack, as long as there is another callable object in there, still in the execution stack, it keeps the symbol, it encloses everything together, and it keeps those symbols whilst we are executing all those instructions on the execution stack or the main thread. Then once all of it's been executed, it returns the final values and it does all of its operations. It then clears out the symbols that we can no longer reference in our program. Once we've executed these list of instructions, we've done what we need to do with these instructions get thrown in the bin. Our instructions are in the bin, and now we get garbage collection as well that deletes out these symbols so we're not wasting memory. And that is also garbage collection, and garbage collection is a big part of memory management so that we don't end up filling up all of the user's RAM and crashing the browser and being very, very inefficient in storage. And JavaScript manages that automatically for you. In JavaScript, we have the global scope. And what do we mean by the global scope? Well, for example, we have the window object. Now, the window object is a scope. You know that objects have scope, and the window object is the highest level object. And this object and all of its memory pointers, so all of these symbols that are directly attached to the window object, are globally available, meaning they're globally scoped, or they can be accessed anywhere in the script. For example, I can access engine because engine, this variable, is being created on the global scope. It's the same as me going to the console and typing in, for example, engine equals. And that will create a memory pointer on the window object. And it will be globally available. It will be available to this scope, and it will also be available to this scope as well. And that is only for symbol names that are directly attached to the window object. That is a globally accessible object called engine. And now what we can do is we can run this. We have the run expression, and again, I'm just creating a variable, and we're also creating an embedded subroutine called add, and then we're invoking it. And then what we're doing is we're saying console.log, and then we say engine. Now, what we have with JavaScript is something called inferred globals. In other words, if I infer something to you, it means that I can suggest something. For example, I can deduce or conclude something from evidence, reasoning, rather than, get this, from an explicit statement. Now, you know in JavaScript, we write statements. So we're kind of working on a conclusion. We're trying to conclude something. So what JavaScript is trying to do, this JIT compiler, is it's trying to deduce or conclude where this memory pointer is. And what it does is it starts to go up the scopes if it cannot find it. So it tries to look inside of this scope for the memory pointer engine. If it doesn't find it, it goes to the next scope. It won't find it. We've only created a variable called A, and that's it. So it won't find it in this scope either. So it will go all the way up to the window scope, and it will find it there. So I can pull out a globally accessible variable or constant or subroutine that's attached to the window object. And so what it will do is it will keep going up and it will find it here. Let's go ahead and hit refresh, and then I want to say run expression, which will then also pop on the stack the add subroutine, and then we console.log, and then we are simply trying to find the memory pointer engine. And it went all the way up to the global scope. So it inferred that we just wanted to go up to the global scope. So if it can't find it in its current scope, it's automatically inferring, suggesting that we want to keep going up the scopes until we find it. So what happens when, for example, I say console.log A? Again, the same type of thing happens. It's still inferred global, which means we keep going up until we reach the global scope if we cannot find the symbol. But in this case, we can. So what it does is it says, right, we need to log out the A symbol. It's not in this scope. But there is a symbol called A in this scope, which is equal to 10, and it returns the value 10. So it stops there on that scope. Now, what happens, for example, when I to create a variable called engine, and I'll set it to string engine. And then what I want to do is log out engine. Let's go ahead and save this now and hit refresh. What do you expect to happen? Well, I say run expression and it says string engine. And you'll notice that with our variable, it said, right, let's try and find that symbol name in this scope. We found it in this scope called engine. And it stopped there and it printed that out to the console. It didn't need to go anywhere up the chain. It was directly defined in that scope. But you'll notice that this globally available engine object is still perfectly fine. It's still here. We didn't change the global variable called engine. You can think of it like this. If we had a look at the window object, we created the engine property, and that is in fact an object that we created. And then I created the run expression callable object. So I've just fashioned it as an object here. And then we have A is 10, because don't forget we created a variable inside of our run expression subroutine. And then also we had the add subroutine, and in there I created the engine property. So that is in fact not going to affect this property. Each one of these braces has its own scope, so we don't have naming collisions. So that's also something that is very, very good. But this also means you have to be very careful as well when you've got inferred globals. Because what you have now is if I say, right, okay, engine, that's fine, that could log that out to the console, for example. But what happens when I use the equals operator? Now you have to be very, very careful. I'm going to say new string. Let's go ahead and save this and hit refresh. And then we're going to execute the run expression subroutine. Now we're not logging anything out to the console for now, but now when I take a look at engine on the global scope, it says new string. And what it did was it looked at the memory pointer, it looked for it in this scope, said nope, looked for it in this scope, said nope, and then it went out to the window object, and it did find it. But it did the assignment operator as well, and it assigned that string and replaced the object that was residing within it. This is why you have to be very, very careful. If you wanted to do that, change a global constant or variable, then that's perfectly fine, or even a subroutine, a global subroutine. Doesn't matter. It's just a symbol name. However, if you need to create something within the scope, you need to say var or use the constant keyword, because that then means this is explicitly creating this symbol in this scope and none other. If you just type in the symbol name without the declaration of the variable or the declaration of the constant prior, then you will have an inferred global. And in fact, let's just say this. Let's just say test. So now I'm going to go to test equals new string. Let's go ahead and save this now and hit refresh. Now what you have is an inferred global. So I'm going to run. I'm going to say run expression. It didn't error. You may be going, what? How come it didn't error? Well, we have the assignment operator here, don't forget. Now what you have is an inferred global where it looks for test in this scope, then it looks for it in this scope, doesn't find it, then it goes to the window object, but it didn't find it there either. But because we're using the assignment operator and we're assigning the new string, guess what's happening? Let's take a look. You go to window, you go to the window object, and then you type in test, and lo and behold, it's actually created that memory pointer test on the window object. It created a global variable. That is what's called clobbering the global scope. Imagine if I had 5 or 6 different variables, 2 or 3. What you're doing is you're clobbering, you're unnecessarily creating a larger window object, and it's going to make it harder for the browser to really search through. Now, don't get me wrong, the browser is extremely quick, and JavaScript is very fast at finding stuff stored in memory pointers. However, what I would like to illustrate to you is we've just clobbered the global scope. We've unnecessarily created the test2, and the test3 symbols on the window object. We've done that unnecessarily, and that's very, very bad. You can have all sorts of naming collisions. You can start overwriting data where it shouldn't. So be very, very careful. If that's what you want to do, that's fine. And obviously, if you just tried to point to the data, so let's save it now, refresh the browser. So now the window object doesn't contain test at all. So let's try and point to this. Let's hit refresh, and then let's go ahead and run the expression. You're going to get an error that says, sorry, I cannot find test. So the reason why I errored this time is because we're just pointing. We're trying to find something in memory. And basically you've got the librarian that comes back and says, sorry, I can't find this symbol. However, if you use the assignment operator, you are now going to create a global symbol on the window object and assign whatever value is to the right of it. So that is what is called inferred globals. You have the global scope, and you also have callable objects scopes as well. Now, this word is a context-based word. In other words, it has context. It has a reference. If I was to say, look at this, without a context, well, you simply wouldn't know what I was looking at. You need context. You need me to point to what I'm looking at, like a memory pointer. I could be pointing to a car engine, or I could be pointing to a piston that I took out of the car engine, or a stack of papers on my desk. So we need context when we work with this. When you open your browser window, there is an environment that is established, and that is the window object. We create the window object that contains all of the default properties and methods that make up the JavaScript API. However, we also have the this keyword that is set up in memory. And depending on where you use this keyword, it will change and it will have a different pointer. So first of all, this by default points to the window object. When you open a new tab, it creates a window object for that window, and then of course it just says that this memory pointer is just pointing to the window context. So by default it's the window object, and then it can change. But how does it change? So I've logged this out in the console. Let's just comment this out with the double forward slash, and that will comment that line out, and it will just nullify it. You can actually write English in this line. It's just a nice way to comment your code. You can add it in any way you'd like. By the way, I'm sure you've downloaded some of the lecture files, and that's exactly what I've been doing. I've just been adding in a few little comments in the code to teach people what I have done. So now we have this object here, and let's take a look at the property first of all. So we say object.prop. Now, if the this keyword is found inside of a property in an object, it just points to the window object again. It doesn't change its context. Likewise, if I have an array, and an array is an object, and the first key is 0, so we want to target this first element, let's go to array, and then pull out the 0 indexed item, which is the this keyword again. And when I type that in, you'll notice we get the window object again. So if you have the this keyword within an object property or within an element in the array, it's always pointing to the window object. But what happens really with the this context? If it always points to the window object, it's pretty pointless. Pardon the pun. So what actually changes the this context? Well, it's actually callable objects. Callable objects allow us to change the this context. So for example, we have a method within an object, and this method returns whatever this is pointing to. So let's take a look at this object.method. And there it is. You can see that it's no longer the window object. The this pointer is now going outside of the scope of the function by 1. So what it's doing is it's jumping outside of the function, and it's going to the object that contains the method, which is this object right here. It's printing out that object that contains the prop property that, don't forget, has the this keyword, which is targeting the window object, and then it also has the method right there. There it is. So it's actually changing the context. And you also have the same for arrays, because arrays are a type of object. Array, and then this is on the index of 1, this function, and we want to invoke it, so we put in the parentheses. You'll notice it returns the array in which this subroutine is located. And what about a globally scoped subroutine? Well, if I go ahead and invoke it, this subroutine is called global. It fetches it out of memory, it invokes it, and it returns whatever this is pointing to. And this is just pointing to the window object. It steps out 1, don't forget, just like our method, it stepped out 1 into the outer scope, and that was this object. Well, now with our function, it's actually stepping out 1 into the window context, because this is a globally scoped function right here. So this step out 1 from this context to this one, and we get the window context. Nice and easy. Now also, there are different ways you can invoke functions. Now you know about one way in which you can invoke a function. For example, we have said global. So you just type the symbol name and then you invoke it. That is how you invoke a standard function or subroutine. However, here's the really cool part. You don't have to invoke a function that way. You can see here I'm targeting global as if it was a callable object. And notice the dot syntax, just like we work with objects and we use the dot syntax to access members, properties, and methods within the object. Well, we're using that same member access operator on this global or callable object, and then we can use the call method. So this is proof that functions are treated as objects in JavaScript, and you can call the object, invoke it, and you can actually assign a value to this. Think of it like this equals object, for example. We are assigning the argument's value here. So at the moment, what I'm saying is I'm calling and invoking this subroutine, and I'm telling this context, the context of this execution context will be of object. So I'm taking this object right here that I created earlier, and I'm passing that into the global function. So let's go ahead and do the same thing. Now, this isn't going to print anything out in the console, but if I now run this code in the console, you'll notice it changed the this context actually be of the type object. So now we've changed the context of this, which you can do with callable objects. And there's one more. You also have the new keyword. So you can say new global. Now this is interesting. The new keyword comes before we invoke the function. What does that do? It adds a new this context. So this by default with the global context is going to be window, but it says, no, I want a new context. I literally want a blank object. That's what it's doing, is putting in, it's assigning a new object to the this keyword. And that's what we have. New, and then you invoke the global subroutine. Let's go ahead and run that. New global. Hit return, and there you go. And if you have global, by default, it points to the window object, but it's how you invoke the function. You can invoke functions in different ways. You can use the call method on a callable object and pass in an argument, and that argument will be assigned to the this context. It will define the context of this execution context. Then also you have the new keyword, which is a new context, a completely blank and empty object. And we'll talk about why this is important later. The standard way of invoking a function or subroutine by just calling it by its name. And if you do this, by default, it will be the window object. No matter even if it's an embedded subroutine like so. If it's an embedded subroutine, again, the default of this will be equal to window again. However, if you have a subroutine within an object scope or an array scope, it will return the object that invoked it. For example, you have object.method, and when you run that, this context is going to be the object that invoked it, or you could say array is 1, and then you can invoke it, and again, it's the object or array that invoked it that is the this context. If you were to, let's say, embed this in here, so let's go ahead and do one further. Let's say embed, and let's create an object, and let's put this method inside of this object. And then when I hit refresh, let's say object.embed dot, and then we've got method. Now what will be the this context? Well, it's the object in which the method was invoked from. So we do have the main object, but it was not directly invoked by that. We also have the embed object, this scope here. And so this is now the context, embed. If I hit return, you'll notice it returns the embed object that contains our method. And if I put the embed property in here and set that to true, let's say, again, I can just run that and you'll see it is the embed object that is being returned. So if you're calling a method, then it is the object that it was invoked from. But please do note, with methods, you can use .call. So I can say .call, and then I can, let's say, make this context the array. So I'm going to say array. So now we're targeting our method here. We're invoking it, but we're invoking it via the call method. And we're passing in the array. We're telling this context to equal array this time. Let's hit return. And you'll notice what you have is the array being returned. So you can change this context of methods. And also you can type in new, and then we can invoke this method. Again, it's just a subroutine that's placed within an object scope. But now if I hit return, again, we change this context. This context is a new object. It is a new object like so, and there is our new object that's returned. This keyword now refers to a brand new context or contextual object. So that's how you invoke it. So it's number one, where is the function placed? If you're invoking it in the standard way like this, or like this, it is basically where is the function placed. If it's placed inside of an object, it will be the object that it has been directly invoked from. If you invoke it with the call method, it will be whatever you have decided you want this keyword to be targeted towards, whether it be a method or whether it be just a standard routine, or you have the new keyword. And if you invoke a method or of course any other subroutine on the global scope, it doesn't matter. It's going to make this keyword point to a new context. Now, one final thing, you also have, let's say, embedded subroutines. So what I'm going to do is say console.log, and I'm going to say, right, this comes from the global object, and I'm going to log out whatever this is pointing to. But then also I can have an embedded subroutine called sub, and I can also say console.log, and then we're going to console out from sub, and we're going to find out what this is pointing to. So let's run this little experiment, and instead of saying return this, let's go ahead and invoke sub as well, as everything's going to be exported out to the console. I'm going to hit refresh, and I'm also going to delete this invalid piece of code here. And then what I'm going to do is I'm going to run it. So let's say we call the global method subroutine, and we're going to call this subroutine, and you'll notice we get, well, two different results. First of all, you say from global, this is this console.log line, and we're targeting this keyword. And you can notice that it's targeting a new contextual object that we invoked it with. We said new global, and it's invoking it with a new global object. Then we created this subroutine, we added it to the stack and invoked it, but we said console.log from sub this. And we say console.log from sub, and you'll notice it's now referring to the window object. So be very, very careful, because now this refers to the window object here. And we'll talk more about why this is dangerous later on. But also, we now know that by default, callable objects will go to the global scope because of the way it's been invoked. It's just been invoked like that, a standard way to invoke it. We didn't say new sub. If you said new sub, then this would equal a new object. But we invoked it like this. It's how you invoke that callable object, even if it's in another callable object. It's how you invoked it. Well, we invoked it that way, and we know that way this context by default, this standard way of invoking is the window object. So be very careful when you are using this keyword. Construction workers in the real world build things. You give, let's say, a construction worker some blueprints, and they will construct or build something like a building, or a car, or a plane, or anything else that requires a blueprint. So likewise, what are these constructors in programming? Well, these constructors in programming are in fact like construction workers. Now, in the case of JavaScript, we have Constructor Functions. This is the typical way that you create objects in JavaScript. But why do you need a constructor function? Why do you need a blueprint to create an object? Well, we may have, let's say, a game, and we have a player, and the player is an object. We can describe him, and he has certain characteristics, and this player goes through the map, and he comes in contact with apples. And when he touches an apple, he gets more points. So we want to have a constructor function for all of the Apple objects that we want to construct throughout our entire program. So we need to be able to create a constructor function so that our program can call upon this function dynamically and create an object from it. And when we create an object or an instance, that's all it means. An instance just means a copy of. It's a copy of the blueprint. Kind of like me having a blueprint for a building, and what we do is we copy that blueprint over and over and over again. We create an instance of the blueprint. And likewise, we're creating many objects from this constructor function. So that's why we have constructor functions. So our program can call upon this function at any time. A user clicks a button, it can generate an object, for example. A user goes to a new level, we can randomly generate more apples. There could be many instances of why we do. If you were creating a graphics editor, for example, and you import an image, I need a basic blueprint of data for that image to go into my main data store. I need to keep track of all of the images the user is importing into my program. Whatever it is, you're going to need some means of construction. So that is why we have constructor functions. So first of all, I want to create a constructor function for the apples that are going to be produced throughout our game. So I'm going to create a function, which is a callable object, and I'm going to call it apple. Now with the naming of your constructor functions, please add in a capital letter to begin with. And the reason why we do this is because it helps us identify that this is a constructor function. Whereas if it was lowercase, it kind of just looks like every other function. It's just a naming convention. You don't have to do it with your constructors, but it's ideal to actually have a capital letter with a constructor function. Then we can pass in some parameters. Now we're creating a template here for our apples, but our apples can be placed at different positions. They can be a different color and they can provide a different score to the user. So even though we're constructing a single apple object from this constructor, the values are going to be different. I'm not just going to create a flat object and then they can change it later. What I want to do is I want them to be able to create objects on the fly that have different values. It's the same template, but it's got different values. So for example, X, Y, we need these parameters. We also need the color and we also need the score as well. Now what we need to do is take a look at this execution context and of course the context of this. Now you know when you actually invoke a function, that is how you determine this context, the context of this execution context. So with constructor functions, you use the new keyword and then you invoke your constructor function. Why? Because we don't want this by default, if you were to just call it like that, to equal the window object. That's bad. We want to make sure that we assign a new context, a new object context to this execution context, like so. And then we start adding in, let's say, properties and values and methods into this, whatever you want to do. It's just like referring to an object. So for example, let's go ahead and say this dot. And so what I'm doing is I'm referring to this new object that I've assigned to this keyword because of how I've invoked the constructor. So when I'm using dot, I'm accessing an object. This contains an empty object. A new object, if you will. And I can say, right, give me the X position, and that's going to be equal to X, for example. There'll be a value assigned to X, like so, maybe the value of 10 or something like that. And that value will get assigned to the object's X symbol. So if I say X10, that's what we're doing here. So please do note the difference. This is the parameter pointer, and this is the symbol contained within the object. Be very, very careful. This is the symbol pointer within the object, and this is the symbol pointer for the parameter. So there we go. That's all this is doing. This is just an object now. It's just a new object that I can manipulate and play with. So you've got Y, you've also got color, and then also you've got score. And all that's going to do is it's going to return the object. Now you can say return this if you really wanted to. But to be honest with you, the context, it doesn't make sense because once we actually start invoking this execution context, there's no need to say it. It will by default return whatever sort of the value is in this function. So actually we don't need to say return this. It's just going to take a look at the context, the current value, and the current value is this object that we keep manipulating. And if we keep manipulating it, all it's going to do is it's just going to return this object wherever we invoke the function. And it's going to invoke it with, and it's going to return with all of the values we assign. So let's go ahead and add in some arguments for our parameters. So for example, 10, and then we've got 20 on the y-axis, and the color is going to be red, and this one is going to give you 200 points. Now, if I was to just save this and hit refresh, you wouldn't see anything in the console. You can log it out to the console, for example. You could just copy this and paste it in the console, and you'd see that it does return an Apple object. You'll notice it has the name of the constructor function, which is here, and then it tells you what it returned. Well, it returned an object with the X is 10, Y 20, color red, and score 200, just like the values we've passed in here. Well, that's no problem. But there is a little bit of an issue. Once you create this object here, like that, so it returns that object. Perfect. How can my program later on reference this object? It can't. Because there's no way for me to reference, there's no symbol name to target that object in memory. So what you actually need to do is make sure that when you invoke it, you assign it a symbol name. So I'm going to say var apple1. And then when you invoke the function, it's going to return an object, and you can point to that object later on in your program using apple1. So I'm going to now save that out, hit refresh, and say apple1. There is apple1 with our defined values. And then you can start creating more instances, meaning more copies of this object. And they can all have different values. Each instance is independent from one another. So for example, this will return an object that's going to have these values. So I can just copy and paste that in. So we can have that, and you can have another one, and then you can have another one. They could all be identical if you really wanted to, but then you can start to change the values even then later on. Because each one is an instance. It is a copy of. We created this object from one function, but each instance, each object is unique. Just like, for example, you can have a MacBook that's identical to another MacBook, but one MacBook goes to another user and another MacBook goes to a different user. And you can change that MacBook, you can reinstall it, you can do different things to it. They're all objects. So even though they come from one factory, one construction house, if you will, or place, then you take that and then you can change each one independently of one another. It's the same thing here. Just think of this as the production line, making objects, then you've got each object, then you can keep changing the objects. What will happen is you will get different instances. We now have 3 Apple objects, and we're passing in different values. We're constructing that object each and every time off the same blueprint or constructor function. And there you go. Just hit refresh. Apple1. Apple2, and Apple3. And that's it. You now have Apple1 with its own set of values, and each one has its own values, whether it be red, green, or pink. And it has a different score, 250 or 10, and so forth. So you just keep going in this fashion where you construct objects, and that's all you're doing. You're just creating, in essence, a manufacturing line. You are creating a place where you are defining the blueprint of an object. And yes, each object can have different values, but it has the same structure, if you will. And yes, you can even modify the structure if you wanted to, which we'll talk about later. But overall, you're just creating objects from constructor functions, and your program can actually invoke this function by itself, so it can mathematically map out where it wants to place these apples, and then it can call upon this constructor function when it needs to and keep generating more apple objects. Prototypes are actually unique to JavaScript. JavaScript works with objects in a very specific way that other languages don't necessarily use. But what are prototypes? Well, prototypes are just shared objects. They're objects that have properties and methods that can be accessed via a range of different objects. And it's all down to how that object is constructed. So let's first of all take a look at a constructor. We have an Apple constructor constructing Apple objects with the color and the weight, but also you can have methods in there such as eat and throw. So we have a constructor function that will generate our Apple objects, and each instance is unique to itself. We have the color and the weight. However, there are some members, meaning some properties or methods, that are not unique to this object. For example, eat and throw. Well, you can eat and throw every one of those apples, and it's not a unique thing. Verbs aren't unique in that sense, just like we have cars with different color, styles, and makers. But what you also have is the verb drive. And drive is not unique to any particular car, it's just a verb that we have for that particular category of object. So, in lieu of that fact, what we actually need to do is use a prototype object here, a shared object for shared members. Our Apple objects can have a prototype object associated with it, with the eat and the throw methods. They're not unique to each of those Apple objects, so there's no point having a copy of the eat and throw methods for each object. We're just wasting memory here. We're adding additional copies when we don't really need to do that. We don't need it on the instance level. So what is the instance level? When you have an instance of something, such as the constructor is the blueprint for an object, and an instance is a copy of that object. So when we run that function, it returns an object. That is an instance. It's a copy. And on the instance level, it needs to be unique. You need to be able to identify this object from other objects, its properties, and so forth. You may even have unique methods, but typically you don't find that. So we want to now attach a prototype object to our constructor. And what this does is when we attach this prototype object, we are in fact defining a shared object. So now all of our Apple objects on the instance level for each copy has its own properties and potentially unique methods. So everything that's unique to that object is on the instance level. Each copy has its own uniqueness. But eat and throw are not unique to any one particular apple. So we can put that in the prototype. And then what can happen is, when I access any one of those objects, either Apple 1, Apple 2, or Apple 3, I can then ask it to access and invoke, let's say, the eat method. What will happen is, these objects are now linked together. So we have one copy of the eat and throw methods, but when I access one of those objects, such as Apple 1, 2, or 3, and I ask it for the eat method, it will look at those objects and it will say, well, I can't see that symbol name. Don't forget, a symbol name is just a memory pointer. And so we have a memory pointer here that doesn't exist in Apple 1. So what JavaScript does is it automatically searches the prototype chain. This is a chain of objects. It's just a link of objects. And every one of those Apple objects is linked to that prototype object, and it will look down this chain and it will find for every single one of those Apple objects that symbol name in the prototype, and we can invoke it. So now I just have one eat method and one throw method in memory, and everything that's unique is on the instance level. Everything that needs to be duplicated is duplicated, and everything that doesn't need to be duplicated, such as eat and throw, well, they just stay in one place, and we just have one copy. This saves a lot of memory, and it's very important for larger scale applications. For example, jQuery and lots of other popular JavaScript libraries use the prototype to make sure that they only have one copy of the verb of the subroutine and so forth, and they can have lots of instance objects, such as each Apple object, each copy, and it's unique to itself. So prototypes are objects, and they're shareable objects. They share their properties and their methods, so that you can access those members via the instances that were created. That's all it is. Now, one final thing. What about this? That word is so important. This is all based on context, and as I have said before, it is all about how it is invoked. So just take, for example, Apple 1. I go grab an Apple 1. That is an instance of the Apple constructor. That's what was created from it. And it's going to be linked up automatically with the prototype object associated with the Apple object. And I'm going to ask it to invoke the eat method. And the eat method is going to have a this keyword reference. Well, you need to look at how it was invoked to understand the context of this. We need to know what this is pointing to. So we know that it was invoked from the Apple1 object. That's where we used the member access operator. And we said Apple1 access the eat method and invoke it from that object. So we now know that when we use the this keyword in a prototype object, it's not just going to point to the prototype object. It's actually going to point to the object in which the call was made, which is Apple1. So you can think about the this keyword going back up the chain. It points to the very first object that invoked that particular function call. So if I was to use the this keyword in the prototype object, it points back to the initial instance that invoked it. And that is why we use prototype. And that's why it's so unique and special in JavaScript. And it actually does save a lot of memory. Hi guys, I hope you are finding this content really useful and adding value into your life, and I'm serving you the way that I should be with that great service of knowledge and information, and hopefully getting you excited about your career. And I hope you can get the value that you need out of this. And if you are and you'd like to contribute something, maybe buying me a cup of coffee, hit that Kofu link in the description down below and you can donate like $3. That will be enough to get me a nice cup of coffee, and I can still keep making great content for you guys. So now let's take a look at the existing project that we currently have. We have a constructor that allows us to construct instances of the Apple object with the color, weight, eat, and throw methods. Now the problem is that the eat and throw methods are not unique, so they don't need to be on the instance level. They're just verbs. You can eat and throw any Apple object. So what I would like to do now is put them into a prototype object, because now we have 3 copies of the eat and throw methods unnecessarily, when there could just be 1 copy of this subroutine in memory rather than 3 copies of each for each instance. And if we have more apples, there will be more copies of these subroutines, wasting memory. So let's take a look at saving memory and making our application more manageable. So what we want to do now is take a look at our callable object or subroutine called Apple. This is our constructor function that's building these objects. If you take a look at the window object and take a look at the callable Apple object, you'll see that this constructor has a prototype property. It is in fact a callable object. Don't forget, JavaScript treats functions as callable objects, and you have a few properties that you can look at. But mainly we want to take a look at the prototype property. So what I want to do now is target that subroutine, Apple or callable object, and use the member access operator to access the callable object, and I want to access the prototype property. And then I want to set it equal to a new prototype object. Any property or method is going to be shared across each instance that is generated from the Apple constructor. So what we have is the eat and the throw methods. I can now cut that out of the main Apple constructor functions execution context and paste it into the prototype. This means that I'm only going to have this 1 prototype object in memory and 1 copy of the eat and the throw methods that will be shared across all instances, all copies of the Apple object, and we're saving memory. Now let's go ahead and save this and then go into the browser and take a look at Apple 1 and run the eat method, for example, Apple 2 and Apple 3. When we do this, you'll notice that each one runs the exact same subroutine. I can even then modify just 1 subroutine. Don't forget, last time we were copying that subroutine or that method for each instance, but now I can target my constructor function, I can target the prototype, and I can actually change the eat method, for example, or I could add a new property or a new method onto the prototype, so I can change it, and then when I run it again on either Apple 1, 2, or 3, you'll notice that they're all pointing to the same subroutine that's in the prototype object. Now I want to use the this context. This is a contextual word. It needs context. If I point to this, in that sentence, what am I pointing to? I need a context of what I'm pointing to, just like what is this, that memory pointer, pointing to. So what I'm going to do is I'm going to change the eat method, and I'm going to change that to return whatever this is pointing to. Now, what I would like to do is refresh that in the browser, run it, and target, let's say, Apple 2, and then I'm going to run the eat method. Now, what's really important here is how is this method being invoked? This is so important to understand the this context. Is the this context pointing to the prototype object, or is the this context going to be pointing to the Apple 2 object? Well, the answer is it's going to be pointing to the Apple 2 object. And why is that? Because that's the object with the initial invocation. If you want to know what the this context is, you have to look at how that function was invoked. And it was invoked, meaning it was called up and told to run by the Apple II object. So what you see here with the this context is it goes back up the chain. That's really nice. And the reason why that's really nice is because now you know that when you use the this context in the prototype object, it goes out to the instance level. So now I can change the color property, for example, or I could change another property or add a new property onto the instance level, the unique level, and change that object in particular, which is really nice. That means I can have one subroutine with the this context, and the this context will point to the instance level. So if I invoked it from Apple 1, it would now, the this context, be Apple 1. And the this context for Apple 3 would be Apple 3. And so that allows me to go back up the chain and look at the initial object that invoked it, and then I can change that object. And that's actually how very popular libraries work, such as jQuery and other libraries. They use the prototype object and the this context, and it allows you to go back up the chain. So if you want to take a look at Apple 1, you have Apple 1 and then you have underscore underscore proto underscore underscore. Now the reason why you have that is the prototype object, but you're not supposed to modify that object directly through the instance level. You're not supposed to do that. You have to let the JavaScript JIT compiler actually link the object dynamically, which is what we're allowing it to do here. You should only be modifying prototype objects on the constructor functions themselves. You shouldn't be doing it through the instance level, and you'll probably find that this name may change in different browsers. They really don't want you modifying the prototype object through this property. But it's here as a reference. It's here as a pointer, if you will, a link, as in a prototype chain, and a chain is made up of links. So we've got links of objects. So we've got our prototype object that we attach to the Apple constructor that's being dynamically linked to. And then also we have another prototype object that again is being dynamically linked to, and you have a couple of methods and properties that you can actually access here. So this is actually something that's very unique. You can call a symbol name, for example, we have eat and throw, and it will look down the chain, and as soon as it finds that symbol name, it will stop and it will invoke that value, or it will return that value. Now, finally, what you have in this prototype chain is, again, it stops at the symbol name. So let's say I modify just Apple 1, and I'm modifying it on the instance level, on the copy level. Actual Apple 1 I'm going to modify. And I'm going to create the eat property. So now we have the eat symbol, and it's pointing to, it's referencing, it's symbolizing this string in memory. Now what happens when I try to invoke the eat method? Well, that's going to be a little bit of a problem. Because what's going to happen is it's going to look for the eat symbol. And as soon as it finds the eat symbol, it stops. Now, just for Apple 1, I've created the eat property. And if I try to invoke a property, you're going to get an error and say, sorry, it's not a callable object. So actually what you're finding is here, as soon as it finds the symbol name in that chain of objects, it stops right there. So now we have a block here, because on the instance level, we've got an eat symbol, but in the prototype, we've also got the eat symbol as well. Now it doesn't erase that symbol, because if I go to Apple II and call the eat method, it looks for that eat symbol name and it will invoke it because it is on the prototype, so it'll stop on the prototype. But if it's on the instance level, it will stop on the instance level. So it's as soon as it finds that symbol name, it stops and either returns that value or executes that value, that callable object. So be very careful about your naming and your symbol name so that you don't have symbol name collisions here. You have a collision with Apple I, but not with Apple II and Apple III. Apple I has an eat symbol on it, and also the prototype has an eat symbol on it. And so there is a collision between there. And it may not produce the results that you're expecting when you start running your application. So that's it. Prototypes are just shared objects. They allow you to share properties and methods across a range of objects. The prototype object is attached to the callable object that is the constructor. And when you construct an object from that constructor, it is automatically linked to that callable object's prototype object. And that's it. That link is dynamically established. And that's it. I just have to have one copy. And then I can use this context to go back out to the instance level to go to either Apple I, Apple II, or Apple III. And I can change those particular objects' uniqueness. So, hopefully that's taught you a little bit more about prototypes. Our subliminal conscience is constantly comparing values each and every day. And one of those basic ways that it does this is, for example, when you want to cross the road. First of all, you may look right and see if there is 0 cars on the road, and then you want to look left and see if there's 0 cars on the road to the left. So you're doing this comparison. We want to see no cars. And then if both of those statements are true, then we cross the road. And we call these comparisons that we're doing here comparison operators in programming. We, the programmers, are the subconscious. Even though your mind does this automatically, we need to be able to program this. And it's simply allowing our programs to ask questions. We are asking, does this equal this? Or does it not equal this? Is this greater than this? Is that greater than this? So what we want to do is ask questions. And by allowing our program to ask questions on certain data types and values, you are enabling your program to think. And you can change the way that your program functions based upon the conditions that you place within your program. So we're just going to be doing a little bit of console work here. So first of all, we have the double equals comparison operator, and it compares what is to the left of it and what is to the right of it. So what we're going to do is we're going to compare, let's say, the number 10 like so. So is 10 equal to 10? Yes, it is. So it returns true. Now with comparison operators, they always return a Boolean value. If what they have compared is correct, it will return true, and if not, it will return false. So is 10 equal to 100? The answer will be false. Also, you can compare strings such as hello. Is that equal to the string hello? Like so. And that's true. But is it equal to hello with a capital H? Let's find out. It returns false. So this is case sensitive. When it compares strings, it's very, very case sensitive. It not only looks at the characters, the values, but also the casing as well. Very important when doing comparisons. You can also have the floating point numbers like so. So is 10.5 equal to 10.5? Yes, it is, but it's not equal to 10.43. So that's going to be equal to false. Then also you have the null and undefined. So null is equal to null. And you also have undefined. Don't forget that when you see undefined or null in your program, it just means that whatever piece of memory that you're trying to address has not really had anything specifically allocated to it. Now also you can compare the Boolean values. So you've got true and you've also got false, which is equal to false as well, but false is not equal to true. So there are all of your primitive values. You've got integers, floating point numbers, strings, null, undefined, and so forth. One to be very careful of is nan. Nan is a primitive data type. However, it doesn't actually compare. So nan is not equal to nan. It's false. And we'll address this problem later on. So be very careful and never use nan with comparison operators. That is an absolute crucial must because you won't get a good comparison. So never use nan directly. Now, I want to talk about polymorphism. Remember, polymorphism is like Play-Doh. It's changeable. It's adaptable. We had a look at the plus operator when we said, right, okay, 10 plus 10. Well, this is a function in the JIT compiler that will take whatever's to the left of it and whatever's to the right of it and potentially add the values together. So we're going to get 20. But that may not happen in every situation because it polymorphs. For example, we've got two different data types now, the integer 10 plus the string 10. Well, that can't return an expression value. It actually returns a concatenation. So what it did was it said, right, this is a number, but strings take precedent because strings can contain numbers and letters. So what it did was it took the integer and it changed it into the string data type. It polymorphed, it changed it. You can think of it like a cast. It's changing its cast, its data type. It's ultimately retaining the same value, but it's just changing the data type to try to compare it. Or in this case, add it together, which it's going to concatenate when it comes to strings. So it's just concatenating those two strings 10 and 10 together, producing 10, 10, this string here. Well, likewise, the double equals operator does polymorph. It will change the values when needs be. So for example, a good case is null is equal to undefined. Technically, they're two different types of primitive values. However, null is equal to undefined. So what it recognized was that null is kind of like undefined. They both mean the same type of thing, so it just polymorphed. And in this case, it's a good thing. Numbers and strings. So I have the number 10 and the string 10. Now what happens is if there is a string either to the left or to the right of this comparison operator, a string always takes precedence. Why? Because strings can contain numbers and letters. So you can turn an integer into a string, but you can't turn a string into an integer or a number. So that's what we're doing here is it's polymorphing, it's changing the data type of that number and it's converting it into the string data type and comparing it. So it's literally the string 10 is equal to the string 10. And that's true. So to prevent this from happening, what we can do is use the triple equals sign. Now this will not only check that the values are the same, it will also check the data types as well. So null and undefined, even though they mean the same type of thing, nothing's been allocated to that spot of memory, they are different data types. So now when I ask it, is null equal to undefined, it returns false because it's not only checking the value and it's not trying to change the value or the data type, it's leaving the data types alone, it's leaving the values alone, and it's doing the comparison. There's no polymorphism with the triple equals. They are not equal to one another. And likewise, the number 10 is not equal to the string 10 in this case because there's no polymorphism. This is a number data type and this is a string data type and therefore it's false. They are not equal to one another. So that's how you prevent polymorphism from occurring when trying to compare two values to make them equal. Now likewise, you also have the is not operator. Sometimes you want to check to make sure that, let's say, a variable is not equal to null or undefined. So what I can do is I can say is null not equal to null? The answer is false. They are equal towards one another. But if I say is null not equal to undefined, we also get false again. Now, if it returns false, that means that they are equal, because don't forget, this is the is not operator. Is it not equal to this side? So let's say 10 is not equal to 100. True. It isn't equal. But also the value of 10, is it not equal to the string 10? Well, that actually returned false. So is the number 10 not equal to the string 10? It says false. So that means they are actually equal. Don't forget that we're asking, is it not equal? Is that true? Well, it's actually returned false. So they are equal. So there's polymorphism happening here because we have the string 10 and we have the number data type 10. So again, to prevent this, we need to use the is not operator with an extra equal sign. So we're going to say 10 is not equal to the string 10. So if you add that extra equal sign in there, it's now going to check the value and it's not going to change the data type. So now it's going to say true. They're not equal. 10 is a number, that is a string, they're not equal. Likewise, null is technically not equal to undefined. However, if you use the single equal, it will return false. For example, null is not equal to undefined. That returned false, meaning it's equal. But technically, they are not equal. So that should be true. So now is null not equal to undefined? You'll notice it says true. They are not equal. Null is a different data type to the undefined. And we're just trying to compare them and find out the best ones. So we're just trying to compare these values and we're trying to find out is the data type matching and also is the value matching as well. So there is the double equals and the is not operator. They polymorph, and if you add an extra equal sign onto them, they will no longer polymorph. Now also we have the greater than operator. So is 10 greater than 100? So it's going to look at what is on left. 10 isn't greater than 100, so it returns false. But 10 is greater than 1. So that's going to equal true. Now you can also do this with strings as well, such as hello. Is hello greater than the string hello? Well, the answer is going to be false because this string isn't greater than this string. They're both the same value. But however, if I had a few more O's onto my hello, you'll notice it says true. So this string is greater than this string on the right. So that's that. But you also have the greater than and equal to. So you can say the number 10 greater than and equal to 10. Because beforehand, if you said is 10 greater than 10, no, they're equal. But what you can do is have greater than and equal to. So if it's either greater than or if it's equal to whatever's on the right, return true. So 10 is equal to 10. You also can invert that around. So is 10 less than 100? And that's true. You can tell by this little point right here. That's how I remember. If it's the big one on the left-hand side, it's greater than. If it's the little one, it's less than. Is that less than, smaller than this side, which is bigger? And it is. So now we can also have is 10 less than 1? The answer is false. It isn't. And also you can say, is it less than 10? Well, 10 isn't less than 10, so that's going to be false. But you could say less than or equal to, again, just by adding in the equal sign. Well, 10 is equal to 10, so that is true. And you could also try to do this with strings. Now, I don't recommend using the greater than and less than and equal to and greater than and equal to operators with strings because they are kind of funny. So for example, you can have the hello, is it greater than, for example, hello? That's going to be false. Now, if I add a couple of O's onto here, it's going to be true. This string is now greater than this string. And you're thinking, yeah, because the length is longer in that string, for example. There may be more spaces, more characters. But what happens when I add a capital H onto this string? Well, now it's false. This string is no longer greater than this string, which is showing me that it's not actually very good at comparing strings because I would consider that string to be a little bit greater than the string on the right. So as you can see with these comparison operators, you can sort of compare them and see which one suits best. So take a look at the comparison operators and review them all. You have the double equals, the triple equals, then you have the not equals, and is not equal value and type. Then also you have the greater than, less than, greater than and equal to, and less than and equal to comparison operators. Start playing around with them, experiment with them, see how they work, and then come back to me in the next lecture. So in the previous lecture, we were asking questions like you'd ask questions when you want to cross the road. Is there no cars to the left or to the right? And then we can cross the road after we've evaluated. However, you actually have the verb, the execution of walking across the road. We first ask the questions in our mind, but then you actually have the verb of walking. You are walking across the road. Well, likewise, we need to program this as well. Well, in our program, we have if statements, and in here, what we do is we write the condition in the parentheses. So this is where we say, right, I want to look left and I want to look right and I want to see if there's a green man showing so that I can cross the road. But then also you're going to need the braces, and the braces will define an execution context. This is the action, the verb, the thing you actually want to execute. So likewise, this is what we're going to do here. You define the instructions that you want to run. So let's go ahead and define the condition. So for example, let's say I want to make sure that the green man is equal to yes, like so. So here we have a comparison operator. We're asking a question. We're evaluating the green man value. This is this variable here that I've defined. I want to look at that variable, pull out its value, and indeed the value will be yes, and they are equal to one another. And again, make sure this is case sensitive. So if I have a capital Y here and a lowercase y there, it's not going to be equal. So be very, very careful about evaluating strings. So once I've evaluated it, I can then log something out to the console. So console.log, and I'll say cross the road. There's my verb, my execution, if you will. And if I hit refresh, it immediately went down, it created these variables with the values, and then it took a look at the if statement and it asked, what is the condition for the execution? And all it needed was the green man, and it needed to be equal to the string yes. If it is, then log this out to the console, cross the road. There it is. So, in fact, this condition evaluated to true. It's a truthy condition. It's either going to be true or false. The conditions have been met or they haven't. So, we have now a true if statement. Now, if this was not true, for example, the green man is equal to no, then unfortunately, these strings won't match, and therefore you no longer have a truthy statement, you have a false statement. So now let's take a look at this. If I go ahead and save it and hit refresh, nothing happens because it's not true, and therefore we don't perform the action. So this leads on to something else. You can write as many if statements as you'd like with your different conditions, but sometimes you want to ask a series of questions. So for example, if something doesn't work out, then else if. What if something else could be done? So let's go ahead and say else if. An else if statement again requires a condition, and we can check for a different condition this time. If the green man is on no, I can still cross the road if there's no cars there. So let's go ahead and say, take a look at cars left, and I want to see if cars left is equal to 0, then I want to perform a different execution context, this action down here. So now I can go ahead and save this, and I can hit refresh. So the first if statement was false. So this execution context was never executed. The second conditional execution context, well, the conditions were met for this execution context because cars left is equal to 0. So we can log out to the console or clear cross the road. And don't get me wrong, you can have as many commands in here in this execution context, just like a regular function. So you can go ahead and save it and hit refresh. And there it is. It's a true statement. But let's say if all of them fail. So let's say that cars left is equal to 1. Well, cars left is 1, and is it equal to 0? No. So this is now a false statement. Therefore, it's going to prevent any execution. So it's now no longer going to execute anything. But what you can do is say if all else fails. So else doesn't need a condition. It says, look, if all else fails, then do this. Console.log, and then we can say stay where you are, and save that out and hit refresh. So this statement was false, so we don't execute that. This statement was also false, so we get rid of that. And if all else fails, so they did, then execute this execution context, which has no condition on it, and we just say stay where you are. And there you go. We now have stay where you are. So we've chained this, and you can keep adding as many else if statements as you'd like, and keep adding as many questions as you would like, if you will. But I just need these 3 conditional execution contexts chained together using if, else if, and finally else. And again, you can optionally add in else, and you can optionally add in else if, but one thing you do need to start out with is an if statement. So now what I'd like to do is we have cars left right here, and I'd like to ask a little bit more information with this conditional statement. Whatever is written in between these parentheses is called a conditional statement, and it's just checking to see if conditions are true. But we have cars left, but we also want to check the right-hand side of the road for any cars as well. So what you have here is the ability to chain multiple comparison operators. Don't forget you got the asking just one question like, is cars left equal to 0? That's not really good enough because we also want to check the right-hand side, and I don't want to have to write a separate if statement because that just wouldn't work. So what I can do now is use the and or the or operators. Now, which one would be correct? Well, and would be correct because you need one and the other, whereas the or operator is one or the other. If one side is true or the other side is true, then go ahead and perform this action. So let's take a look at this. If I say and, so I'm going to say cars left is equal to 0 and cars right is equal to 0. Then if both of these are true, because we need this and this to be true in order to execute this execution context. So we say console.log all clear cross the road. So let's go ahead and save this now, and we hit refresh and it says, sorry, no, that's still false, stay where you are, because cars left is not equal to 0. Cars left is equal to 1. So that is actually false. Now, cars right is equal to 0. You can see it there. So that is in fact true. However, you need this side to be true and this side to be true. So in this case, we have on the left-hand side a false return from that conditional operator. And of course, if you get one side false, it's all false. So that's going to return false from that and operator. Sorry, you need both for it to be true. However, if you use the or operator, it means one or the other must be true. So if I save this now and hit refresh, you'll notice it executed. It did say console.log all clear cross the road, as you can see. And that's because even though cars left is equal to false, because it's not equal to 0, so that's false, and cars right is equal to 0, which is true, it says one or the other, and it's going to go with any truth. If this side is false, or is the other side true? Well, it is. So as long as one of those sides is true, it will return true, and it did. However, we know that roads have two sides to them unless you're on a one-way street, and if you don't look both ways, you could end up being flattened by 2 tons of metal. So what we want to make sure is that we use the and operator here, one and the other. The left side has to be true and the right side has to be true. The or operator says either the left-hand side has to be true or the right-hand side has to be true, and that's it. All right, so I'm going to change this to the or operator again, and I just want to mix and match this up. And I also want to say, is the green man equal to yes? We're going to use the and operator again. So what I want to do now is I want you to look at this conditional statement, and I want you to tell me whether it will, if true, execute this execution context, or it won't execute this context. I want you to pause the video, and I want you to again have a look at the Mozilla Developer Network, or MDN, and we have all of these operators here that are defined, don't forget, in the JIT compiler, and they all have an order of precedence. The ones with the highest number are executed first, and you scroll all the way down, and those are executed at the end. So what I would like you to do now is look at that condition, and then I want you to go through that entire statement and tell me whether or not this is true or false. Pause the video now, and then you can come back and see if you were right. So what we have first of all is we have the strict equality operators. So if you take a look at this and I scroll down, you'll see at level 10, we have the strict equality operator with the triple equals. That's the one that currently has the highest precedence. So we start with the first one on the left. So is the green man equal to yes? Well, the green man variable is equal to no. So this is false. And we want to take a look at cars left, and then you also have cars right. And again, these operators here currently contain precedence. Well, this one is to be evaluated next. Is cars left equal to 0? Well, cars left is equal to 1. So this is going to be false. Then we have cars right. And is cars right equal to 0? Well, cars right is equal to 0. So this is true. Now we also have the and or the or operator. So let's take a look at this if we can find it here. We have first of all the and operator, and then you have the or operator. So we have 6 and 5. So we've got to go with the highest order, which is the and operator. So if you take a look at this, we have the and operator, false and false. Well, don't forget, for an and operator, you need this side to be true and this side to be true, so it's going to return false. But you still have this or operator in here. And if you take a look at that, that's the next one, the final one, the or operator, and it's going to say one or the other. Well, this side is true, so it doesn't matter. It's one or the other. Either side could be true, and with the or operator, if either side is true, it returns true. So in fact, the answer is yes, it will, with this current conditional statement, actually return console.log or clear cross the road. Let's take a look and see if we are right. And there you go, it says all clear cross the road. Now I'm going to change this because I actually want this to evaluate to false. I want to make sure that there is a green man always showing and at least one side of the road is clear. So what I do is I use the parentheses again, these round brackets. So I'm going to put in the parentheses like so, and what happens is you've changed the order of the execution because whatever is in between these parentheses is going to be executed first. And why is that? Because the grouping operator, or the parentheses, is in fact the most important operator in this statement as it currently resides at level 20. So it looks at whatever's in between these parentheses and evaluates what is in between them. So if we take a look inside of the parentheses, you have the strict equality operators, which they take the highest order. So what we want to do is we want to first of all evaluate it. Is cars left equal to 0? Well, cars left is equal to 1, so that's going to be false. Then we also have the second strict equality operator. Is cars right equal to 0? The answer is true. And again, we just wanted to check whether one side of the road was clear, so that's okay. So we want one or the other. So this is the next operator to execute. So this side is true. Wherever it finds a true on the or operator either side, it's going to return true. So the total evaluation from what's inside of the parentheses will return true inside of those grouping operators. So it's evaluated everything, and then it says, and does the green man equal yes? Well, the green man equals no. So this is going to be false. So you can see that by adding in those parentheses, we've evaluated what was to the right of this and operator first, and then we did what was to the left of it, which is now false. So with the and operator, you need one and the other side of the operator to be true. Fortunately, that isn't the case here. So we now want to return false. That will prevent this from executing. Then we have the else statement, which will say stay where you are because the green man needs to be there. So you can now see how adding in the grouping operator, just like in mathematical expressions, when we use the parentheses, it evaluates what's inside of it first. So if I hit refresh, you'll notice it says stay where you are. That is operators, that's their precedence, and that is basically where you have an execution context that is a conditional execution context. It executes upon a condition being met, and you can chain these execution contexts together. Likewise, you could say, right, is the green man equal to yes? So let's go ahead and change that to yes, like so, and then hit refresh, and you'll see that the green man, if it's equal to yes, console.log cross the road. And there it is. You get the value out across the road. So as soon as it finds a condition in a chain of execution contexts, this is a chain of 3 execution contexts right here. And if the first one is found to be true, then it will just stop there, execute that, and return it. And the other ones will be ignored. So there we are. Execution based upon condition. Loops in programming languages allow us to have repetitive tasks repeated dynamically over and over and over again. This helps us as programmers write efficiently. So for example, I could print each one of these names out to the console. So I could say console.log, and then we take a look at the class register, like a teacher will pull out the register, and then we start to iterate through it. So we start at 0, and then we go to 1, and then 2. So that is all of the indexes. This is the 0 index, then you got 1, and then you got 2. And we can print out these strings, these elements here in the array to the console. Save that and hit refresh. Now that's okay, but the class register could potentially change. We could add names in there or actually delete names out of there. On top of that, doing it this way means I have to write it out line by line. And as I said, there's a problem with this because things can change, things can be altered, and that's not good for us. So having a repetitive execution will prevent this from happening, and it will allow our program to be more flexible. So let's go ahead and take a look at the for loop. And you'll notice with the for loop, syntactically, it looks very similar to the if statement, where you have the parentheses, and then also you have the braces, and in the parentheses we define conditions, and then also you have the conditional execution context that will execute when the conditions have been met. And you can think of the if statement as a singular on its own. So for example, if this condition is met, then run this instruction once. But you can think of the for loop as a plural, as multiple. So for example, the condition may be true for maybe 2 or 3 seconds whilst your program is executing. So this condition, while it's being met, is like a plural. It's running this execution context multiple times. So you have the single version, which if you just wanted to check something once and run something once, you'd use if. And if you would like a plural, then you would use a loop, for example. Now, what do we do here with the loop? Well, first of all, you need an index. Why? Well, when a teacher goes through a register, for example, we have a teacher with a class register, what she does is she starts ticking off boxes and saying, right, that's Lawrence, are you here? Tick the box. John, are you here? Tick the box. Jeff, you're not here. You know, cross the box. But whatever there is, there's an index for each one of those persons, so she knows where she is in the register. So likewise, we have a teacher here, and this teacher needs to know where they are in that register. So what I'm going to do is create a variable called I, which is index. You could call it whatever you wanted. You don't have to give it the name of I, but I will. And I'm going to set I equal to 0. And yes, you can define this variable within the parentheses. So var I equals 0. Then we put an ending semicolon because that's actually one statement. That's one part of it. But the next part is the actual condition itself. If this condition remains true, then we continue to execute. So what I want to do here is say, is I less than the class register.length? Now, what have I just done here? Well, this next part, this next statement is a conditional statement. Now, I at the moment is 0. So 0 is less than the class register.length. Now, let's take a look at the array itself. If you actually take a look at the class register, don't forget, they are objects, don't forget, that have the key names as the index, so 0, 1, 2, but you also have the length property, which tells you how many elements, how many values are within this array. And you'll notice it has 3 elements, 1, 2, and 3. And this is actually quite nice because we're starting at 0 and then we are taking a look at the length, which the length tells us there's 3 elements in the array. And this actually works quite nice. So is I less than class register.length? So whilst I is less than the class register.length, we're just going to keep running this execution context. But likewise, you need to make sure that at some point this condition right here fails. So if I always remains at 0, this condition is always going to be true and it's always going to execute. And you can see the problem there. If you continually execute something constantly, you're going to get an error in your program. So at some point it does need to fail. It just needs to last the lifetime of the condition and then it does need to fail. So what I'm going to do is say I++, and this will increment I. Incrementing just means add 1. So +1, +1, +1, +1. De-incrementing means -1, -1, -1, -1. Dead easy. So we're eventually just going to keep on incrementing. And if you keep adding 1, then it will eventually be equal to the length of the array. And at that point, it will be false. I will eventually be greater than or equal to the class register.length. It will no longer be less than. And so this will eventually end up being false. That's very important. It's also important because we want to use I to access each one of these elements in the array. So let's take a look at this. We've defined an index counter, so we've got something to store where we're at in this register. Then also you've got the condition in which if I is less than class register.length, we're not done. We need to keep iterating over until we reach the end. And then finally, we just want to keep incrementing each time, just like a teacher going through the register. She is incrementing through the names one by one by one by one. So what I want to do is console.log and then say class register, and then I want to use the computed member access. Don't forget, you can write a statement inside of here and you can actually pull out values, and you can even use variables. And yes, we can use this variable I in our execution context for the for loop. So please do remember that. So I'm going to say console.log class register I. And so let's take a look at what this actually produces. I'm just going to hit refresh and you'll notice nothing changes. It's still printing it out, but this time I'm not having to write out line by line. And if I add, let's say, a new name and save this now, it's being printed out dynamically. So what is actually occurring in this for loop? First of all, we have the class register. And what we're doing is we're setting up the variable I is equal to 0. So we're starting at the 0 index. And we're saying, is I less than class register.length? So I is currently 0. That's what I is. So 0 is less than class register.length. And don't forget that with your arrays, this array here, it is in fact an object. And this object has the length property that tells us how many elements are in the array. So if I go ahead and hit refresh again, 0 is less than class register.length, which is 3. That just returns the value 3, so that's true. So we're going to execute this execution context, and it's going to say console.log class register I, and it's going to look at the value of I, and it's going to be 0. Then, after it's finished executing this context, we say I++. So now I is equal to 1. And is 1 less than the array length, which is 3? Yes, it is. So we want to execute again, and I is now equal to 1. And we're console.logging the class register 1, which is John. That's John there. He's on the index of 1. And then once it's finished executing, we add 1 again. So now var I equals 2. And is 2 less than 3? Yes, it is. So execute it again, console.log class register. Take a look at the value of I. I is now equal to 2, and we want to print out the element with the index of 2. You got 0, 1, and then 2, and Jeff right there is printed out. And that's it. And then it's incremented again. So now var I is equal to 3. Now, is 3 less than 3? No, it's actually equal to 3. So now this statement is false. And when this statement is false, we no longer execute, and all of that's just dumped out. That's what's happening there, is we're just simply iterating over, meaning going one by one each value. And all you need to do that is you need a counter to keep the index. Then you need to check the index to make sure that it's lesser than the length that you're trying to iterate through of an array, for example, and then you want to keep incrementing until you have finished. So you are able to iterate, which means go one by one by one. And you can do iteration by two types. You can increment and de-increment. So at the moment we're incrementing, we're adding one. So we go one by one by one. We start here and then we keep adding one and go up. But de-incrementation means that we start at the end and then we go down the elements in the array. So this is incrementation. If I go ahead and just copy this out, and then what we do is we just comment it out and paste it down below, we add incrementation. Now what I'd like to do is invert this and de-increment. So I'm going to say class register dot length minus 1, is it greater than or equal to 0? And then we're going to say I minus minus this time. We're taking away 1. So let's separate these guys out a little bit so that we can see what we're doing. If I save this now, let's hit refresh and we should get an inverted list. Instead of going Lawrence, John, Jeff, it should be Jeff at the top. So if I hit refresh, there it is, Jeff, John, Lawrence. How did this work? Well, we have an index again. We need to make sure we have a place to start at and to keep incrementing through. And in this case, we're de-incrementing, and place where we start and de-increment through. And then what we do is we say, right, class register.length is going to be 3. Don't forget, class register is an array object with the length of 3 right here. But this right here, Jeff, the very last element, the very last index is actually 2 because it's 0 indexed. So we actually want to say, right, go get the class register, tell me the length, and then minus 1. 3 minus 1 is 2. That gives us the index of the last element in the array. So that's what we've got there. 3 minus 1 equals 2. That's going to point to Jeff. And if I change the length of the array, it would be different. So we have var I equals 2. Then we're saying is I, which is currently 2, greater than or equal to 0? And that's true. 2 is greater than 0, so minus minus. So we start with I being 2, and then you keep de-incrementing. So I will eventually be 1, and then you go down to 0. And 0 is not greater than 0. However, 0 is equal to 0. And so this statement is still true. And so we can pull out the very first element in the array. And finally, I will be equal to -1. And when I is equal to -1, -1 is not greater than, nor is it equal to 0. So it's going to be false. And that's it. So that's how you can increment through and de-increment through the elements in your array. Now finally, there's one last thing I want to cover, which is the for in loop. So this time I'm going to write for, and then I'm going to create a variable called index, and this index is going to be for the class register. So what current index are we at in the class register? And then we're going to have our for loop, and we can say console.log, and then we can say class register, and we can access the class register array, and we can pull out whatever is at the value of index. So index to begin with is going to start at 0. Now please do note that the for in loop is incrementation. It's not de-incrementation. So if you want to step back through your array, you want to go from the last element to the first, you need to write your for loops like this. However, if you want to increment, you can write it this way, but this way is very verbose, meaning it's very stretched out. You got to write a lot of code, compared to this guy, which is a bit cleaner because we have the variable index equals 0. This will be automatically incremented, and we're saying, right, I want you to increment it for the class register. So take a look at all the indexes in the class register, and this variable here, which you just define the variable like that, you don't actually use the assignment operator, you just say var index, and the index will automatically be assigned 0 and then incremented 1 and then eventually 2 for our array because we only have 3 elements. So that's all that this is doing. It's just a memory pointer pointing to a number, an index that we can access. And as you can see, this is incrementing. It's starting from the beginning and going through. So we say class register index, and that's it. We log out the class register, and then we take a look at the index, and it's going to be 0, 1, and 2. Hit refresh, and there it is, Lawrence, John, Jeff. So this syntax is a little bit cleaner, and that's called the for in loop. And we're taking a look for the indexes in the class register. So you can see how that like strings together like a really nice sentence. Just don't forget the var keyword in there because we need a variable. We need a memory pointer to point to a value. So we're saying console.log class register index. There it is. There are your different types of for loops. I definitely recommend sticking with for loops because for loops are heavily optimized in JavaScript. Even in older browsers, they are fast. They are incredibly, incredibly fast. So please make sure you use your for loops for repetitive tasks. Hi guys, I hope you're really enjoying the Avelx content, and I always want to go above and beyond. That's why I'm creating the platform Avelx Academy. Avelx Academy will allow us to grow and collaborate courses together rather than me creating it. We can do it together. We can have a community where we can go if we have troubles and problems. And I'm also offering completely free when you sign up to cheat sheets, extra information, extra blog information, extra tutorials, podcasts, and other things that will be available through the platform. So sign up today with Avelx Academy. ES6 is short for ECMAScript 6. The ECMA body is the one that controls the standards for the language, and they also bring out new versions of the language, just like HTML has new versions as well as CSS. Well, that's the same for JavaScript, and you could also call it ECMAScript if you wanted to, and it's ECMAScript version 6 or JavaScript version 6. And this new version allows you to define a new way to create a variable. The first way, which is the way we've already seen, is a standard variable. The new way is using let, and also you have constants. In either case, you have symbol names. These symbol names are just like an address to your house. They allow you to address values stored in memory. You're probably going, well, why do we need let? Well, let has more respect for scope, and we're going to demonstrate this. But first of all, I just want to demonstrate that in fact these are all symbol names. You have the symbol name for the variable, you have let symbol for the scoped value, that string that we're storing, and also you have the constant, which is sim name. Symbol name is a variable container, which means its value can vary depending upon what you assign it. You can assign a number or anything else. So you can reassign the value to this memory address. It's kind of like knocking down the house and then building a different house. Also with the let symbol, you can also assign new values. They are variables. And now my let symbol will reference the new value placed in its memory address. Then you also have constants such as sim name that once set, you cannot assign a new value. And you'll notice that we get an error if we try to do such. But why would I want to use let? What's the whole reason behind it? Well, let creates symbols that respect the scope that they reside in, particularly with conditional execution context. So let's cut this out. And then what I want to do is take a look at an if statement. An if statement takes a condition, and upon that condition being true, it will execute whatever is in its execution context. So we are in essence defining an execution context that's conditional, and we want to see if it creates these symbol names where we expect it to be. So I'm going to save this now and hit refresh. First of all, what about this variable here, symbol name? Well, when I take a look at that, it actually allows me to pull out that value from memory. But that shouldn't have happened, because this is the scope here. That is the scope. That's not the window object. And what it did was it went out of that scope and it actually attached that symbol name to the window object. And that's very bad because we're adding a global variable here. And you could have all sorts of problems here. Naming collisions. I could have another if statement down my script using the same symbol name, thinking that the variables respect the scope. But variables don't respect conditional execution context, such as if statement execution context. So that didn't work. Now, what about the let symbol? Well, we created that symbol name, let symbol, and you'll notice it says, sorry, it's not defined. So the let symbol was defined within these braces, and they are scoped. It respected the block level scope. You also have a constant. You can also think of this as a block of commands that we're placing together and we're asking to execute it, and it respects that block. What about the constant as well? Constants also respect the scope of this conditional execution context, and that's why you should use let if you want to respect the scope. And also, don't forget, you also have other types of execution contexts, such as, for example, a for loop. So you also have these parentheses here, and we're creating a variable called I. And also, let's paste in those instructions again. So we have the variable, and we also have let, and we have constant. Let's see if variable respects this conditional execution context, and also this variable here respects the parentheses. Let's go ahead and hit refresh. Let's see if I has been defined. I has been defined, and I is equal to 5. So it created this variable, this symbol name on the window object. It jumped out of this scope, these parentheses here, which has caused a huge problem because now my window object has a symbol name called I unnecessarily. I don't need that symbol to be globally accessible. Also, we have this symbol name here from the variable symbol name. That also did not respect the scope. So vars don't seem to be respecting conditional execution context scope. However, let symbol, for example, that did. Let symbol, sorry, that's not defined. It was defined within this scope private to this execution context. Also the constant, which is simName. SimName also respected the private execution context of this for loop. So it's private, but var didn't. And that's why you should use let. And also let will solve that problem here. Now I'm using let for the symbol name I. Now if I try to access I, it's going to say, sorry, that's not defined. So it respects the parentheses and it also respects the braces. Now I want to further stress that you have your functions right here. Now with functions, var is respected. So if I create a variable with a symbol name var symbol, and then I assign a value, and then I hit refresh, you will notice that var symbol is not defined. And if I run those instructions, so I'm invoking that execution context, and then I try it again, you'll also get the same error. So variables respect only the scope of a function's execution context, but it does not respect anything to do with for loops or if statements. When it comes to that, you should use let wherever possible because it respects the scope of those execution contexts or conditional execution contexts to be specific. In the JavaScript programming world, you will hear a lot about the DOM, or DOM, or Document Object Model. And I want you to think of this like a representative. For example, you have an advocate, such as a lawyer or a solicitor in a court of law, and you have the person they're trying to defend. The lawyer is not the person themselves. However, they speak on behalf of the other person. There's an advocation. Well, likewise, we understand that this does happen in JavaScript. Let me just show you something. If I go to the console and type in window, we have an object. This object is like to JavaScript the advocate. It gives us information, details, APIs on this particular window. Now we are looking at this entire window object here, but we understand that this object isn't that window object. It's not these buttons here and this button here and this address bar here. It's an object so that JavaScript can understand it. It can get details of this particular window. It's an advocate. It's a way of interacting and communicating with this window object. Well, likewise, you also have the DOM as well. All of these elements, you've got HTML, then you've got the header with some information in, and then also you're going to have the body as well, which is the visual representation. And you can see here we have the header one, and you also have the included myapp.js script. So you have all of these things here. You have these nodes, what are called nodes. You can think of nodes like leaves on a tree. A node is just a small piece of a larger system. So you have the overall tree structure, and then you have the little nodes, which are the leaves. And likewise, you can think of the document here as the overall tree, and you have lots of nodes, lots of little leaves that make up the tree structure. Now, likewise, we do have an object that resembles this document here that allows us to access the document, change the document, so we can change what the user is visually looking at. Currently, we've only been working really in the console and modifying data, but what we haven't been doing is actually changing the visual data that is presented to the user. Now, understanding data, how to work with it, modify it is very important. That's the first step. But then you need to be able to present this data, hand it back to the user. And in that sense, we need to be able to access the document that they're viewing. So just as we have a window object which tells us all the information about this window, we also have the document object. And if you take a look at the window object, you can see that document is actually a global symbol available to you. So it's attached directly to the window. You've got the overall window here, and then you've got the document here. And so the document object, just as you can see when I hover over it, you can see it highlights it for me automatically. So we've got the overall document. It tells me, the URL, so where we're currently at, you can see there. It just gives us information. It represents this document. Where's its location? What's the active element in the document, such as the body element, which is where we put in nodes, we put in HTML elements that are visual to the user. So you got the document. And then also you got child nodes. Remember, you have the overall tree structure, which when you look at this, when you start folding things out, what you have is a tree structure. And you have nodes inside of there. So you've got child nodes to the document. And you've got the doc type there on the 0 level. That goes here. That's the 0 level. And then also you've got HTML as well. So you've got the HTML element. That's the root element. So if we go back to console, we go into HTML, and again, we get details about the HTML element. So for example, base URI, that tells us the file location. You got, the height of the HTML element, the client width, and so forth. So you got all sorts of information about this element. It's not the actual visual element that you're looking at, but it's an object that represents it, that gives us details and actually allows us to modify it. And within the HTML, you also have child nodes. So you go into the child nodes, and there it is. You've got the head, the text, and the body. So if you take a look at the elements right here, you have the head and you have the body. So you can have a look at the head and you can modify stuff in the head, for example, which we've got the meta and the title. So if you go into console, you can go into head, for example, and you can also take a look again at the information about the head element, and inside of there you also have other child nodes. So to take a look at the child nodes, in here you have text, meta, text, and also title as well. You have all this different information, and I can actually modify the title of the document via HTML. You have the inner HTML or inner text, and there we go, JavaScript Essentials, and that's showing up there in the browser, and that is there, JavaScript Essentials. So it's giving us details about this specific node in my tree structure. And that's it. That's how I look at it. And also, you have within the HTML, you've got child nodes, and then you've got the head. You've also got the body. And the body is normally the one that you want to access. So you go into the body, and again, you've got base URI, you've got all sorts of information, and also you have child nodes, because we've got the body element. So you open that up. Now we can take a look at the child nodes, which is the header 1 and also the script node. So we can take a look at the header 1 node. So go into console and just say child nodes. It's an array, and there it is. We've got a header 1, and you'll notice when I hover over it, this object is linked to the visual representation of that node. So I can hover over it, say header 1, and again within header 1 I can take a look at changing the computed name. I can take a look at the inner text, the inner HTML, and so forth. And there's tons and tons and tons of information, such as events, and we'll take a look at events later on. But you can see the document object model is where we have a document that's represented by objects, and it's modeled upon how you've developed your HTML file. So when you're developing your HTML file, there is an object structure that is automatically generated by JavaScript, and those objects represent those elements you've created. So that's what document object model means. It's not the actual visual thing that you're looking at, but it is an object representation of the document. So you can modify the document in JavaScript using objects, and that will reflect back the changes to the actual document. And in the next lecture, I'm going to show you how to access this document and work with it. So instead of saying document dot, for example, child nodes, and then I go into this array and then I say, right, go grab the first element in the array, which is the HTML. Then I also want to take a look at the child nodes again. Now it's keeping track of this, but this is not convenient. This is not a good way to access the DOM. Then I want to go ahead and try to accessing the body now, and you'll see that it's printing out the HTML here. And again, these are objects. You've just noted that these are objects, but the console just prints it out in HTML format just to make it nice and easy for you so you can highlight things. And then you need to go into child nodes again, and then you need to do this and that. This isn't convenient. This is not the right way to access the document object model. I want to, let's say, access the document object model via CSS selectors, via their ID, via their classes, and so forth. This is so important because the reason why we want to do that is because if I start changing around, let's say, the nodes, so now we have child nodes, and then let's say child nodes, and I want to access the one on 2, let's say that's going to be text. Let's try 3. That's script. So I'm going to say 1. There it is. There's the HTML. So you see, even now I'm getting a little bit confused as to what elements are on which index. It's getting a bit confusing now. So now I've selected my header 1, for example, but if I go back to brackets, and then I change my index.html. Let's add in a paragraph, for example. And now I'm going to say, hello world. Well, now the paragraph has taken over the JavaScript Essentials ID. This was at 1, but now this paragraph could potentially be at the level of 1. So when you start modifying the HTML, then this could break, and that means your script can break because it's not targeting the right element. So this isn't a good way of accessing the document object model. The document object model is generated automatically. We've got a ton of objects, but the way we access the document is a lot like how we access it via CSS. We use the CSS selectors and we target a specific element and then we style it. Well, you can do the same thing in JavaScript. And that's what we're going to do next. So we've discovered that trying to select elements via going manually through the document, for example, getting the child nodes and then taking a look at those child nodes and sort of going through the directory structure of the DOM, we can sort of access, let's say, the body element, and you can also access other elements in the body element. But this is not feasible. If I start adding elements and I start changing elements in the HTML page, the indexes of these child nodes, these child elements, can change. I could add another paragraph element, and now all the indexes have changed for all of these child elements. So what we want to do is make sure that we don't add any more problems and that our program is robust enough to target the right element so that we can display that information to the user. So the way that we do this is you have several methods that come with the document. Don't forget, document is a global variable, and the document object has a prototype object attached to it, and it also allows for a few methods as well. So you have all sorts of properties that tell you about the document. You can even attach events onto the document, which we'll talk about later. But also you have certain methods that you can run that allow you to target, for example, specific elements within the document object model. So we want to try and find these objects that resemble or represent these HTML elements. So at the moment, we don't have anything specific. We don't have any class names or ID names. All we have is tag names. So let's try and find the tag names. So I can say document.get element. Then you can see you have get element by ID. Well, we don't have any IDs. Class name, by name, by tag name, and it's also namespace. Whenever you see NS, it means namespaced. And you also have a few other selectors as well. So we have get element by tag name, and then I can simply provide the tag name that I want. I want to get all the paragraph elements, for example. So I'm going to say, right, get all the paragraph elements. And I put it in a string. You don't put in the angle brackets, you omit those. But what you do is you just type in the name, and there you go. We've got one paragraph element. And you'll notice it returned an array. Now, whenever you see one of these methods return an array, you know that it can return multiple objects. So for example, we're getting all the elements with the paragraph tag, and we can hover over that. You can see when you hover over that object that represents that DOM element, it also highlights it in the browser for you. And again, you could have several paragraph elements. So you can have 1, 2, 3, and then 3, 4, 5. Save that, hit refresh. And now when I run this again, we have 3 paragraph elements that we're targeting here, 0, 1, and 2. So we have all of those paragraph elements that have been returned. And we're targeting each one of those paragraph elements, and you can modify those paragraph elements, you can change them, you can do whatever you like to them. So get elements by tag name just allows you to target an element with a specific tag name. If I wanted to target this header 1, for example, I would type in header 1, and there it is. Hit return on that. There you go, header 1. Now this is okay, but we're going to select every paragraph or every header 1 in the document. Sometimes you want to target something specifically, just like with CSS styling, you target something by its ID, or you could target multiple elements by their class name. Because you've got get elements by tag name, and whenever you see elements with a plural, you know that it's going to return an array because there could be multiple objects returned. However, if we wanted to get an element by its ID, we need to first of all assign an ID. So I'm going to say ID equals hello. Then you need to refresh the browser. Then we say document.getElement by ID, and this isn't a plural, it's singular. So you know it's just going to return the single object on its own that represents the element with the ID of hello. So you put in a string, you don't put in anything else, you just put in the ID name that you provided and then hit return. And there it is. And if you wanted the actual object, you'll notice it's actually printed out the HTML. That's just to make it easy for you to read. But if you use the dir function and say document.getElement by ID, and be very, very careful about how you do this because, again, don't forget JavaScript is case sensitive, so the I and the B and the E, for example, need to be in all caps. Otherwise, you'll get an error. And then we need to provide the ID we're looking for, which is, again, hello. So when you do this, it returns the object, and the dir function makes sure that the object is printed out as an object in the console. And so now I can actually see that, yes, this is an object. It's just doing that so that it's nice and easy for us to see and read in the console. But in all actuality, it is an object that it is returning that represents this piece of HTML right here, which is our little hello paragraph. So that's how you get an element by ID. But there are other cases in which you want to use class names, because class names allow you to grab several objects with a specific class name. So we can grab this paragraph and this header 1 via the class name of P class. So let's go ahead and target P class. So I'm going to hit refresh, and then again I'm going to say document.getElements by class name. And again, we have a plural here. Elements means that we're going to get an array return because there could be multiple elements with the same class name. And even if there's only one element with that class name, it will still return an array. So please do note, whenever you see elements, it's guaranteed to return an array. And then we need to provide the class name, which will be P class. And there it is, P class. And those two, there it is. You got the paragraph element, and then you got the header 1 element with the class of P class. And there it is. They are objects resembling that HTML element. And you can take a look at this object and go through it and see what properties and even methods are available, because you also have prototype objects attached. So you can get the class list, children, child nodes, all the rest of it. There's some fantastic methods that you can go through, and you should really take a look at a lot of these because it's going to help you understand the document object model and what's available to you. If you're ever unsure about something, just sit and read, just go through objects, and you'll find all of these little keys and properties and methods available to you. And you can understand things a lot more when you do this. Whenever I'm sort of new to a framework, I'll just sit and read the code that it outputs, and it tells me a lot about that particular framework, and that's a top tip for you. So that's why we have the paragraph and we have the header one, both with the P class. So you can get elements by ID, you can get elements by the class name, and also you can get elements by their tag name. So that's fine, and there are many other things that you could do here. So you've got get elements by ID, class name, by their name, so you could just give them a name reference, by tag name, and also tag name NS. But you're probably going, well, that's fantastic, Lawrence, but what about CSS selectors? Can I use CSS selectors to target DOM elements and return that object just like I would in CSS where I target elements? So let's go ahead and take a look. You can say document.query selector all. You want to go with all because it provides you all the possible selectors and all the support as well. Query selector all. You could just say query selector if you really wanted to, and then provide the string, and the string is going to be the CSS selector. So if you wanted to select the element with the ID of hello, well, if we know CSS, you type in the hash and you say hello, and there is my paragraph element. Now the query selector all, by the way, will guarantee an array that will be returned. It always returns an array, even if you're selecting an element with an ID. So we're saying hash hello. Then also, you could select an element via its class. You use the dot syntax and say p class. And there it is. It's selected both the paragraph and the header one with the class of p class. But also, you could combine them as well. So you have hash hello, and also I'd like to target all the elements with the p class as well. Let's hit return. And there you go. It's now returned the element with the ID of hello and both the elements with the class of p class. Now I'm just going to give you an advanced CSS selector to finish off. So what we can do is we can have the metadata that you can add. So I'm going to say data content, and we're going to say 1, 2, 3. And then also I'm going to have a header, and I'm going to have a span in here. Right, so what I want to do is I want to select this span directly, and I also want to target this element here as well. So these two elements we are going to target. So let's go ahead and refresh the page so everything shows up where it needs to. And then what I'm going to do is say document.query selector all, and I'm going to provide the CSS selector string. The first thing I want to do is target the paragraph element, and I'm going to use the brackets, and I want to say target the element with the attribute, which is data-content. And not only can I check for the attribute, I can also check that the attribute has the value of 1, 2, 3. And again, be very, very careful here. You can see that I'm using single quotes on the outer edge and double quotes in the inner. Very, very important, because if this is single, can you see what happens? That turns into a number, and you've got a string surrounding it by the left and the right. They are two separate strings now. That's not what we want. We want this as one whole string. So we can see by syntax highlighting that this is all red, so it's all a string. So I'm targeting the paragraph element with the attribute data content here, and it must be equal to 1, 2, 3 as its value. Then I'd like to select some more elements, and I want to select the header one. So I can say, right, target the body element, and then I want to target the header one element that's a direct child, and I want to target that header one element via p class, and then I also want to target the span element. Again, this span element must be a direct child of the header one. So the span is a direct child of the header one, and the header one is a direct child of the body. And so this is what we're doing here. So we've actually got a pretty advanced selector. I'm just demonstrating what you can do. So I'm just going to hit return, and you'll notice it's returned both the paragraph with the data content attribute equal to 1, 2, 3, and also the span element, which is here, and it's been directly selected from the body straight down to the header one, and that header one must have the p class on it, and it must also select the span right there. and it returns it like so. And if I was to take away that class, for example, would it still work? The answer is no. So if I hit return, it's only going to give me the paragraph because it's looking at the body, then it's looking at a header 1 with the class of P class. That header 1 no longer has that class, and so it's just going to stop there. So that is using the query selector all, so you can still use CSS selectors to target DOM elements. This is a more efficient way of doing it. It's easier, and the JIT compiler itself is looking through the whole document object model and finding it for you. This is very important. So there is an advanced CSS selector. Obviously, I know that you don't need to do this, body.h1p class span, but I'm giving you a demonstration of how you can use those advanced CSS selectors in JavaScript to target DOM elements, to pull that DOM element out, change the object, modify that in the browser, and away you go. So now that we're introducing JavaScript and working with the DOM, we need to consider where our JavaScript is placed within the overall DOM structure. So it's important to note that HTML block loads. You can think of all these elements as building blocks, and they block load. So this element loads, then this one, then this one, then this one. It goes one by one by one by one, and it starts going through and rendering each element one by one by one by one. But there is a significant problem with, let's say, if I have a large JavaScript file, and I take this large JavaScript file and I put it in the head. Now, this is perfectly fine. You can do this, but there's one significant problem. If this JavaScript file is very large, then it's actually going to have to wait until this JavaScript file is finished loading, and then it's going to have to carry on rendering the page. That means this part here, the bit the user sees, they can see the paragraph, they can see the header 1, for example, is slower for them to view. Whereas if you take the JavaScript file and you put it at the bottom of the body, it means that they get to see these elements block load quicker. But also it does something else. It means that our script is ready to start modifying the HTML because it's block loading. So I know all of these blocks of code, these elements, have loaded, and it also makes sure that there is an object in the document object model, the DOM, for those HTML elements. And therefore, when the document has loaded, when all these elements have finished loading in, I can then start modifying those objects, searching for those objects. Whereas if I had the script in the head, what I'd have to do is I'd have to tell this script to wait for the page to finish loading, and then I can start modifying. But I would rather not do that. I would rather put it in the best position, and I always recommend this now, is put your JavaScript files at the bottom of the body tags. So I'm going to go ahead and save this now, and then I'm going to take a look at the myapp.js file. We now know that the myapp.js file will execute when my header 1s and my paragraphs and all the rest of those objects have been created. So what I'm going to do is, first of all, I'm going to say document.getElement by ID. And I want to get the element with the ID of hello. This is perfectly fine. If I refresh the page, nothing happens. You can log it out to the console if you wish to see that it is working. So I can say console.log and log it out like so, and go ahead and save it. And there is my paragraph element being targeted. Now, as you know, this is just printing it out in fancy print. We may just want the object itself. So instead of using console.log, use console.dir, and dir will tell you to print out an interactive list so that you can actually view it for the object that it actually is. So if I open this up, you'll have the inner HTML and also the inner text properties as well. Now at the moment, inner HTML looks exactly the same as inner text, but I'll show you the difference when we move on to the header 1 element. But for right now, if I actually wanted to change the text within the opening and closing paragraph tags for the hello paragraph here, if I want to change it, I can use either or. I could use inner HTML or I could use inner text. But as I want to change the text specifically, then I'm going to stick with inner text. So I'm just going to take a look at going back and taking a look at the myapp. Now we know that console.log has provided us the information that this is returning an object. When you run this, it returns an object. Now, it's not a new object. it's a reference to the object. What I mean by that is it's just like a memory pointer. It's finding the object. It's not returning a new object. It's the same object, but it's just allowing you to point directly to that object in the document object model. It's just a way to refer it. It's just providing you, in essence, a pointer, like a memory pointer. And when you run this method, it will return an object. And then you can access the inner HTML or the inner text if you wanted to, like so, and you can modify its value. Let's go ahead and do that now. Let's say document.getElementById.hello, and then I can say .inner text. Because don't forget, this part returns an object, and this is accessing that object here. We're accessing the inner text, and we'll set it to new world. So I'm going to go ahead and save that now, and let's hit refresh and see what happens. You'll notice now it doesn't say hello world anymore like it did before. It's saying new world because I've just changed it, and I can change it in the browser again. So instead of actually just reassigning the entire text, don't forget we can also have the plus equals. And I'm going to change that to space order. So what that's going to do is it's going to look at the existing value of the inner text, which is new world. And what we're doing is by that plus sign, we're adding, meaning concatenating these strings together. New world. We're concatenating them together to make one giant string, new world order, and we're assigning it back. So I'm going to say plus equals, and then I'm going to make sure that's a string, hit return. You'll notice it says new world order. I needed to add that space in there, but you can see that it concatenated those strings together. So you don't have to completely replace the value. You can use the existing value and add additional information onto it. Now, on top of that, if we go ahead and let's say copy this in here, what we are doing is we're doing things actually in a very lethargic way for the JIT compiler. What I mean by that is we're doing work unnecessarily. We have got two document.getElementByIDs. Now, when these methods are run, you can think of it like somebody looking through a dictionary for a specific word. Well, we're looking through the entire DOM structure, which is the dictionary, for a specific word, which is the element. And the problem is that we are researching, we're going back over ourselves again. We've already found this element in memory, this object that resembles that element, but then we're doing it again. And that doesn't make a lot of sense. We should only do one search and then start modifying it. So we know that really this is returning a reference to the object. It's just a memory pointer. So what we can do is we can give it a symbol name so we can access it easily. So I'm going to say var p hello equals document.getElementById hello. So now we're searching through our dictionary once, finding the word once, and then we can start to run potentially or change properties or run methods. So for example, now I can say p hello. And this again will produce the exact same value, as you can see. So what I'm doing here is I'm establishing a memory pointer. This is just a reference to the object in the document object structure. It's not returning a new object. It's just allowing us to point to that object in memory. So it's searching through the document once to get the element by the ID of hello, and it's returning a memory pointer, a reference in memory to where that object resides within our document. And then when we refer to p-hello, we're just referring to that object. It's just an easy way to access that object. And now, instead of running it twice, we just run the search once, and it also means that our script will run quicker. Now, you can also modify the text via inner HTML, but why is there two different versions? Well, inner text is just for the text that's presented to the user within the element. It includes no HTML whatsoever. So let's go ahead and clarify this. If I wanted to, let's say, add in a HTML element, we would say, let's say span. And so we're adding in some HTML here, and I want to say hello world. So we've got this span element. I'm going to save it and hit refresh. Except it isn't a span element. What's happened is it's escaped these special characters, meaning it doesn't actually get recognized by the HTML rendering engine. Instead, what it's doing is it's actually just printing it out as standard text, inner text. But inner HTML is a little bit different. It will allow us to add in HTML. So let's change this from inner text to inner HTML and make sure HTML is in all capitals. So I'm going to go ahead and save this now and hit refresh, and you'll notice it says New World Order, Hello World. And if I take a look at the elements, I can see the paragraph, New World Order, and then I can see the span, Hello World. So instead of actually escaping the angle, brackets, and so forth and special characters so HTML wouldn't render it, inner HTML doesn't do that. Inner HTML will allow you to place HTML content or create HTML content within the actual element itself. So within HTML, it's a little bit different to inner text in the fact that you can actually add in more HTML. Also, if you take a look at this, if I say dir and I point to this object, p-hello, if I take a look at my paragraph element with the ID of hello, you'll notice that we have with the inner HTML, I can see the HTML, whereas inner text, I cannot see the HTML. There's no span tags there. It just gives me the text that is presented visibly to the user. So that's why we have the differences. Inner text and inner HTML allow you to do two different things. Now, also, you may have noticed that if we scroll down, and again, just read through these things because there's lots and lots of things here, you have something called outer HTML and outer text. So the outer text, again, is just presenting the text that's visible to the user. But outer HTML actually allows us to take a look at the element itself, the paragraph element here. It lets us look at the outer HTML, not just the inner HTML. So any HTML inside of it, but outer HTML lets us look at everything outside as well, the elements itself and what's inside of it as well. So now I can actually change this from being a paragraph. Let's take a look at this. I'm going to take a look at myapp.js and I'm going to change this. So here is my outer HTML. It's a paragraph element. And what I'm going to do is just copy that out real quick. And I'm going to say p-hello.outer HTML. And then we're going to set it equal to a new outer HTML string. And be very, very careful because if you use double quotes, we've got an ID attribute that uses the double quotes and it escapes out of the string. So this executes as JavaScript. When working with outer HTML, always go with those single quotes and even with inner HTML as well. So now what I want to do is paste this in, and now my ID attribute with the double quotes will not escape out of the single quotes. And I need to just make sure this is valid. And I'm going to change it from a paragraph to, let's say, a header 2 element. So I'm going to save this now. So it's going to replace the outer HTML with header 2 tags. So I'm going to save that and I'm going to hit refresh. And we've got the New World Order, Hello World, in the header 2. So here's header 2, and there also is my span. So that is how to modify the outer HTML. You also have outer text as well if you wanted to. And that would actually, if we say outer text, again, notice that we are using HTML here, but this syntax will actually be escaped, meaning it won't be recognized by the HTML renderer. So if I go ahead and save this now and hit refresh, you'll notice that it turned it into simple plain text. And it's not even an element anymore. It's just a standard text within a HTML file, which you can do, but obviously that's not recommended. So be very careful when using outer text. Because if you use outer text, then you're going to strip away the tags that contain the text, and it's actually going to turn it into just raw text in the HTML. So I'm going to change that back to outer HTML, and I'm going to go ahead and hit refresh. So there we go. That is how you modify the contents of a particular element. Now, last but not least, what would you do, for example, if I wanted to select this span here? Well, I could do document.query selector all, and I'm going to use a CSS selector string to target this. So I'm going to say, right, target the header 1 element that has a span element within it. So there is my memory pointer. Now you know that query selector all has the option of returning multiple elements. So query selector all, even though it may only be able to target one element, it's still going to return an array. And I'm again going to create a nice little pointer to it. So I'm going to say span h1, and I'm going to set that equal to the memory pointer that's returned, document.querySelector all. So I'm going to go ahead and save that now, and we'll hit refresh. And if you go to the console, you can say, right, dir, and we want to log out span h1. And when I hit return, it returns an array. Now be very, very careful here because the array itself doesn't have an inner HTML or outer HTML. Well, this object here, the object at the index of 0 is the span element object. So if you were to say document.querySelectorAll dot inner text or inner HTML, it would error because you're pointing, this returns to this array. So if I was to say square brackets 0, now it's pointing to the 0 element. So document.querySelectorAll is like opening up that dictionary. We're looking for a specific word, a specific element, this span element, and it's going to return an array like so. And then we're accessing that array and looking at the element at the 0 index, which is the span. And then you can start to modify it. So I can say span header 1, and then of course I can say dot inner HTML, and we'll just set that equal to new text. And let's go ahead and save that now and then hit refresh. And you'll see new text here because we targeted this span within the header 1. If you didn't do that, then basically you won't have anything happen. What you're actually doing is creating a new property on the array, which is bad. We don't want that. So you need to say span header 1, 0. Then you're saying inner HTML like so. So you can either put it here or here. Hit refresh, and there we go, new text here. So be very, very careful when working with, for example, get elements by class name, get elements by tag name elements, or query selector all, always return an array, and you need to make sure that you're targeting the actual DOM object itself rather than the array of the returned references, the return memory pointers. And again, this is so important. When I say document.getElements by tag name, and I get all the paragraph elements, for example, you are in essence getting memory pointers. And these memory pointers are just a reference to the objects in the document object model. They're not new objects. They are the same objects. It's just pointing to, it's just referencing those objects in your overall document object model. So keep going through it, modify, play around, and experiment with the query selector all, with the get element by ID, get element by tag name, get element by class names, and start modifying these elements and see what you can do. Okay, so the goal of this lecture is to be able to style this header 1 element. Now, currently at the moment, it's only got the default styles applied to it. I would like to add maybe some style to it by changing the font face, maybe adding a background color, and so forth. But how do we actually do this via JavaScript? We know how to do it via CSS, but in a way, JavaScript also has the same sort of syntax as CSS. In CSS, if we add in the style tags, for example, you target it via CSS selector, which we can do. You can say, right, target the header 1 element, for example, or you could give this an ID of style, and we can target it like so. And then also you have the braces, and this defines an object. Even in CSS, this is an object because you have CSS properties and CSS values. They're objects. You can have the background color. This could be something like blue, or you could go one of the default colors, or you could provide your own custom color. You can change the font color as well if you really wish to maybe white or something like that. And then also you have a whole host of other things you can do, but you can see that the syntax itself does look like an object. It does have properties, and it does also have values as well, a key and a value pair. So let's go ahead and do this in JavaScript. So I want to go to myapp.js, and then I'm going to say document.getElementById, and we gave it the ID of style. So let's go ahead and grab that element. So now that we have the object, we also need to refer to it because I don't want to have to keep researching through the document again. It's a very lethargic task. We don't want to keep doing that. So I'm going to create a variable called EL, short for element. And then what I'm going to do is I'm going to target the element, and then I'm going to take a look at the style property, which is actually an object. I can take a look at the EL. There's my header 1. And if I type in dir and say, look, show me the actual object here in the console, if I scroll down, you'll notice that eventually we will have the style object. And in the style object, you'll be able to see you have all of these properties available to you so that you can start to modify all of the available CSS properties. And you can go through all these CSS properties. You can find out all sorts of potentially new properties that have come out, object.fit, orphans, all sorts of properties that you can look at and modify under CSS. They're all listed here. And again, be very careful here because in CSS, we didn't have to put the quotation marks, but in JavaScript, you do because it is a string. We're not looking for a variable called blue or a symbol called blue. We're looking for the string blue, and that will be assigned to the background color. And then maybe I want to change the color of the font. So I'm going to say el.style.color, access the color property and assign the color white. Again, making sure it's a string. If it's a number, it's a number. And also, let's say that I want to set the width, just to demonstrate what we need to do. So el.style.width. And you're probably going, well, what could I do? A number here? Well, yes, you can put in a number. That may treat it as a pixel value. So let's go ahead and save that now and hit refresh. And you'll notice that it didn't actually change it. So instead of saying 200, you need to actually provide the measurement. That makes it a string. So that's very important. You need to make sure that you append the actual measurement. So that's pixels, EMs, points, or whatever else you want. You know, you got millimeters, centimeters, all the rest of it. So I'm going to say 200 pixels width. And that way it will change it to 200 pixels width. So be very careful again when assigning values here when it comes to widths, heights. Make sure you include the measurement and make sure that it is in fact a string. And likewise with your colors here. Also you have RGBA and all the rest of it, all the other color modes that you have. Again, all need to go as strings. And that's it. So that is actually how you style an element. You target the element, first of all, you get that memory pointer, then we can target the element's style property or object. That object contains many properties which resemble CSS properties, and then we assign values as you would assign values with CSS properties. That's how we style an element. And what did this actually do? Well, whenever you modify the style, you're actually modifying the style attribute. The JavaScript works with the style attribute. You can see background, blue, color, white, width, 200 pixels. This all came from the modifications that I did in JavaScript. And so that is where we get the modifications of styles. Now this is one way to style an element, but I'm just going to comment all of this out so it will in effect nullify the code. It's just not going to be interpreted. And you can see that we go back to the average styling. Now typing el style dot is going to take quite a while. So what we can do is instead of using that, we can say el.style.styleText.css text, and it requires a text string, and you can just provide a simple text string that you can modify the style. So we can say background is going to be blue, color, and the width. So I've just provided a simple string that will style the element. So hit refresh, and there it is. I can just do it all in one go with this CSS text. And let's say we have some CSS already applied. Well, then what you could do is you could take a look at using plus equals. So now this string here is going to be added onto this string here, and then we're going to assign it back to the CSS text. So we're not going to erase any styles. If you just use equals, this string will replace this string, but plus equals, they will be concatenated together and assigned. So in this case, let's just set the height to be 200 pixels as well. So I'm going to do that, and we're going to save this now and hit refresh. And it will also add the height. If I get rid of the plus equals, you'll notice it just simply changes the string. It gets rid of all that, and it only applies the height. You can see if I hover over it, it has the height of 200 pixels, but it hasn't got the coloring and the style. So let's add that coloring and style in there. Let's change that to 100 pixels height. And there we are. We have our nice little styling, and that's both ways that you can style your element. You can do it individually, or you could do it this way. And it's better off to do it with CSS text, because if you have multiple styles, what happens is the browser renders. So every time you, let's say, change a style property and change to white, it re-renders the element. So we're triggering 3 re-renders here, 1, 2, and 3. So it's saying, oh, change property, render, change a property, render, change a property, render. That makes it slow at rendering, and it can make your page not as quick. I know that it's not a big deal here, but trust me, later on down the line with proper web pages, it makes a big difference. So the idea is use CSS text, you do it all in one go, and then it renders when you apply that CSS text, all in one block. And you can see that basically CSS text is just applying to the style attribute. Notice the style attribute, we didn't have that here. There's no style attribute on this header 1, but now there is the style attribute, and that's what JavaScript uses. It uses the style attribute and it applies styles to our element. And that is how you style elements in JavaScript. Now finally, there may be something else that you may want to do. So let's go ahead and save this now and hit refresh. And then what I'd like to do is apply some styles. And these styles are going to be computed styles. So I'm going to target the element with the ID of style. And then I'm going to apply a background color of blue, the font color of white, and also I'd like to apply the width of 100 pixels and a height of 100 pixels. So now that we've gone ahead and done that, I'm going to save this and hit refresh. And there it is. I have these predefined styles here. And what I'd like to do in JavaScript is be able to access those predefined or computed styles. How do I do this? To do this, we have the getComputedStyle function, and what this function requires is the object that is the advocate for our element, which we know we are targeting, we are referencing this object via the EL symbol. So the EL symbol is like a name tag for a person. It's just pointing to that object in the document structure. It grabs that object and then it gets the computed styles on that particular object or element. And just before I refresh, you can see that when you select something, you also have this little window right here. So you can select the element, which I've selected it there, header 1, and you can see here the computed styles. You can take a look at all of the default options. Now don't forget, the browser does give some default styling to a standard set of elements. For example, div elements are displayed as block level elements, and header 1s can be displayed as inline blocks, or again block level elements. It's all defaulted, and you can see that by default, for example, I haven't set the display, but it is a block level element. This is set by default by the browser's preferences. And if I take a look at my index.html, I didn't set the display property here. So you have what's called the computed properties. The computed properties are the CSS properties that I've applied to it, and also the default properties as well. Now at the moment, if I just refresh, nothing will happen because it is running and it is working, but you need to log it out to the console. So it will grab this element, it will get the computed styles, it will return an object with all the computed styles, and it will log it out to the console window. And here it is, CSS style declaration. We have the object in here, and if you click on it, you'll see all of these CSS properties. And it also shows you the defaults as well, such as margin and the position and all the rest of it. So you have some default computed values applied automatically to this particular element. Now the computed properties are computed properties. They are not the actual style properties that you're applying via JavaScript. JavaScript applies styles, for example, via, let's just add one style in here. The background color is going to be yellow. So I'm setting the background color in CSS. That's not computed. That is actually via the style attribute. Whenever you try to modify styles in JavaScript, it's done via the style attribute. It's not the computed properties. The computed properties come from your CSS files and also from the browser's defaults. But when you want to modify the styles through JavaScript, you'll find it uses the style attribute. Now, there's one more important thing. Sometimes people, and I have also assumed this, that I wanted to override the style attribute. So we have the background blue here in the computed, But here we have it set via JavaScript. Can we override the JavaScript? Because at the moment, this style attribute is taking precedence over my computer's styles. The answer is yes, you can. What you do is you use the exclamation mark important. And when you use exclamation mark important, it makes this value more important. And thus it will actually now, even though we have the background yellow via the style attribute, this background property is more important. Now be very careful, because if you do this on the style attribute and you say, right, I want that value to be even more important, then there's no way you can override this. You literally, once you have background yellow, this is really, really important. You can't override it at that point. But if you don't have that, then you can just use important on your computed CSS properties and it will override. Events are simply when something happens in our application and we want to run a set of instructions. So what could this be? Well, for example, when the user clicks a mouse button, or when the user presses a key, or when the user touches their screen. These are all events that can trigger subroutines, a set of instructions or functions that run in our program. We need this because we now have graphical user interfaces. A lot like with your favorite graphics editor, you have the ability to have the layers panel and you want to add a new layer. Well, that button that you're clicking on has an event listener. It's listening out for an event, particularly a mouse event where you click on that particular button and then it runs a subroutine to add the layer to your current document. This is what we're talking about with events, and with graphical user interfaces with buttons and input text fields, select drop-downs. We need to be able to listen out for events, and then when that event occurs, we have a subroutine, a set of instructions that we want to run, and we want to be able to define a subroutine to handle the action. So let's take a look at the typical type of element that you would want to add events to in HTML, which is form fields. The user interacts with form fields and your application will respond when they change the value. And what you can do with form fields is provide a name to either a set of form fields or a form field itself. And JavaScript allows us via itself to use the get elements by name. And that allows us to select elements or form fields via the name attribute. And in here we can provide the name cars. And you'll notice it returns an array because we have elements, which means plural. That means it will return an array, and on the 0 index we have the object that resembles the select drop down with the name of cars. So if you take a look at a standard DOM object, you'll find that if you scroll down, you have all of these on symbol names, on abort, on aux click, and you have all sorts of things on blur, and you have the standard on click, and you also have on DBL click. That stands for double click. So you have all of these events, and all of these event names begin with the word on. So these are all the possible events that you can attach to this one DOM element. And I just want to choose one of these. Now typically you need to look at what this element would typically entail. Well, I can use my mouse on this, and I can also actually use the keyboard. I can tab onto it, and I can also use the down arrow and also hit return to select a value. So you can actually have mouse events and keyboard events on this particular element. So let's take a look at a real simple one, such as on click. I have my on click event. Now, firstly, I want to show you how to do this straight in HTML. So I'm going to say on click right here in HTML on this select element. And then I'm going to set it equal. Now, whatever is in between these quotation marks will be executed as JavaScript. So I can say console.log, and then I'll say you clicked me. Now, one very important thing, we are using double quotes. If you use double quotes here, you could end up escaping out of these quotation marks. And you can see this has just messed everything up. So be very, very careful. Use single quotes and double quotes and vice versa. Don't use the same quote types. So well, now that we've gone ahead and done this, let's hit refresh and let's click on this select. And you'll notice it ran console.log, you click me. So you can add inline events. Why is this a bad idea and why did developers shun it? The reason why is because you want your application logic ideally in a separate file, not in the same file as your markup and presentational code. So instead of doing it this way, I'm going to go to the My App and I'm going to create a select symbol, and then I'm going to say search the document, and I want to search by name, so get all the elements by the name of cars, and don't forget this returns an array, so we want to access the element on the 0 index of the array, and then what I want to do is I want to target that object. And when you do this, if I just go ahead and save this and just quickly hit refresh, I can take a look at the select DOM object, and in here you have onClick. So I can just target this symbol name onClick, and you can see we do have a function, and in this function we're actually just doing the console.log. You can see it here. That's what this is doing here. So if I do this select.onClick equals, what's going to happen is this assignment operator is going to take whatever is in onClick right here, this function that was provided by the HTML file, and it's actually going to overwrite it with this function here. So this means that I can only have one subroutine for the click event on this object. And I'll show you how you can have multiple subroutines for this object with the click event in just a second. Now, what I'd also like to show you is that all callback functions, this is what they're specifically called. We call them callback functions. And the reason why we do is because it identifies the function as a callback. It identifies it as a subroutine that's associated with an event. So that's the special name for them. And you'll notice that we have an event parameter. Now, you don't have to provide this event parameter. It's actually optional. You don't have to provide it at all. But, however, I do. And the reason why is because it populates, meaning it assigns to this parameter, this symbol name, an event object. And that event object gives us details and information about the event that triggered this callback function. So let's go ahead and take a look at this when we log it out to the console. So I'm going to say console.log, and then I'm going to log out the event object. Let's take a look at what JavaScript actually did here. So if I take a look at this onClick symbol, if I keep going down, onClick, here we have my function that I've assigned here. It has now deleted the function that it generated from HTML. So that's now been overwritten. We can only have one inline callback function. Second of all, we have this function and it's automatically being given an object because it's a callback function. It's associated with an event. That event data will be logged out to the console when this event triggers. So if I click, it triggers the event, it executes this execution context, and it logs out whatever event is pointing to. Some people like just saying E or EVT, which is short for event. It doesn't matter, you just need to give it a name so that you can reference the object. And in this particular object, it gives you all sorts of information. Now, depending on whether it's a mouse event or a keyboard event or a touch event, you will get different information in this event object. But JavaScript does this for you automatically, and it's actually kind of nice. It tells us information about, for example, let's say if it's a touch or click event, it tells me where they've touched and clicked on the page relative to the element, relative to the screen, and so forth. And it tells me all this information. And also, you have the ability to have a look at the path. So you can see it's gone from the select, and then it bubbles up. This is what bubbles means. It means the event travels upwards, bubbles true. And this is where you get this path from. You got the select, and then it bubbles up to the body, and then it bubbles up to the HTML, and then it bubbles up to the document. You know, when you blow a bubble, what happens is your bubble floats upwards. Well, that's what's happening here. In essence, this event is flowing upwards. It's going from the select and bubbles up and bubbles up and bubbles up to the window object. And that's what's happening. And likewise, I can also see the source element, the element that actually triggered the event itself. And as you can see, source element is equal to that select DOM element. So without further ado, that is the inline events, and all callback events pass the event object to the first parameter, and that will give you information and details about the event itself. Now here we're using inline callbacks, which I can only have one. I can either have this onClick or I could have this onClick in the HTML, but I only have one callback function being executed. I would actually like multiple click events. So what you can do is you can target your select dropdown and use the add event listener. This is not an inline event. You won't be able to see this function in the object itself. It's going to be defined by the JIT compiler. Now, one benefit to this is, again, we can have multiple events. So I can have another click event. They're probably going to me, Lawrence, this is not on click here. It's just click. Well, when we have our particular select drop-down object, which I can take a look at the source element here, you take a look at the source element and you'll take a look at all of the ons. You've got on before copy, on click, on close, and so forth. Now, this is just namespace. So all these methods, in effect, are grouped in a namespace of on. But we don't need this anymore because we're adding the event listener. So if you want to say, for example, on click, just get rid of on. Or if it's on drag, again, just get rid of the on there and just type in the event name itself. So now let's go ahead and add in a callback function. And this is going to log out something different. So I'm going to say console.log and then log out, clicked by add event listener. And also don't forget you are past the event object. Just like inline gets the event object, so does this. All callback functions that will execute upon a particular user interaction or change within the document, these callback functions will always receive an event object that gives you details about that information. So I could also log out that object as well if I really wanted to, but again, I just want to log this out to the console. So hit refresh, and when I click, you'll notice we get the event object from the inline onClick function. And then also we have this callback function, which logs clicked by add event listener. And you'll see here it says click by add event listener, and you can add in multiple callbacks and just keep going with this. So this one will be number 2. Hit refresh. Now when I click the inline, then you also have this event and also this event here, which is how we do things. Now, if you want to remove an event listener, you would target the particular element in question, and then you would say remove event listener, and then type in the event name that you want to remove. So I want to remove something from the click event, and then you need to provide the symbol name that references the function, the subroutine, the callback function that you want to remove. Unfortunately, these functions are anonymous, so be very careful when you add event listeners. If you are not going to remove that callback function doesn't need a name. But currently, there's no way for us to reference this in memory. We always need symbol names, memory pointers to reference something in memory. Well, in this case, it's anonymous. I can't do it because there's no symbol name. So in this case, what I need to do is just go ahead and delete that because it's just adding more complication to this. I need to define the function with a name. So I'm going to say click callback. And then I'm going to use that symbol name to reference this subroutine. And I'm going to add it like so. I'm going to add it by its reference name here. Then what I'm going to do is I'm going to remove that event listener. So let's first of all see if this works. So I'm going to hit refresh. I click. You'll see it says clicked by add event listener. So we have in fact attached this subroutine to the click event on this select element. And then what I want to do is target that select element, remove event listener from that element. It's under the click event. And then we need to provide the symbol name. The symbol name is the memory pointer to those sets of instructions, which is going to be click callback. So we're adding it and then we're removing it. Let's see if that works. And yes, it did. It added it and then it removed it. And by the time I've clicked it, it's already been removed. That's how you add and remove and use the add event listener method. So to add inline events, you must target the element itself, and then you have to choose the symbol name that is associated with the event that you'd like on click on drag. You can take a look at those events and see which events match up to the element that you're using. And then you can add in a callback function. All callback functions receive the event object automatically. This symbol name is automatically referencing an event object that's created by the JIT compiler. And then also you can add event listeners via the JIT compiler. It's managed in the JIT compiler, and remove event listeners. And that means that you can add multiple callback functions to a single event. And you can also have inline events right here in the DOM. As of right now, we currently have no visible DOM elements in our current document object model. Now what I could do is, let's say, add in a div element and style it with CSS. But what I want to do is add this div element in via JavaScript. I want it to be dynamically inserted into the page. So how do we do this? Well, I'm going to save this now, and I'm going to take a look at my app.js file. I'm going to create a variable called element, and it's going to be equal to document.create element, and you need to tell it what type of element you want to create. So in this case, it could be a div element, it could be a video element, it could be an audio element, it could be any type of element that you can create within HTML. So I'm going to create the div element, and then what I'm going to do is I now need to attach it, because if I save this now and hit refresh in the browser, and I take a look at my console, if I take a look at my element, you'll notice it does print out the div syntax. And if you wanted to take a look at the object representation of it in JavaScript, this object resembles this element in the HTML. So at the moment, this element is not placed inside of the document object model. We have just created this object, but it's not been placed inside of the document. But as of right now, we can treat it like a regular DOM object. For example, I can target the object that's been created, and I can take a look at its style. I can modify its CSS styles via CSS text, and I can give it a few different things. So we've got the width as, for example, 200 pixels. Then you've got the height, which is going to be 200 pixels. And then also you can have the background color, and let's set that to blue. Then also we need to define where we want to add in. Then also you can define other things such as on click, and then we're going to run a function, and we'll get an alert dialog box that opens up, and we'll say hello. And once we've done this, we then need to place it within the document. So we need to decide where we're going to place it. Well, I want to place it within the body. I want to append it down here to the body, so that we can actually see it being rendered in the browser. So what I want to do is I want to take a look at the myapp.js file, and then I want to take a look at the document.body. This object right here, the body object, targets this body element here, and we can append the child to it. So I can say .append child. So we use the append child method, and then you need to pass in what child object that you want to append to the body. So in this case, it's going to be element, which is this DOM object here. And I'm going to save that and hit refresh. In here, you have the div element that we created dynamically with the CSS text. And also we have an on-click event, and when we click on it, we get an alert dialog box with the message. And if you take a look at this, all we did was we took it and we appended it to the document so that we can actually see it. It's actually placed within the DOM structure. So you have the document object, which resembles the entire document, and then you have the window, which represents the entire window that we currently reside in. And here it is. So it is now an object within our document object model. And again, you can take a look at the actual object itself. So all we did was we took an object and we placed it inside of an object, and you'll find it in there. You can go down to .body, for example, and take a look at it, and it will be actually dynamically inserted into the document. Now let's very quickly just create a few elements just so that we can take a look at this. So we can have, let's say, a div element, and we're going to add some style to this. Now let's also change this element here as well to have a height of 20 pixels, because I kind of want this all to fit in this little window here. So I'm going to take a look at the index again, and I also am going to add a ID onto it. So we've got the ID, and that's going to be yellow. And then let's also have a green div element as well. And what I'd like to do is just pop this in here. We have the green element, and that's going to have a background color of green. So I'm going to go ahead and save this now and hit refresh. So we've got our 3 div elements. We've got the yellow one, the green one, which I have inserted manually, and then we also have our appended one. And you'll notice with the appended one, it comes actually below the script tags. So we have the script tags here, and then appending is right at the bottom. And what append child does is, as the name suggests, append child, is it takes this object and it appends it as a child element. So it takes the div element that we've created, let's say out here, and then it appends it into the body. But what happens when you want to place something specifically within the document? For example, insert before and insert after. So maybe I don't want to append it as a child element. Maybe what I want to do is actually place it specifically in between, let's say, these 2 div elements. How do I actually go about accomplishing this? Well, let's take a look at, first of all, targeting the ID of the element. So what I want to do is I want to take a look at just commenting this out. That's appending. So what I want to do now is I want to take a look at what element I want to target. I'd like to actually target this yellow element, because when we do append child, it appends the div right at the bottom. Let's say I want the div to be right at the top. How do I do that? Well, I need to target the parent node or element. You can think of all these elements here as nodes. Nodes are just symbolic. It just means something small that makes up a larger structure, like leaves on a tree. Each leaf is a node, and those nodes are attached to the tree, and it's all a big node structure. It's got structure to it. And likewise, we've got this here. We've got the body element, then we've got the divs and so forth. So whenever you hear node, it's just like symbolic of a smaller system. Like you can have lots of little computers that make up a larger server and a big server farm. And each one of those computers is a node, and then you have the overall structure. So what we have is these nodes here for these DOM elements. And what I'd like to do is target this DOM element and then insert before. So what I want to do now is I want to take a look at the target. So I'm going to say var target equals, and then I want to target the object in the document. So I'm going to say document.get element by ID, and we want to get the element of yellow, which I'm targeting this div element here. Then what we need to do is target the parent node. I need to target this node, and then I need to say where I want to place my div element in this node. So let's take a look at that. I'm going to say document.body. So I'm targeting the parent node. Then I'm going to say insert before, and then you need to first of all provide the element that you want to insert, which we know that we have created this object and we can point to it via its symbol name called element. And then once I've done that, I then need to say which element I want to insert my newly created element before. So I'm going to say target. So I'm going to target that yellow div and I'm going to insert my element before it. So it's going to come right at the top of the body. Let's save this now and hit refresh, and sure enough, it does. We targeted the parent node or element, then we targeted the yellow div element, and then what we said is take the blue div element. So by using append child and insert before, you are able to place this dynamically created element anywhere within your document. So here it is, the final project where we start to combine multiple pieces of information. And what I'd like to do now is I'd like to take a look at what we want to do in this project. Well, first of all, we have a few select drop-downs. We have these 3 select drop-downs: background, width, and height. And here they are. Background has a selection of background colors. Then you can set the width, and then also you can set the height. But also, what we have here is a div element. And this div element is currently visible with the standard width of 300 pixels and a height of 300 pixels and the background color of blue. But we want to modify it. So when we hit the set button, this button right here, we want to grab all of the input values that the user has provided. For example, set the height to 300 pixels, but the width to 100 pixels and the background color to green. When we hit set, I want to modify this div element so that we set the background color, we set the width, and we set the height of this div. Hence the set button. All of these have IDs. So we have the select drop down with the ID of background, width, and height. That's the CSS property name that we want to modify. And then also we have the values to set that CSS property. And then also you have that set button, which when they click on it, I want to set those values, those stylings on my modify div. So that's what we're going to do here. Now I want to take a look at the myapp.js file, and I want to actually start programming this up. So when I click the set button, I want it to run a function. So I'm going to create a function called set, and we are going to provide some instructions. But for right now, I just want to create an alert dialog box that says click. So once this has happened, what I'd like to do is simply create an event listener, and I want to attach it to that element. So we're going to target the button with the ID of set. So I'm going to say document.getElementById. So we're nice and easy, and we want to target the element with the ID of set. And then I want to add an event listener, and the event listener is going to be click. So this isn't an inline event, it is actually going to be an event listener managed by the DOM. So I can say document.getElementById set add event listener. When they click on it, we're going to run the set subroutine. So that is what we currently have here. But what I'd like to do now is target all of my select dropdowns, and I'm going to add the name attribute so I can do this easily and call it CSS property. So now I can target all of my select dropdowns via the name attribute. And how do I do that? Well, first of all, we need to create a symbol so we can reference the array that's returned. So I'm going to say create the symbol name elements. I'm going to say document.get elements, and again, if we have the S in here plural, we're going to get an array by name. Get elements by name. And what we want to do is we want to type in the name that we want to get. So that's CSS property. Get all the elements by the name of CSS property, and then let's just log that out to the console so that we can see this. So I'm going to say elements. So I'm using that symbol name to find out the returned array or target the returned array. And I'm going to hit refresh and hit the button. So you'll notice now it went out, it fetched all the elements, all my select drop downs, and we logged that out to the console. Here it is logged out to the console. We have the length of 3, 0, 1, 2, and there's 3 elements there. So that's why the length of 3 is there. 0 is the background, then 1 is the width, and then finally we have the height. So we've selected all of our drop downs. Lovely. Now what we need is a for loop, because what I want to iterate, meaning go one by one by one, each one, go through each one and grab its value. So I'm going to say for loop. Then I'm going to create another symbol name for the index, and I'm going to use let because it respects the scope of the conditional, and that is equal to 0. Then what we want to do is we want to keep this for loop live whilst index is less than the length of the array. So I'm going to say index is less than, and then we target the elements array, this array here, and we take a look at the length property like so. So whilst index is less than the length value here, then we're going to keep iterating through. And of course we need the iteration part, which is adding 1, so index plus plus. So we add 1 every time we execute this execution context. So now what I want to do is say console.log, and then let's take a look at the index. So I'm going to go ahead and save that, hit set. So you can see what happens is index starts at 0. So we start at 0. That's the first element in the array. Then we go to 1. Then we go to 2. And that's it. It stops after that because when index hits 2, it goes to 3 on the next run. And that means index is 3 and element's length is also 3. So 3 is not less than 3. So that's a false statement. It doesn't carry on after that point. So that's perfect. That's exactly what we want. And so now we have the index. What do we want to do to grab the elements out of the array? Well, I'm going to let you think about that, but again, the way we do it is we target the array. First of all, the array contains the data. Right here, this symbol name, it has the array pointer, and we need to look inside of that array and grab out the elements on each index. And don't forget, we have the computed member access because we need to actually use a symbol name as well. We're going to use this index here, and the index is going to be 0, 1, or 2. That's what we have here with the index. So now when I hit refresh, it's going to, when I hit set, grab all the elements, create the for loop, loop through each index, and there you go, you got the 3, each one. 1 is the background, 2, and then 3, or 0, 1, 2. Perfect. That's what we wanted, but we want the value ideally. So what do we do to do that? Well, we say dot value. All input fields or form fields like text input, text area, you've got select drop downs, you've got multiple selects, you've got radio buttons, checkboxes, ranges, all of those type of elements that can go in a form element have the value property, and the value property contains its value. As you can see here with these options, you've got the value attribute here that provides the value to the value property in the object that resembles those HTML elements. So if I hit refresh now and hit set, we go through and you can see we've got green 100 pixels, 100 pixels, green 100 pixels, and it's there twice, don't forget. So it has logged out each value. If I change the value, let's say green 100 and 300, set, you can see it says green 100, 300. It's only because the console doesn't like printing out more than it needs to. So there we go. It is now grabbing the values, but our values are just the values. We also need the CSS property name. So let's do another console.log and try to get the CSS property name. And as you know, the ID defines the CSS property name. So let's go ahead and get that attribute's value. So for example, we take a look at each select dropdown again. That's what we need to do. And what we need to do is say get attribute. And we want to get the ID attribute like so, and hit refresh and hit set. Then you've got background green. That's from the first iteration. Then we have width and also the value, 100 pixels. That's on the second iteration. Then you've also got height and the value of that select dropdown on the third iteration, 0, 1, 2. Perfect. We've got the CSS property name. So I'm going to say let, again, because it respects the scope. CSS property equals, grab that element and then get its ID. Then also, I'm going to create the second variable called CSS value equals, and we grab the element's value like so. And again, we're just going to tidy up this code, make sure it's accurate and correct. And you can even log this out to make sure that it's working. So console.log, we have the CSS property, and we also have the CSS value. And you can log that out, hit set. There you go, background green, width 100 pixels, height. Perfect. We've now logged that out to the console. Everything is working fine. We're iterating over each one. We're getting the value and we're also getting the property name. Now it's time to take a look at this div element here. This div element, which is with the ID of modify, is in fact going to be modified. We want to change its properties. So I'm going to say, right, take a look at myapp.js and we want to say document.getElement by ID, and it has the ID of modify. So we're targeting this div element, and let's go ahead and create a symbol name so we can reference it later. Let div, and there is the div element. And what we want to do is take a look at the div element, and what do we want to access? We want to access the style object, and then we need the CSS property. But don't forget, the CSS property is a variable. That's how we're targeting the property name, because we're getting the attribute and it's returning that value. So that'll either be background, width, or height. It's going to return that string here. So I'm going to copy that. And what do we need to use? Can we use this member access or this member access? Well, it's this member access, the computed member access, because it needs to go and find this symbol name in memory and pull out the value. And then once we have this CSS property, we can assign this CSS value, which is here. The CSS value will be, for example, the drop down for this one will be green, yellow, red, and so forth. So that's all we're doing. Let's go ahead and save this now and hit refresh. And I'll go through this code so that we fully understand it. Hit set, and now you'll notice it's changed this div element to a background color of green and the width and the height 100 pixels. I can go ahead and start changing it again and hit set, and you'll get a different style. So what have we done here? First of all, we've targeted the button. Then we've added an event listener called click. When they click on it, it runs the set subroutine. Then we're creating a variable that stores the array. It stores the array of all of these select dropdowns. We're getting all the elements by the name of CSS property, all of these 3 select dropdowns. Then what we're doing is we're iterating through that array to target each individual select dropdown. We can't target all of them in one go. You have to select each individual select dropdown for each individual CSS property and value we want to modify. Then we go and take a look at each element in the array and we get its ID attribute. And that is the name of the CSS property we modify. Then also we have the CSS value, which again we target each select dropdown and then we pull out its value. Then we grab the div element, and then once we've targeted our modified div element, we target the style object associated with the div element, and then we can start to modify the CSS property. Now this is either going to be, let's say, background. This will return the string background, and we can access that particular property like so, but we have to use the computer member access because we are using a symbol name, and there is some computation involved in that before we actually get the value out. Then we set it equal to the value that we have here. That will, for example, be for the background. It'll be green, yellow, or red. We grab that value, we assign it. And then you do the same thing for the others. You have height, and then you have different values for the height and the width and so forth. And everything is fine, and it works perfectly. And the nice thing about this is you can start to play around with HTML, so you don't have to have background necessarily. You could have border, and you can set the value to 2 pixels green or 2 pixels yellow, something like that. And you could have different styles applied to this just by changing the markup code. So your code here is dynamic. Now, one final thing is when you develop programs, you should always at the beginning look at and go through with a fine-tooth comb any wasted processes. So for example, do we really need to, every time we click this button, target all of the select drop downs? That's just like me opening up a dictionary, finding all the words that I need or the elements that I need, and then redoing it every time I click the button. No, I don't. I only need to do that once. So you should actually just do it once instead of every time I click the button. Likewise, do I need to, for example, target the div element every for loop? Because don't forget, this is again looking at the entire document object model, looking through those objects and trying to find the element with the ID of modify. Not a smart idea. So we don't really want to keep on having to search through things like that. So I'm just going to go ahead and provide all that information before we actually run the subroutine. So let's go ahead and save it and then hit refresh and then set. It's now a lot quicker because we're basically preparing stuff. And whenever you come to programming, prepare stuff before. And that's why chefs can cook so much, and a family meal takes a lot longer, because when you're doing the family meal, you're preparing stuff there and then. But chefs, they go in the morning and they prepare all their ingredients, they prepare everything, and that makes it much quicker when they're cooking. And you can think of the subroutine as the cook and this stuff as your ingredients, your recipe list. You're getting everything ready so that you can use this data later on, and you don't have to keep on searching through or prep data. Even though it's insanely fast, it's still going to be faster if you write your code properly. And that's it. Hi guys, I hope you're really enjoying the Avelx content, and I always want to go above and beyond. That's why I'm creating the platform Avelx Academy. Avelx Academy will allow us to grow and collaborate courses together rather than me creating it. We can do it together. We can have a community where we can go if we have troubles and problems. And I'm also offering completely free when you sign up to cheat sheets, extra information, extra blog information, extra tutorials, podcasts, and other things that will be available through the platform. So sign up today with Avelx Academy. Hi guys, I'm so impressed at the fact that you've come through this. Now, if you've cheated a little bit and maybe you skipped a little bit, or maybe you're just taking this as a refresher from taking the course, you know what? Thank you so much, and thank you for going all the way to the end and even seeing my big ugly mug at the end of it, because it's fantastic. You know, you really have put out, or you've invested your time in this product, and I hope that you will continue to invest your time with Avelx and invest your love in our community, in the vibrance that we can bring. We've got a Discord channel, we can chat together, we can build courses together, we can have fun together, and it'll be me building a lot of these things, don't worry. But I want to know from you, I want to get to know you on a personal basis, as well as just building things that are more valuable to you and who you are. I can also do assessments as well. Sometimes people ask for stuff, but in reality, they don't need that stuff. What they need is potentially me to look at what they want to achieve, and then I can come up with the content that I think is mostly relevant to the community and will engage us all and bring us all up, right? Software development is not one of those industries where we have mum and pop recipes, and as soon as you get rid of mum and pop recipes, it's valueless. No, the development community is all about just like sharing, right? Okay, if you can share and continue sharing over all of these things, this is evergreen, right? This is evergreen stuff. It's never going to end. You know, people say, oh, well, what if there's more programmers out there? So what? There's more websites out there. There's more websites now than we know what to do with. In fact, I know for a fact that tomorrow, if I wanted to drop this and go into a career, I've got so many companies I can just phone up and say, can I get a job? The answer will be, yeah, of course. And they will hire me right then and there. Just my prior employers, as well as if I want to go get a new job, I know I can do it. I've got the full confidence that I know I can do it. So that's where I want you to be in your career. It's kind of like, if you don't suit me, I can go anywhere I want to. You can go remote, you can go around the world. This is really the only type of job that is fully remote that's pretty good. There's other jobs like marketing, things like that, but programmers, we can be fully remote. Why do we need to drive in? Yeah, I'm trying to sell a lifestyle here that's greater. If you're making 50, 60,000 pounds a year, right? You want to be able to drive on those sunny beaches and you can still work at the same time. You can holiday and work at the same time. You can travel, you can experience the world. You don't have to be stuck in a 2x4 tiny little box office. And we need to take these employers and say, no, I want to live my life, but I want to live it on my terms and live it all around the world. And I think that that is the beauty of this industry. You just started with the Avelx stream, but if you love the content, if you've really adored what we've done here, I'd love you to hit that subscribe button. Go ahead and do it. There's nothing wrong with it. This content will be evergreen. I promise you that I'm going to give you things that you need to develop. And I'm going to give you stuff that I wish, even at the level I am now, I wish I had when I was 20 and when I was, you know, even 15 years old. I was learning this when I was a 12, 13-year-old. You know, I was learning ActionScript back then. I wanted this knowledge. This type of stuff will save you hours of over-research. This thing will save you years. It'll save you years because I knew ActionScript, then we transitioned to JavaScript, and then no one really explained JavaScript, and then it was really boring, so it never kept my attention. Then I had to learn through trial and error process, and you know, we all started back then with jQuery, and jQuery made things fun again, right? jQuery was really fun, and JavaScript was just never fun to me. But now I know the fundamentals of JavaScript, and then you can move on to more advanced things like Vue.js and React.js. Right? These guys make it even more fun to create applications. You can create very large applications in an extremely short amount of time. So, if you want to be there too, join me on Avelx Academy. Join me and support this channel. Don't forget, there is a subscribe button. There is a ding dong bell. And I'm going to thank you so much. Thank you for being here.